delegates, the invited speakers. We again welcome you to the second day of the session on the International Symposium on Marine Energy. Today's session, the first session is on the ocean thermal gradient. This will be chaired by Dr. 𝐌𝐀𝐑𝐈𝐍𝐄 𝐑𝐄𝐍𝐄. Good morning, everyone. Dr. Srikanth is the Program Director and Principal Research Scientist at Energy Research Invited Speakers and 𝐷𝐄 welcome you to the second day of the session on the International Symposium on Marine Energy. First speaker of the session is today's session. The first session is on the ocean thermal gradient. This will be chaired by Dr. 𝐌𝐀𝐑𝐈���𝐄. Good morning, everyone. Dr. Srikanth is the Program Director and Principal Research Talk on significance of ocean thermal energy research invited speakers and 𝐷𝐄. Currently, the registered professional engineer and energy operations staff officer who has served in 3 decades in US Navy warship. Mr. Gandhi operated a 250 kilowatt open cycle low-tech plant after serving as electrical engineer in US Navy warship. He has operated a closed cycle low-tech test system and later a 105 kilowatt ammonia turbine generator. Mr. Gandhi has designed seawater pipelines and performed feasibility studies for deep irrigation cold water system and is a co-author of Mr. Gandhi operated a 250 kilowatt published by the IEC plant. He has corresponded with NIOT beginning in 1998. He has operated a closed CCI low-tech test system and later providing low-tech advice to the United States and Mr. Gandhi has designed seawater pipelines and performed feasibility studies for deep irrigation.
Well, good morning, everyone. Thank you for the opportunity to give this presentation. I'm going to share my screen. Well, good morning, everyone. Thank you for the opportunity to give this presentation. I'm going to share my biggest picture, and I know that, as I understand, some people who are going to be speaking are very familiar with ocean thermal. Other people may not be familiar with ocean thermal energy. So the graphic you see is the ocean temperature at about 10 meters depth. And you can see it's quite warm in the tropics, 28, 29. Biggest picture, and I know that, as I understand, places like Hawaii, about 26 are very familiar with ocean thermal. And the real appeal is that ocean thermal energy. So the graphic you see is the ocean temperature source of solar energy. By that I mean it works at nighttime, it works during daytime, tropics, it doesn't change very much. Biggest picture, and I know that unlike a lot of the other renewable energy, it's also not polluting. And when you look at the general distribution of population versus where the temperature is, by that I mean it's mostly works at night. Because in the tropics, it's mostly for small, crowded islands where there's a lot of people, unlike a lot of the others, or the Caribbean, but most of the world's population is generally China or so on, or population aren't mostly in the tropics. India is, so that's a small, crowded island. And in terms of sustainability, on a grand scale, what ocean thermal energy most is governed by is probably China is how well the deep ocean water is tropics. And there's been studies that probably the sustainable scale of this ocean resource is about the same size as the world oil, which is about 100 million barrels. How well the deep ocean water. So the last picture was the surface temperature. This picture on the right is at 650 meters. It's probably the sustainable scale. So if you look at the graph on the left, you can see that let's say the world oil island is quite warm in the top 100 meters, and then it drastically starts to get cooler, and surface and gradually gets this picture all the way down. So, for example, at 650 meters, the animal is like half. Look at the graph on the left. The Indian Ocean, you can see, is a little bit warmer at a depth, but it's quite warm in the top 100 meters. But we'll talk about that. It's down cooler. At 650 meters, it's pretty about the depth where the cold water pipe is. Several animals at the Natural Energy Lab in Hawaii. Indian Ocean is a little bit warmer at a depth, but it's quite warm in the top 100 meters. So the easiest way to simply have to use it to replace cooling electrically powered refrigeration. The systems that you use to use this cold water, you have to pipe warmer and get cold water, and then you run it through heat exchangers, and you have some pumps. The easiest way to build or data centers or something like that. It's the least complicated way. It's not really transforming any energy. The systems that you use this cold water, typically for the projects that I've shown here, you're going to save about 85% of the electricity pumps. Yes. Not really transforming any energy. The systems that you use. I'm sorry, put more in?
Presentation mode.
For the projects that I've shown here, you're going to save about 85%. You cannot see the full. No, I had it full. Yes. So that works better?
No.
Yeah, okay, that's what I was saying. Okay.
Presentation mode.
For the projects that I've shown here. All right, thank you.
You may be having.
You cannot see the full. No, I had it full. So that works better?
You need to stop the screen. No.
Okay. Yeah, okay, that's what do y'all see right now?
Now it's not unchecked.
All right, thank you.
You may be having.
You cannot see the full. No, I had it full. So that works better?
You need to stop the screen. No.
What do you see now?
Now it's not unchecked.
All right, thank you.
You may be having. Maybe, or at least you have to keep it in this. Yeah, not it. You can share the screen or put it in full presentation. Yeah, not it.
What do you see now? Do you see the slides?
No, not it.
Okay, I'm seeing the presentation.
You can share the screen. No, first just share the screen. And then you put it into the.
What do you see now? Do you see the
full
slides?
presentation mode? No.
Yes, so there's sharing the screen. And then that should be the slideshow.
Make sure the first is share the screen that you are sharing. Then you put it into the.
What do you see now? Yes. So do you see the slide that says seawater air conditioning?
I can see the slide, but it is not in the presentation
That
mode.
should be the slideshow. Still just in PowerPoint
Make
mode.
sure the first is share the screen that you are sharing.
Sorry for the delay. Yes. So do you see the slide that says seawater air conditioning?
I can see the slide, but it is not in the presentation
That
mode.
should be the slideshow. Still just in PowerPoint
Make
mode.
sure one suggestion is share the full screen instead of just the window.
Yes.
You can minimize all other open files and one.
Yes, so I'm not sharing the entire screen. Still just in PowerPoint, so okay, good, let's do that.
Instead of just the window.
Yes.
Okay. You can minimize all
Should
other
have just gone back.
open files and one.
Yes, so I'm not sharing the entire screen. Okay, so you should see a side that says seawater aircon.
Yes.
Yeah, very good. So, okay. So the picture on the left, that's the city of Toronto, and that system was installed in 2002. It should have just gone back. 3 pipelines, each 5 kilometers long. Okay, so you should see a side that says 1.6 meters in diameter. To bring cold water to air condition. So the downtown area, that's city of Toronto. And that Toronto is in Canada. It's not very tropical. It was, but you can get the cold water, not very could be only 3 meters. A few years after that, in French Polynesia, that's Bora Bora on the bottom left, water and condition. That was a small hotel. It started operating in 2006. They have very steep symmetry, cold water, only 3 meters from 900 meters. About years after that, French Polynesia, that's Bora Bora on the bottom left. Since 2001, Mauritius has looked at trying to do it. That's in the Indian Ocean. And then the newest seawater irrigation project is the hospital in French Polynesia again. And that was just last year. About years after that, French Polynesia, that's Bora Bora. This is a screen grab from the new video published by 𝐌𝐀𝐑𝐈𝐍𝐄. And then the newest, so low temperature deep cell. I'm not going to talk about it too much because Dr. Hadasan is up last year. Is up next. But here, we don't have to. The first was cold water only. Now you use warm and cold water. But temperature cell, it doesn't actually vary. Talk about it too much. All you do is cool. Let's say 12 degrees. Next. And so here you have a vacuum tank and heat exchange pumps and forms of seawater. Cold water vacuum such as some of that warm water, flash cold water, and then condense it with the cool water. Temperature cell, it doesn't have vary. Talk about it water, which is a wonderful thing. 12 degrees. And 𝐿𝑇's the expert. The next most complicated way for energy is cold water, that's meaning the cool water and warm water. So now you can make electricity. So that's an impact on the top left. That was about 𝐿𝑇's the expert. 35 kilowatts net. The next most complicated way bar energy demonstration works. Cold water, Nauru built a land 𝐾𝐂 system. I guess it was about 100 kilowatts net. And then on the right was a U.S. Department of Energy funded project using a World War II tank that was modified with heat exchangers in it. And they put a turbine in it. Nauru built that would have been about 1 megawatt net electrical power. And you see on the right-hand side the cold water pipe energy hanging from the middle of the ship. There's the socket where it plugged into the bottom of the ship. And that was 1.2 polyethylene would have been about 1 megawatt net electrical power. And you see on the right-hand side. Later in Hawaii, right near where they used 𝐾𝐂-1, they built a land-based facility. And so where that black arrow is underneath the word 250, that was is when pumps to where the cold water pipe and the warm water pipe came ashore, which was then provided cold water and warm water to the vacuum structure. And they built a land-based facility. That's an open cycle 𝐾𝐂 plant, 250 kilowatt. That was max power rated. Cold water pipe and the warm water pipe came ashore. That chamber is a little more than 10 meters tall and a little less than 10 meters in diameter. It's concrete, and then the turbine, which is quite big, is right below the yellow. About 1% of it would flash steel and then go up into the system. After the steam went up, it would enter the steam attic, and there you see that yellow turbine that was in the top of the tower, and it would enter through those veins, flash little holes at the very bottom part of the turbine here, and go so you can see up into the system, and would spin that turbine. That's a 3-meter diameter turbine, and it was after the steam went up, it would enter the steam attic, and there you see that yellow turbine that was in the top of the tower. So very stable. That was the largest, most stable rotating element in the entire grid up into the system, and would spin that turbine. That's a 3-meter diameter turbine. And after the steam went up, it would enter the steam attic. And there you see that yellow turbine that was in the top of the tower. So left, it was very stable. Farthest left, largest cabinet, stable was the vacuum compressor entire grid up into the system. And would spin that turbine. That's a 3-meter diameter turbine panel. And after the steam went up, it would enter the steam attic. And you can see it into the system. It would spin that turbine. That's a 3. For the younger people in the room, those computers there ran DOS. So then there were some other OTEC plants. There is Korea's barge on the top left, and not very well known because the heat exchangers failed. But on the left-hand side, there are some experimental aluminum heat exchangers considered for OTEC, and still in those are at Hawaii. And those particular heat exchangers did not have very good performance. So the idea was that they might have adequate performance at a low cost, but their performance was not good enough. And then on the right-hand side is the Kumajima OTEC plant, which Dr. Ikegami is very familiar with. So anyways, it's been a successful plant. It's there and doing fine. Later in Hawaii, they built a closed cycle plant using the same cold water pipe as was installed back in 1988. And then on the very top of the tower is the plant you see in the main picture. And so that's a 105 kilowatt system. So the dashed blue line is the size of the skid. You can see there people for scale. The right-hand yellow rectangle is the generator, a standard generator such as you would have on a fishing boat. The yellow square is the reduction gear, which takes the 13,000 RPM turbine and slows it down to 1,800 RPM for the generator. And then the the shiny aluminum cylinder with the arrows going in, that is the actual turbine itself. So you would have the ammonia vapor come up from that angled green arrow, go through the throttle valve. That's the red and silver little zone. From the throttle valve, it would then enter the turbine right at the short arrow. It would spin the turbine, which was about 300 millimeter diameter. And then the vapor then exits through the big arrow. So this system was very responsive. When we designed this, the biggest challenge for the control system was not paralleling it to the grid. That ended up being quite easy. It was handling the case in case of an emergency trip where we may open the breaker and lose connection to the grid. Because it's such a small responsive turbine, the concern was that it would overspeed. And so the way we handled that, because the valve could not close fast enough. And so the way we handled that was basically with an electric brake with some resistance heaters. If there was an emergency and we had to trip off from the grid, then the power would be a high overview. I'm going to cover some projects throughout the world. And so we've had the opportunity to see some that worked out well and also some that never even really got started. And so I have kind of these 5 attributes on if a project can go ahead or not. And so as an example, you see here Bora Bora in French Polynesia where the little green circle is. And so these 5 attributes seem to work in terms of being able to predict if you can go ahead. One, you have to have a good seawater temperature, warm and cold, at not too far away from where the customers are. Second, the load needs to be big enough that you can generate enough revenue to make up for it. I often use the example of ocean thermal energy is kind of like a dam. Hydroelectric dams are often it's a lot of infrastructure, and so it takes a lot of money to get started. But then afterwards, you have a lot of control of the product, and it's not an intermittent source. You have to have regulators who are supportive of the project, or also some sort of a zone, like maybe if a marine protected area is right near there, then that may be a problem. The sales price of the product you're selling has to be valuable enough, or you need to be able to get a subsidy. So, for example, for Bora Bora, it was a very small hotel, only about 440 tons of cooling to be provided. However, in French Polynesia, the government will subsidize capital construction as a way to try to keep jobs in French Polynesia. So they could apply for a subsidy because by having this system, it helps them run a hotel, which helps them keep jobs. And then lastly, you usually have to have somebody who will be the champion of a project and will provide all the information that people need and generate the enthusiasm from the regulators and the other people who and the financiers. Honolulu seawater air conditioning is kind of another example. There was, for 8 or 10 years, people were trying to provide seawater air conditioning for downtown Honolulu. They had a pretty good seawater temperature difference. The customers weren't too far away from that. The load was adequate size. The government regulators were reasonably willing. The sales price could have worked. And there was some leadership. But in this case, the system, the marine pipeline was not that expensive of this, not a very big portion of the whole total cost. The most expensive part of the system was trying to distribute the chilled water throughout the downtown Honolulu area, a well-established city with all sorts of utilities and pavements and streets. And so that was what was driving the cost. So with those 5 criteria, here's a lot of the projects that use deep, cold seawater around the world. So Toronto, up by Canada, in a lake, meets all those attributes. They had cold water. They had a customer base very big. Toronto, unlike Honolulu, already had an established chill water network through the entire downtown. What they were able to then do is just get the cold water from the lake and use it instead of a centralized banks of big chillers. Cornell University, same thing. Jamaica is a place we looked at, and there just wasn't enough hotels for cooling close enough to where bathymetry was suitable to get cold water. There wasn't enough customer load size. Baha Mar is a similar hotel in the Bahamas that never really took off. You were able to get to quite deep in about a 6-kilometer pipe, but there was never quite enough financing to make it happen. Vieques is an island near Puerto Rico, was considered for OTEC, and bathymetry was very good. but the economics didn't work out. Grand Cayman has been considered for OTEC and never had enough customer size. Mini OTEC is green, because I'll say that one worked. OTEC 1 worked as planned. The open cycles 250 Algoods, we talked about. The 105 we've seen. Honolulu SWAC we've talked about. I'm going to skip Minispar for a minute. Bora Bora Hotel was a successful project. In fact, the hotel owner did it again with another small hotel called the Brando. And then most recently is that Tahiti Hospital, which probably was large enough that it did have good economics. Kumajima is the OTEC plant by Japan. As I understand it, the primary mission of that cold water pipeline was to provide water for aquaculture, which has been very successful. Cresso's barge worked good, but I think it was kind of during COVID. Kiribati hasn't quite happened. That orange circle is representing Tumon Bay, another example of not enough load and not enough willingness of regulators to have several big hotels be able to share their load and then put the cold water pipeline through a marine protected area. The 5 low temperature thermal plants in Lakshadweep Islands have been successful. After all, you built one and you liked it enough that you built more. And then Diego Garcia, which is a small U.S. military base on a British Indian Ocean Territory island, has been looked at for OTEC 3 separate times that I'm aware of, at least. And each time the finances just didn't work out well enough. And so, and then the other one, that platform on the right, that's something we're doing with Argonne National Lab. The idea is in the Gulf of Mexico is the potential to maybe put a small closed cycle OTEC plant and attach it to an already existing or potentially new semi-submersible oil platform as a way to make electricity to charge, to look for methane leaks from old sealed wells. But I think the Gulf of Mexico is kind of, in the wintertime, it's a little too cool. The surface water is not very cool, and it's also a very small plant, so the economics won't really work out. So what we've seen is that really the biggest systems are the ones that are profitable. The pipeline in Hawaii and in Kumajima are providing cold water for other high-value products. In the Lakshadweeps, you have potable water. It's, depending on how much water there is, that's very valuable. And then, then the red just is either were things that didn't work out or never really happened. So what I call the mini SPAR was a study in Hawaii funded by the Naval Facilities Engineering Command. It was a multidiscipline study done in 2010, 2011 to consider OTEC at a small scale to prove the technology. And it was a very nice study. We had a lot of good teammates. It was led by Lockheed Martin, a large defense contractor, with excellent participation from companies, the oil industry in the Gulf of Mexico, and heat exchanger companies, a turbine company. It was a really good team. And you could see the SPAR was, which you see on the left, and also floating horizontally on the right. And the intent, and this has been done numerous times with oil SPARs, is you tow them horizontally, or you can transport them on a big ship. And then once you get it on site, then you flood it such that it floats vertically and you have a nice stable platform. But fundamentally, the mini SPAR project didn't continue because it didn't generate enough revenue and it was very expensive. I mean, you can see there the long distances to bring it to Hawaii. And the mini spar was kind of limited by how much power we could make, because at the time in 2010, the biggest cold water pipeline that we could get was a 2.5 meter pipe. So the study that we're going to do for NIOT is essentially to look at how we can do using bigger pipelines. On the left, you can see OTEC 1 with little 1.2 meter pipes, and how that looks different if you use these new pipes that have been invented by 𝐈𝐍𝐄. It's the same basic material, but with a lot of improvements in the chemistry, we can make the walls of the pipe much thicker as it cools. And so this is a project that's funded by the U.S. Trade Development Agency. And so then we've also, PCCI has assembled a multidiscipline team, and we're going to consider it. So the team that we have to do is Tough Offshore, which is an Indian process engineering company and offshore design contractor, heat exchanger company, the American Bureau of Shipping, a turbine company, and then the assets of PCCI, naval architects, and ocean engineers. So the idea is to adapt a lot of the components from the much more expensive NAVFAC study and apply them to Andaman and Great Nicobar. Great Nicobar would be about the 5 megawatt system, and then Andaman would be the big system. And so the site there, it's actually got more temperature difference than Hawaii has, and a much shorter mobilization. And then there also is a subsidy, because most of the Andaman Island grid is powered with diesels, which are one of the more expensive ways that you can generate electricity. And to me, this is one of the most interesting and exciting parts of this study, is that the owner is not some small government of some small island. The owner would be the government of India under the leadership of NIOT, who are the most experienced government agency in successfully using cold water. So the tasks of the study is to come up with a model of, a computer model of the power module, and then also a computer model of the seawaters and the hydraulics, because a big part of an OTEC plant is you have to generate enough electricity to pump the water, and then the net electricity is then what you sell and have revenue from. And it typically works out to about a third or 40% of all the power you generate. All the power you generate we call the gross power, and then you subtract out the various pumping that you've just had to do, which is 33 or 40%. And so then you can sell the other net power. So then we'll also have a layout of how we can put it into a spar. We'll look at the sea keeping of that spar using the on-site data. We've got the temperature and the bathymetry and the waves. We have 𝐈𝐍𝐄, the inventor of those biggest pipes. That's an unusual factory they have. They can make the largest pipes of any of the polyethylene pipe factories in the world, and such that we can come up with a cost estimate and do a financial model of it. And compared to the Hawaii project, it's only 800 nautical miles from either India or from Lake Johor. So here's a view of Great Nicobar. That's a 1 degree box. So we were looking for environmental data around there. And the deep portion is over on the eastern side of Great Nicobar. And it's about 15 kilometers deep water. So that means that the power cable would be about 15 kilometers long. And then here is the site on South Andaman Island near the city of Port Blair. So it's farther. If you look on the right, it's quite a bit farther to deep water. It's about 50 kilometers, but this is a significant size city such that it could easily handle 16 or 18 megawatts of renewable power. And then, so you could run the diesels less. So the amount of fuel needed would go down. But again, this is just a fraction of the total power need. So this is the base load that we could provide to Port Blair. And in the Andaman and Nicobar Islands, there is a significant subsidy paid by the government because of their using diesel. So they actually charge ratepayers an average of about 10.2. That electricity is 36 rupees per kilowatt hour. So that's essentially a subsidy that the government is providing. And it's been reduced from a couple of years ago when we started this. And so the hope is that because of that big existing subsidy, that an OTEC plant of this size can be large enough to be economically feasible. So here's what it kind of looks like, using some reasonable assumptions. So on the left-hand side is the revenue from 16,000 kilowatts. And if you assume the plant runs 90% of the time, that's the plant availability. And so if the cost of supply is 36 rupees, which is about 40 US cents, so 0.4 US dollars, then the revenue that you generate is about $50 million a year. So from that, you got to pay your operating and maintenance, which is mostly maintenance. You're not buying fuel. And then you've got to repay the bonds that you issued to pay it back. And so then on the right-hand side is the economics table from the International Energy's Ocean Energy Systems economic study just done last year under the leadership of Dr. Jalal. And so here in that table from that study, they've talked about either 10 megawatt size or 50 megawatt size closed cycle. And so if you look at the 10, it's about $27,000 per kilowatt. But then with the same technology for a bigger plant, it's about 16,000. Well, we're talking about 16 megawatts or so. So we're kind of in between what it could be. And so you can see that the rates get a little better. We're at about 40 cents. You know, the revenue we're generating is about 40 cents per kilowatt hour. And so that is in the range of what could be. Like I say, the subsidy has just gone down. So in terms of the 5 attributes for success, do you have an adequate seawater differential temperature and distance? Yes, we think so. Do we have an adequate size of load? Probably 16, maybe. Probably for the 5 megawatt, that would be a smaller size system. That would still be non-economic, but it could be a technology demonstration. 16 megawatts, now that we have these big new pipes that are available, we probably are very close to being able to be economically feasible. And what really that means is if they paid a subsidy for diesel, that money literally goes up in smoke. Whereas if we do OTEC, if we take that same subsidy, you're repaying the government for borrowing the money. So that's very attractive compared to just burning it. The willingness of regulators, well, we'll find out when we get the study done. The sales price subsidies we talked about. And then I think in terms of the leadership, this is an ideal agency to do that. The study we got started in spring of 2024. NIOT has gathered the data that we've asked for. And then since then, we have a new government administration in the United States. So foreign studies are currently paused. And so that's the status of the plant, and I'm happy to take any questions. Is anyone there?
Thank you, Patrick. Yeah, sorry, my mic was in mute. Yeah, thanks for this techno-economics sharing. Also giving us a good overall understanding of the various projects around the world. So it's very interesting to see that as a project sizes scale up, the levelized cost of energy and also even the capex and other are significantly reducing in cost in that way. I remember like even at some of the Caribbean islands, the French also were looking at Martinique with the floating 10 megawatt kind of systems, etc. So how do you see from the environmental impact assessments and other, as the size becomes bigger, what kind of challenges come up, and what is a kind of advisable size from an EA standpoint?
As the sizes get bigger, I think you have two things. One is you're taking the warm water in and cooling it down abruptly and moving its location. So you have all the same issues with entrainment of marine life that you have with any big power plant that's using water for cooling. So that basically means you need to keep your inlet velocity slow, and there should be a screen. So, and what I understand is you try to keep the velocities less than 0.15 meters per second. And that the reason is that the big fish can swim away from that, and the little fish are going to get caught at the screen, so that the little fish don't get entrained. If you try to intake your water in faster than that, then you start entraining the little fish. And then the other environmental impact, its potential, is the deep water is nutrient rich. And so when you discharge the deep water, and we've done some studies on this, I think that the easiest way to have the regulators approve it is you discharge that slightly warmed up cold water that's nutrient rich. You discharge it in a downwards direction towards at least the bottom of the photic zone, so that you do not create an algae bloom. There's been studies in Japan to try to use that for natural upwelling and thus improve productivity of the ocean. But I think from a permitting standpoint, it's probably easier. But it does depend upon the regulators.
Okay.
But that also, I think, impacts the design of the plant. One of the reasons we're using a spar is it's also a convenient way to get that discharge water downwards. Whereas if you use a ship shape, then the discharge water is still kind of near the surface.
Also from this technology or park scaling, compared to that of the wind industry, the uppermost limit is like 25 megawatt, the offshore wind turbines. That's what DTU came up. Whereas in this OTEC, as you see, now you are talking about 3-meter kind of diameter as we approach like in megawatt scale. So how does the materials limit this scaling like today? Or we need to go for composites and other for these pipes from the high density polyethylene pipes? Do we need to move to other structurally resilient materials?
That's why I really like polyethylene pipes for that reason. It's non-corrosive, it's flexible, it's strong, it's a commercially available product. So there have been studies with a more complicated fabrication of syntactic foam and fiberglass that was done in the 1980s. And that's appealing, and you could potentially make that even bigger, but the cost was very expensive. And so the polyethylene is a way that, it's been done before, and we're confident that polyethylene is probably much less expensive than fiberglass. There's been a lot of studies done with different materials to make large seawater pipes. We've looked at steel. After all, a lot of things are made of steel in the ocean. That didn't look too bad at the big sizes. Concrete's been discussed, and concrete isn't a very good application for this. Concrete was discussed a lot in the 70s and in the 80s, and the idea was kind of the gravity-based platforms built in Norway. But those systems were designed to sit on the bottom, and so the concrete was loaded in compression. When you try to hang a concrete pipe from a floating plant, since it's loaded in tension, it's just not the best use of concrete. You end up having lots of steel with a concrete paint, and it's not a very good paint. So of the various materials that are easily available, I think polyethylene is the best right now.
Okay. Yeah, thank you. I will open the questions to the floor. Is there any technical questions or techno-economics questions? Mr. Patrick? Okay. Okay, thank you, Mr. Patrick. Yeah.
Well, thank you. I hope you have a good conference.
The audience will be writing to you. Yeah, thank you.
Thank you, Mr. Patrick. A very informative talk. And unfortunately, we cannot provide you with the memento. But thanks again. Going forward, our next speaker is Dr. G. Venkateshan, Scientist G from NIOT. His talk would be on efforts on OTEC-based desalination at NIOT. Dr. Venkateshan is Scientist G in Energy and Fresh Water Group at NIOT. He has almost 2 decades of experience in design, development, and operation of LTDD plant implemented by NIOT. He is currently the project director of Vertical 5 of Deep Ocean Mission, and is also coordinating the implementation of the first ever project on OTEC power desalination plant at Kavaratti. His area of work includes heat exchangers, OTEC LTD process cycle, seawater pumps, and marine energy systems. Thank you, sir.
Usually in many of the colleges, I used to go for a lecture. At the time, they may ask me the topic. At the time, I used to tell the different techniques in desalination and different techniques used in DC water, those kind of topic. But here, first time, they forced me to speak on this topic, because there is a slot in that one. And it seems that Madam told asked Venkateshan to speak this way. Thank you very much, Madam, to give me an opportunity to share my working experience in NIOT with you. This presentation mostly about the R&D content, so that it will be helpful for the student communities. This will be mostly about the R&D content. Here, your speaker talks about the various locations and what is the assessment and what are the locations where those kind of water plant and all installed and what it is capacity, those kind of things. And this is the out of ocean and marine renewable energy. We can see the wave energy, ocean current energy, tidal energy, and ocean thermal energy and solar energy. Out of all these energy available, if you can see already the wave energy, ocean current energy, tidal energy spoke a large amount of resource assessment and what is the present situation yesterday. And the topic that I would like to tell about here is the ocean thermal energy and the solar energy also. Why I selected the solar energy also, because yesterday Dr. P.K. Professor told that you have to desalination some amount of water from the solar energy. So why OTEC is required for an India? Because India being a well-placed tropical country with very rich water resources. And yesterday, Dr. Sujit Joseph told that about the estimated water resources in India is around 3,200 megawatt of installed capacity, and India has a large cost capacity. So water has its own potential. So I have classified my presentation in such a way that water, first let me explain about what are the efforts that we have incorporated in an offshore desalination plant. And later onwards, I will speak about the NIoT efforts in the land-based desalination plant. Again, the VOTEC system consists of two systems. One is open cycle and closed cycle. NIoT has made a large amount of effort to design and increase the efficiency of both the open cycle and the closed cycle system. First, the principle here is it is known only when the it is economical only when the temperature difference is around 20 degrees, and it has a low thermodynamic efficiency of 2.5 to 3 degrees centigrade, and hence it requires a high heat duty of nearly 40 times gross power. Yesterday, one of a student from IMU, second year student, asked about what are the efforts that we have taken for the increasing the efficiency, that I will present in the later part of the story. So this is the open cycle turbine where the working fluid is the water vapor, and in the closed cycle, the working fluid is around the ammonia vapor. What are the advantages and limitations? It has a low thermodynamic efficiency, and hence a large amount of seawater flow rate is required. And the other benefit is air conditioning, aquaculture, and fresh water. And it is mainly ideal for the island and mid-sea mining. Yesterday, our director told about the mid-sea mining. So if it started the mining of polymetallic models, what you mentioned is black color laddu is coming and crushing and bringing it to the surface. So if that commercialization starts, where we need to get the generation of energy and as well as the fresh water, the only source is the generation of energy and the fresh water. This is the first experimental water plant that we have established in 1999. Of course, Dr. Raju Abraham and Pioneerpan and many others are there who have done, because this water started before I joined in National Ocean Technology NIoT. So large amount of efforts we have mentioned, and this is the one experimental desalination facility, and later on was refurbished and become a state-of-art facility in a lab scale model. That is, students, most of them who are interested to do the experimental setup and who want to do the research and analysis can make use of the open cycle water and as well as the closed cycle. The experiment, a large amount of we are having a heater and chiller, so that large amount of experimental studies in order to do the optimization. This is essential when we are doing a smaller scale capacity. We don't record that much of optimization. When we are going for a higher scale capacity, definitely we need to do a large amount of research work. So first, let's afraid about the offshore-based desalination plant. In any of the system, we record the power module components and the cold water pipe and the push bar. For example, for the offshore desalination plant alone, a platform to support the problem. These are the major subsystems required. So you can see the 𝐷𝐿 Sagar City. This is the first desalination offshore water desalination plant that was established in National Ocean Technology, and its length is around 72 meters, and width is, it has 3 moon pools and retractable cold water sump. You can see the large amount of retractable water, cold water sump to meet the net positive suction requirements of the sump. The baseline design is the 1 megawatt, and out of which the net power that we are expecting is around 605 kilowatt, and we can see the warm water flow at that time is 2 tons per second, and the cold water flow rate is around 1.5 kilo tons per second. These are the various plant components. It consists of evaporator, condenser, turbine condenser. Here, these are some of the plant components you can see here. This is an after condenser, heat exchanger, and 4-stage axial flow turbine. And when we are doing the design of the heat exchanger that are supplied from the alpha level and the condenser from the Sondax, we can see at the time it is the largest heat plate heat exchanger that is supplied to the NIoT. And we are also interacted with the Saga University, and in order to increase the heat transfer coefficient. So this is the cold water sump in order to meet the net positive suction rate requirement of around 5.9. So we need to lower the full cold water box in the 𝐷𝐿 Sagar City. To operate the plant in the sea, we need to lower in order to meet the net positive suction rate requirement. And when coming to the surface, we need to increase the level. You can see the ammonia pumps. This is the cold water pipeline. And this is a single point moving system that is incorporated in the water desalination system. So the NIOT experience that is established here is we have completed the subsea system qualification, operation of 1 megawatt turbine with ammonia as the partial load condition, and operation of all seawater pumps. And of course, we have deployed the cold water pipe deployment in the mooring system. But however, the connection could not be done due to the lack of sufficient infrastructure and bad weather. And so even though we attempted a large amount of efforts have been put, finally the connection could not be done. And so we have gone to a much lower level of showing desalination. So this is using this BOT Sagar Shakti, we have replaced all the plant components in desalination plants components, and we have successfully demonstrated a 1 MLD barge motor desalination plant at 800 meter water depth from the shore. This is the first time a 1 meter diameter of the 750 meter long cold water pipeline has been deployed at half a noon, and we have successfully generated 1 MLD of fresh water. Now, after demonstrating a 1 MLD barge motor desalination plant, we have got a large amount of experience, and we are now in a stage of doing the detailed project report of higher scale capacity. So it consists of the open cycle plus one as well as the closed cycle in order to follow a commercial exploitation. So this consists of two types of cycle. One is open cycle turbine. It consists of 2 modules of 2.5 MLD plant, and another is a gross of 5 megawatt capacity, which consists of 2 modules of each of 5 megawatt consists of closed cycle. So this also consists of the freshwater transportation. Here a pumpkin pipeline has to be laid for pumping of the fresh water from the site to the shore, and as well as a detailed costing also will come. In order to increase the commercial viability of the plant, we also increase putting a hydrogen or ammonia generation plant, so to increase the commercial viability. You can see the sizing of the open cycle and closed cycle. Its capacity is around 5 MLD capacity. You can see the warm water flow rate requirement is 16 tons per second. You can see the flash number condenser and turbine are record of 16 numbers. So coming to the closed cycle water turbine, again it records here 4 numbers of the evaporator and the condenser, and which is the turbine models of 4 numbers. And you can see the E2T of coming around the 600 watts per meter square. Earlier the evaporator, since the alpha level or any other heat exchanger manufacturers are not ready to design as per our requirement. So in the presently we are in the detailed project report stage. So what is available in the market only we can shoot, and this is one of the major limitations that we are finding the limitation in doing the detailed project report. You can see the evaporator itself 56 numbers and condenser of 48 numbers, and the turbine is coming around 4 numbers. So apart from this one, the detailed project report, we have also done some consultancy services of the Shell. Already Madam has explained about this one. So this is the 2 megawatt open cycle, closed cycle water turbine. So this is as a scaling tool also we have supplied to the Shell company. So other than that, right now we need to demonstrate a small scale prototype generation of energy and fresh water. So this is consists of the open cycle and as well as the closed cycle. Open cycle of 1 lakh liter per day, and the grass is 100 kilowatt capacity. So both the modules that we are going to put it at deeper water in the open sea trials of more than 1000 meter water depth, and we are going to demonstrate. Right now, we already floated an expression of interest. Few companies have shown that deep sea water, which is around 40 kilometers away from the shore, we record a platform to house all the plant components. So when it is going to an island community where we can get a 10 degrees centigrade or 15 degrees centigrade, if we go away from the 350 meter or 450 meter away from the seashore, we can get a temperature difference of around 18 degree or 20 degree temperature difference. So in all the islands, mostly in Kavaratti, Agathi and Minikai, and in some of the islands, almost 5 islands, right now, the plant, LTD plant, we are establishing at Androth Island. In all these places, we have established a 1 lakh liter per day capacity. And in some of the islands, in 6 islands, we have also demonstrated it is in a working condition of 1.5 lakh liter per day capacity. Because all these plants need to generate fresh water using the power driven from the diesel generators. So the power has to be transported from the diesel has to be transported from the mainland. In order to make a self-sustained desalination plant, NIOT is in the process of establishing a 1 lakh liter per day, which is self-sustained desalination plant. Out of that, there are two options are available. One is the open cycle and another is the closed cycle. A large amount of debate has been undertaken to first initially need to make a open cycle and as well as the closed cycle, or first the closed cycle or open cycle. But here the water requirement plays a major role for the island. So initially we have started for the open cycle because of the working fluid is the water vapor, which is not an environmental beginning, and operating conditions is very favorable and turbine also to be operated. And first initially we will be operating and successfully showing the open cycle. Then afterwards, after getting the water of the sufficient quantity, then we will be demonstrating a closed cycle. Here a large amount of experimental studies and large amount of innovative ideas we have incorporated here in the open cycle. Unlike in the low temperature thermal desalination plant, whereas established innovative idea was incorporated here in order to reduce the environmental impact or in order to increase the more environmental friendly desalination process. In all other places, sump is required at 5 meter water depth, so that the pump need to be put at 5 meter water depth and the pump need to be transported from the deep sea cold water to the surface. This is more environmental friendly when compared to the LTD plants, because in all the desalination plant, warm water and cold water we are taking at the respective places. For example, warm water we are taking at 5 meter and discharging the water at the surface. But in this water desalination plant, we are taking the water at the surface level and discharging at higher depths. So in that way, this is a more environmental friendly process. And here it has a unique area. Don't need to have a trestle, or most of the offshore work has been reduced. And it requires trenching to only for the cold water pipe requirement. So these are the configurations that we have incorporated. Here the sump is constructed at the shore, not at the offshore region. So you can see the warm water sump and cold water pump and discharge sump itself. And the water is taken from the flash evaporator to the respective and discharges to the sump. So in order to remove all amount of the sump and the trestle, we need to find out a reliable and accurate method of hydraulic losses. This plays a major role in seeing the success of this the cold water pipe coming to the surface level. For this to happen, we can see large amount of studies need to be taken. Earlier in the studies, we have seen that in the island desalination plant, the warm water pump is around, when we are designing for the Menica Island, the pump head is coming around 3.5 to 4 meter head. And for the cold water, it is coming around 5.5 to 6. But here, for the Vortex cycle, we have reduced the warm water pump requirement yet as the less than 3, and the cold water 5. Why? Because of the in order to find the accurate method of drawdown losses. So previously this method, what is the difference in the density and what is at the top, we have find it out. And using these two temperature difference, the pressure is density is a function of salinity and temperature. And we have not considered the pressure. But when the water, cold water, deep sea water coming to the surface, we have also considered a pressure, and we have also put it in the equation, and we have observed that the drawdown losses is drastically reduced. By using these two, this one, the cold water temperature, those are the specific energy consumption of the cold water could also be reduced. These are the sum of the plant components, flash chamber, condenser, and all transported to the island places. Now using the cold water pipeline configuration has also been completed, and right now this is in the giving the order. Now this cold water pipeline, you can see this is 4 kilometer long. Unlike in other LTD plant, what we need to put is around the 850 meter or 1 kilometer long in order to get a lesser temperature difference. But if we want to get a temperature of around 8 degrees centigrade, we need to go for a higher water depth. So it's required a 4 kilometer long cold water pipeline, because it's not economical when the temperature difference is large. This cold water pipeline configuration, all the experts are there, but in order to fulfill the requirement, when we are putting any object in the sea, it consists of the horizontal load and the vertical load. The horizontal load comes to the vertical load comes to the buoyancy. This is a positive displacement pipe, which consists of around 40 tons of buoyancy. So we need to add 40 tons plus hydrodynamic wave forces of around 10 tons. So we need to add 50 tons of weight in all along the cold water pipeline. And it is an inverted catenary shape. Due to that, the surface current and the current maximum is available around 200 meters from the shore. So due to which the clump is required in order to arrest the lateral displacement. So we are large amount of clump or around 55 tons weight is required. So just I'm telling you what is the quantum of the work that we need to put it this one. So far in all the desalination plant, we have used the submersible pump which requires to draw the water from the deep sea or warm water. It requires to overcome the density difference losses and as well as the submersibles. That is the submersible required for it. But any type of pumps, whether it is a centrifugal pump or other horizontal centrifugal pumps, also which has a high efficiency pump can also be incorporated here. So you can see the earlier that the MPSH requirement, you can see for the 5 meter yard, it is required around 3.27 meters. But according to the MPSH available is 8.37. So we can very well use the horizontal centrifugal pump which has a high efficiency pump. So you can see some of the pictures that are taken from the earlier scene without the use of now we are going to put a pump in the plant structure itself so that the specific energy consumption that is required for the pump can also be reduced. Now coming to the solar desalination, let me tell about why we require a solar desalination for the island desalination plant also. Here there are the parabolic trough and tower and the linear fluxional reflector are all shown in this slide. In order to, we can select any type of dish and collector system to increase the temperature difference. So this is the solar desalination plant that we have already, with the help of the 𝐾𝐑𝐈𝐍𝐄 or industry participation, we have given a technical support to establish the plant at a 6 meter cube per day capacity, 6 meter cube per hour capacity. You can see some of the plants that we have already planned. It consists of the solar fields and as well as the CC effect multi-effect distillation system. It consists of 1,400 meters square, and this is the CC effect. Here the rays that is coming from the reflector goes to the transmitter absorber tubes where the water gets heated up, and due to this it gets a pressure of around 20 to 25 bar pressure with 20 to 70 degrees centigrade. So these are all some of the multi-effect system where we can increase the temperature difference, and these are the thermal vapor compression system in order to increase the efficiency. So we have also incorporated here. Usually the thermal, the specific energy consumption from without using it is coming around 2 kilowatt per meter cube. But if you can see the specific energy consumption by using the thermal vapor compression is 0.8 to 1.2 kilowatt hour per meter cube. That is what incorporated in the solar desalination plant. Now, how to combine the solar desalination plant with the now, if you see the water alone, if you want to establish for a plant at island. So if we want to put an open cycle water so that the fresh water can be generated in the open cycle. Now, if we want to put the closed cycle so that the power can be generated. Now, when we are want to how to power the how to drive the desalination plant at Agatti. For example, it is drawing the water at around 12 degrees centigrade and 12 degrees centigrade. And how to power, when we want to draw a temperature of around 8 degrees, the bathymetry in such a way that we need to go for a higher water depth. So the bathymetry shows that nearly 6 kilometers of cold water pipeline is necessary. So if you want to put out a 60 kilometer cold water pipeline, the cost is abnormally increasing. So only for 4 degree temperature difference, whether we need to go for a cold water pipeline of 6 kilometers. So in order to that, we can increase the efficiency of the flow cycle by increasing the heat that is coming from the warm water and goes to the before going to the turbine. Thereby, the superheating temperature vapor can be increased. You can see this. Some of the students asked about what is the ways to increase the Rankine cycle principle, and here they can see the Carnot cycle and as well as the Euler cycle, which consists of both the thermodynamic performance when compared to the Rankine cycle in terms of both energy and the exergy efficiency, as it uses the ammonia and the water vapor mixture. And you can say how the Carnot cycle is better when compared to the Rankine cycle. I will explain in this way. First, assume that there is no other working fluid here. See, if you can see the Rankine cycle principle here, the T3 is the T2 to T3 temperature is there going to the heat input, and the T3 to T4 is the condenser output, and this is the heat rejection process. But same in the TS diagram, you can see the average temperature is going from this point to this point because some amount of heat is added here. See, for example, when the ammonia vapor mixture is coming around 70%, 70% by addition of weight, you want to condense the 70% of ammonia vapor, we need to draw a colder water temperature. You can see a colder water temperature need to be drawn. But the cold water temperature you cannot draw because of higher water depth. So what we are doing here is some amount of leak solution we are adding. For example, the 30% of ammonia is added in here 70%. So in order to increase the solution, so that it becomes as a 40% of ammonia solution, so that the same temperature difference can be effectively used to reduce the to vapor condensation. You can see the vapor in the phase stage process take place. You can see there is a shift in the warm water heat addition, and as well as the heat that is going to the atmosphere is wastage. So it is going to another heat exchanger where it gains some amount of the heat that is incorporated in a recuperator process. Thereby, the efficiency of the Rankine cycle is increased by incorporating the Kalina cycle and as well as the Ura cycle. These are the cycle, just modified version of the Rankine cycle and Rankine cycle. So, if, for example, the Rankine cycle is 22.5 to 3%. If you go to Kalina cycle, the efficiency is increased by 1.5%. And by Ura cycle, you can see the efficiency increased by another 1% depending upon the temperature difference. So you can see the combined cycle of the Ura cycle with the desalination process plant. So that is the one way of increasing the efficiency of the cycle alone. The other way to increase is to increase the temperature that is available in the ocean of around 22 degrees centigrade. You can see the collector efficiency and as well as the net generation when compared to the heat available. Using the effect of the available temperature using the ammonia generation, you can see. So, for example, most of the heat will be used for the increasing the evaporator as a pre-cooler, pre-heater. But when we heat the water vapor, the ammonia vapor mixture that is coming out, and thereby is the collection area required will be nearly 60%. And further to that, we are not destroying the environmental impact because the temperature that is going to the east is same as previously used. So the solar collector can be used to enhance the superheating of the vapor that is coming from the evaporator itself. So instead of going for a high efficiency cycle as Kalina cycle or Ura cycle, what we would like to suggest is the going for a double stage process where we can effectively make use of the Rankine cycle in order to increase the effectiveness of the heat extension process. By this way, less amount of heat exchanger area can be used to increase the power generation and as well as the yield. Coming to the last part is the economics. When we speak about the economics, we are only seeing about the water process alone, generation of electricity alone. We are not considering the power generation and what are the additional benefits. You can see there are a large amount of benefits that is available other than the generation of electricity, other than fresh water, and it is also used for aquaculture. The experiment shows that nearly 24-fold times increase in the phytoplankton basement. You can see the surface sea water and at the bottom. In the 𝐿𝐻 Island, what we can see near to the deep sea water, you can see a large amount of fishes are coming towards you because it is of a nutrient. The literature shows that nearly 50% of the fishes has been increased on the catchment of the island. So this is the slide that has taken from the 𝐻𝐃 for Brahmas. So you can see from 10 kilowatt, 30 kilowatt, 100 kilowatt, the sales has been increased, profit has been increased from 12.3 to 44.5 to 183. The estimation of sales when we are considering the 𝐻𝐃, it's a byproduct. You need to see the electricity as well as water, at least in the aquaculture for the fisheries. So the estimation of sales, cost and profit for manufacturing and setting up an operation and running is carried out for the case of the 10 megawatt and 30 megawatt and another 100 megawatt classes. In addition to electricity and water, the growth of the fisheries also need to be considered when we seeing the economics of the 𝐻𝐃. Otherwise, it will not be comparable. So what are the challenges here? It is such a low thermodynamic efficiency, so we need to go for a larger diameter and as well as the marine infrastructure is required. So the conclusion here is countries like India, where we are always dependent on other countries for our energy requirement, should as much as possible to use the geothermal energy or waste heat energy that is coming from the power plants or condensers or the solar energy should as much as possible utilize. And at the same time, the water alone cannot see the future. We need to see other renewable energy such as geothermal energy or other power plant waste heat or solar heat to increase the vapor generation alone. I'm not asking you to preheat the feed sea water, keeping the cold water as a constant, increase the heat that is coming from the evaporator before it goes to the turbine, thereby the superheating and thereby the dryness fraction also increased. Thank you.
Thank you, sir, for this very insightful and both technical and the economics and to the nation, like what kind of good applications and to the industries, how it could be helpful is well covered in this presentation. So yeah, first I will give the opportunity to the audience to, especially to the youngsters. Yes, go ahead.
Yeah, question from my same Amal Sahi, your name?
Sharon.
Amal Sahi.
So you mentioned that when we take the water from surface level and discharge at the deeper levels, environmental disturbance can be reduced. But generally that will affect the ocean stratification and thermocline, right? So how is that possible?
What you meant to say is when we are taking the water from the surface and when we are taking the surface, the temperature will come.
And discharge at the deeper levels, you said we can decrease the environmental impact. Can you explain how?
So you mean to say that question is related to environmental impact, correct?
Yes,
right?
yes.
Okay. What I told you here is previously in all the desalination plant, most of the desalination plant that we have already established here is there are some is installed. They are taking the warm water at 5 meter or 6 meter water depth, where the temperature is around 28 degrees centigrade only. Okay. Now, in this effort, after doing a large amount of R&D, instead of taking warm water at 5 meter water depth and discharging at 0 meter water depth, so we are taking the water at the surface sea level and discharging at 5 meter water depth. So the temperature that when you are discharging at 5 meter water depth, due to the wave dispersion studies found out that it dissipates the heat at a faster rate. So the algae and some amount of green patches and all we could see in some of the island, that type of environmental impact also can be reduced. We are increasing the more and more environmental friendly. In that way, I told you that it is more and more environmental friendly when compared to the desalination plant.
So at 5 meter water depth, there will be organisms like sea organisms. So they are adapted to a particular temperature. Generally, when we go in deep, they'll have cold temperature. So when we discharge it, the temperature difference varies, right? So what about them?
Yeah, I understood. According to the environmental concerns, we need to discharge the water at a temperature not more than 5 degrees centigrade. When we are making the water at 8 degrees centigrade, let us assume that we are taking the water at 8 degrees centigrade. After discharging at the water from the condenser, it is approximately coming around 12 degrees centigrade. Now, 12 degrees centigrade, according to the environmental norms, I could not discharge the water more at a place where the 17 degrees centigrade. So I'm going to a slightly higher water depth, where the 17 meter water depth is around, for example, 100 meter. I am discharging the water with the 17 degree, that is done. But actually in practice, what I'm doing is, here the cold water and the warm water is mixing. The 17 degree temperature difference is coming to a temperature of around 20 degrees centigrade. So when we are discharging at somewhat approximately some 20 meters water depth, that the temperature is discharging without much more impacting the environment. Further to that, the marine organisms, which you are telling, we are putting a large amount of screens in various stages. So those kind of marine organisms, even if it comes, it filters at the sump itself so that it will go away from the one. It will not go to the plant components itself. And when we are seeing the deep sea cold water, when we are pumping, it comes as a very big fishes. So normally it won't come to the screen itself. And further to that, even if more amount of environmental concern need to be done, the cold water that is piped, no, there itself we can put a screen which has a 10 to 15 mm gap in it.
Thank you, sir.
Any further question? I have one. Ammonia has this health and safety issue. For a human, like more than 24 ppm, they inhale, they have challenge. So is there any other alternative for the working fluid as a low boiling point fluid other than ammonia for this VOTEC?
When we are having the plant at the shore, mostly we will be using the R. Right now, studies are being carried out using the R. Right now, we are doing the open field. We are going for the message that after the water from the deep sea water, using that completely different level, then for the growth rate, it will be powerfully repeating to some mission plan. Now we are studying using our water because we are there. But when we are going for the larger scale capacity and if we are going for your hospital desalination plant, then we will be using the ammonia as the working field. Then we will show also the history is in the lab or the way is where it is automatically and there in the lab also they are
Wonderful. Yes. Thanks to NIOT. You all are doing excellent work in this. Yeah, great. Yeah. Thank you.
At the last, I would like to say, though I have presented this topic, most of the work was carried out by Raju sir, madam, and those kind of. Then I would like to thank all the staff members of NIOT, and in particularly, I would like to thank Mr. Jayamani, Mr. Bharani Kannan, Mr. Venkatachalam, who is no more here now. So I would like to thank those three experts who has done a large amount of efforts from which we could learn from the 1 megawatt water desalination cycle. Thank you very much.
Wonderful.
Thank you, sir. Request chair of the session to present a memento to the speaker. Thank you, sir, once again. We now move on to the last talk of the session on OTEC is from Professor Yasusuke Ikegami. Professor Ikegami is a well-known figure in the area of marine renewable energy. He's currently the director of the Institute of Ocean Energy, Saga University, Japan. He's a pioneer figure in the OTEC development worldwide. In fact, he represents Japan in various international forums related to marine energy. He has researched on the optimization of OTEC system, heat exchangers, the condenser and the evaporator for OTEC, and byproduct for OTEC for 40 years. Recently, he is investigating on OTEC system using ammonia and water mixtures as working fluid and new double Rankine cycle using pure working fluid. He has collaborated on projects for India, Malaysia, Indonesia, US, Republic of Palau, and Korea. His areas of interest include the energy conversion engineering, thermodynamic engineering, heat and mass transfer. Other projects are the anti-fouling of heat exchangers, development of turbine and control system for OTEC system. Professor, you can go ahead now. Thank you.
Hello, Ikegami? Yeah. Shrikant here.
Sorry.
Oh, yeah.
Thank you for introducing me. First, I would like to appreciate NIOT So I have a honorable chance to present Japan's OTEC activities. So in my presentation is a recent OTEC development in Japan. 1,000 kilowatt land-based model progress towards the commercialization. So NIoT and our Saga University. Last year, 25th anniversary OTEC joint research between India and Japan. So I very respect the NIoT to make OTEC history from the NIoT toward a world. So first we joined the OTEC conference, International OTEC Deep Sea Aura Applications conference in Saga, in Mali. So first keynote lecture. So first director NIoT, Dr. Ravindran presents Indian 1 megawatt floating OTEC plant, the overview. So his presentation is a push the OTEC in the world. So they're very important. So then NIoT is make history, the OTEC. So we are very honored to contribute and join this project. So this is my great memories, NIoT OTEC project. So 20 years ago, I am too young, so I take a photo inside the tube. This is a very great history to promote the OTEC in the world. So and this NIoT is leading the technology to desalination as a last presentation. So I respect these activities. So, and 1,000 ton per day desalination plant, I joined it on the board. So very tasty desalinated water. So very historical desalinated water. So I respect these activities. So after success of this project, so this push the OTEC and desalinated project using a deep sea water, so to the world. So after this NIoT success achievement, so this push the Japan OTEC project. This is a Kumejima OTEC plant. So this is the first world first second double stage ranking cycle, and over 5 years continuous operation. The world first longest operation. So this is a 100 kilowatt facility connected local grid, and one of the only two full operation. So and the world first take a long demonstration in the 2 second booms. So Kumejima is a southern Japan. This is Japan and India. This here, southern Japan, Kumejima. Kumejima is a very small island, but this is a leading island in Japan to promote the OTEC. So Kumejima model is not only energy, more than energy. So after OTEC use warm sea aura, cold sea aura, collaborate, contributed another industries, protect coral and oyster farming and microgauge and clam shrimp, sea grape, cosmetic. So this sea grape and kuruma plum is a #1 production in Japan. Because deep sea aura is a high potential to create a new job and in new industries. So then Kumejima is a announcement roadmap. So going carbon neutral the Kumejima Town Energy Vision toward 2040. So 6 megawatt OTEC base as a base load and solar PV and battery. Onshore 1 megawatt OTEC, offshore 5 megawatt, totally 6 megawatt. So now it's the first we are progress 1 megawatt OTEC in Kumejima. So I would like to introduce Deep Solar Industries. Then Kumejima model now is not only local Japanese name. So from the Kumejima model to global GX models is in small island. So IRENA, IEA, UNIDO is a many international organization is introduced and proposed the Kumejima model to solve the carbon neutral and SDGs to achievement. So another media is COP26, COP29. So announcements Kumejima model and introduced from the Japanese government. So this is a great announcement, press release on ocean thermal energy conversion at COP28 by CISDOC. CISDOC is a leader authorized by UN, small island developing state, over 40 countries. So this announcement sees small island developing state country are in disparate situation as we have a little space left to develop, deploy land-based solar PV and wind to meet our energy needs. Ocean is our resource of the last resort. So the small island countries leader, president and prime minister requested to promoting OTEC. So this press release, the 500 million project requested for promote the OTEC, on-land type Kumejima and floating type OTEC. So and this Plum 10. Plum 10 is a Pacific Island leading leader meeting. So President, Prime Minister from the Pacific Island, about 80 countries. So this is announcement. So first including OTEC, Plum 10 Joint Action Plan, now including the OTEC. So as a consider introduce OTEC as a next generation of decarbonization technology. So Japanese government, after the Japanese government promotes the OTEC for the Pacific Island. So Japanese government, Minister of the Foreign Affairs and JICA aim to the implementation of ocean thermal energy conversion in the Republic of the Palau with the technical support from Saga University. So this is top news, the Yomiuri newspaper. So we'll proceed with the install of the power plant in Palau as a first step, aiming to start operation by 2027. So now, as a first step, Japanese government now planning the Palau as a first 100 kilowatt, next 1 megawatt, then more bigger. Totally supplies electricity from the OTEC in Palau. Now planning. Another project. So JST, JICA, Japanese government supported the hybrid OTEC development project, Japan and Malaysia. So this project, we are challenged to the hybrid OTEC. Hybrid OTEC is as a one system produce energy and desalinated water. This this system is has some benefit. So because of this desalinated flash water, so using this evaporator, so we can use stainless or aluminum not corrosion, because this fresh water is no corrosion for this evaporator. So, and this side is titanium, but this side is stainless or aluminum. So, and not occur the biofolding, because this flash vapor to not occur the biofolding. So we can decrease the cost of the OTEC energy and desalinated water. So this hybrid OTEC is a jointed OTEC part and NIoT achievement desalinated water. So as a one system. So this heat exchanger is a key technology in the hybrid OTEC. So we are developed as a one system, so desalinated and evaporation. So we are success this system. So this collaboration is Saga University, Tokyo University, so on. Malaysia is a 5 university. This is a private sector. So this hybrid OTEC we are constructed in Japan. Then we are tested. So SATREPS project promoted the implementation of the OTEC in Malaysia. Sabah State Assembly passed the new OTEC enactment. So after the new enactment is the announcement last April. So then 3 private sector joined and announcement to accelerate the OTEC commercialize in Malaysia, Sabah. This is a new enactment. If you're interested, please reach to this address. Another neighbor state, Sarawak Sabah State announcement proposed the study OTEC. So then we are constructed OTEC, new OTEC building. So we are transferred to the exported Malaysia, this system. So last January, we hold the launching ceremony. The governor of the Malaysia. So, and this year, last January 10th, Japan-Malaysia summit meeting announced the technical cooperation in OTEC as a part of the promotion of cooperation on the resource and infrastructures. So from now, we are introduce our institute. Our institute is a whole ocean energy, OTEC and wave energy, tidal and offshore wind. This project is started in Saga University, then wave and tidal and offshores. So we have 46 researchers, professor. So we have a facility to open for the another researchers. So if you want to use our facilities, please submit the application. International use is we are promoted now. So under international activities, our institute, so many countries visited Saga University, past 10 years, 19 countries, about 1,600. So, and we hold the Young Researcher Ocean Energy Platform Program. So, then last year, from the India, so 3 young researchers attended our platform. So we are promoted collaboration with between India and other countries. So Saga University is step by step is a progress OTEC. So recently good milestones, Okinawa OTEC demonstration. So after OTEC demonstration, so we are tested new heat exchanger, new turbine, and double ranking cycle. So recently, we are started 1 megawatt OTEC demonstration project supported by Ministry of the Environment, Japanese government. So as you know well, so some technology existing the barrier of the death. So basic research is a success, commercialize is a high potential, but existing the barrier of the death. So but we want to work this bridge with international collaboration. Now is OTEC is very close to the commercialize. So now we are accelerated the Kumejima 1 megawatt OTEC, so next commercial stage. So innovation technology for the OTEC in Saga University. So Saga University for a long time proposed the advanced cycle, Uehara cycle, double stage ranking cycle, and another hybrid OTEC. So some advanced the cycle is this is for depends on the requested. So desalinated and high efficiency and so on. So we are prepared some advanced cycle, and we developed the heat exchanger and the desalination and the byproduct and biofouling. So from now we are introduce our some achievement. So double stage ranking cycle is with same heat exchanger area. So we are divided from the conventional ranking cycle. So same area, we compare the conventional ranking cycle and the double stage ranking cycle. Conventional ranking cycle and the double stage ranking cycle, same heat transfer area, but double stage ranking cycle separate. So we are decreasing the reversible loss. So we get some additional energy than conventional ranking cycle. So we are constructed the double stage ranking cycle. So we are achievement about 10 or 20% increasing the output using same energies. And byproduct is a hybrid. So OTEC is not only energy, fresh water, hydrogen, lithium recovery, aquaculture. In Saga University is all byproduct is promote and realized. So unfortunately, limited time. So we want to explain the recovers and amplifies the fish resources using the OTEC. So this is the Takumi project. So deep sea water including a nutrient. So after discharged, inside the OTEC this concept. So recovers the fish resources. So this is a Sagami Bay. Here's a Fuji Mountain. Here's a Tokyo. Where this is the people. So this on the operation, this is a sea level. Before the operation, this is a photo. So 1,000 meter depth. Intake port is a 200 meter Takumi project. So this is a mooring system. Intake tube. So this is our actual operation. 5-year operation. So we are success continuous operation. On the hurricane or typhoon, the top of this plant is coming, but for 5 years continuous operating and safety. So after that we are now planning 3 megawatt OTEC, and the growth is 2 mega. So and desalinated water and OTEC plant. So this project is solves the decreasing fish resources because nutrient discharged using OTEC, so we can recover is expected. So this is a OTEC roadmap to commercialize from the Japan. This is a 100 kilowatt OTEC is success, but not economically. So at least we need the 1 megawatt. So then 10 megawatt floating, 100 megawatt. Now we are first step by step in Japan. So 1 megawatt OTEC now is progress. Later we explain. As explained, so deep sea oil has a potential cold and nutrient rich and clean. So in Japan is 15 site already installs the deep sea oil intake tube. So Kumejima is the biggest tube. So from the Hokkaido is a very cool area. By the way, this people want to the deep sea water because clean seawater. So ice deep sea water so protects the fish fish life. So this is important. Now in Japan is increasing the deep sea water intake tube. So advanced technologies are tech. So Japan is develops a commercial scale heat exchanger. Very is a high performance. This is normally heat plate type heat exchanger is a herringbone type, but this heat exchanger is a special configuration for the OTEC. So low pressure drop is a high heat transfer area coefficient. This is a commercial scale. So we are using Kumejima data. So now we are scale up the commercial. This 100 kilowatt data is very important. 1 megawatt is diameter 1.5. 10 megawatt 3 to 4 meter diameter. So we are already the designs for the commercialized 1 mega, 10 mega on land floating type. So this heat exchanger using this one. This heat exchanger is for the suitable the double stage Rankine cycle. This heat exchanger is a cross flow. This is a evaporator and seawater. This one. Why is a cross flow? So seawater side is increasing the pressure drop using a conventional herringbone heat exchanger, but this area is cross section is bigger than this area, so we can decrease the pressure drop on the heat exchanger. So this is very suitable for the OTEC, for the double stage Rankine cycle and so on. So from the Kumejima experimental data, we confirm the 70% net power. So Kumejima first 1 megawatt OTEC, then 6 mega. So now 1 megawatt OTEC commercialized. So in Kumejima, our OTEC model, so this deep sea water intake tube is very, very costly. So this cost is shared as another industry. So OTEC company pay this distribution companies. So this deep sea water intake tube is a green infrastructure, public infrastructure, green infrastructure to promote the carbon neutral and nuclear job. So OTEC cost is very decreasing the share the intake tube. So actually in Kumejima now we pay the seawater so they can get the income. So if we can share, OTEC cost is a very decrease. And now we are develops a new technology, heat exchanger, floating and intake tube. So we can expect it this cost. Finally, Japan now is a Mitsui OSK line is a get OTEC project fund from the Ministry of the Environment. This is a news. So this is a first 200 kilowatt heat exchanger. So for the 100 kilowatt in Kumejima. So now we are already constructed. In this year is a operation this heat exchanger. So we are costed 1 megawatt. Finally, 0.4 about 40 cent per kilowatt hour. And 10 megawatt about 15 cent per kilowatt hour expected using our experimental data. So we are compare the study solar, offshore wind, wave, tidal, OTEC. So some space, footprint, power generation cost, initial cost, running cost. OTEC is the initial cost is intake tube is very poor performance. Solar is very high benefit. So we are each combination. So Pacific Island, so no wind, so high potential OTEC. So we are proposed the OTEC and the solar jointed and the Kumejima model. So finally, we are constructed the established OTEA. OTEA is the largest OTEC association in the world. So India delegate is Dr. Prima NIOT. So we are promoted OTEC. If you're interested, please reach to this address. This is a free. By free, you can get the information and we can join it to promote the OTEC, the world. So from the NIOT, so make a history of the OTEC. So we are finally the respect the NIOT achievement. Thank you, Mikanandris and arigato. Thank you, attention.
Arigato, Higigami. Yeah, thank you for the excellent presentation. And I have always seen your passion with OTEC through the years. And thanks for the good collaboration with NIOT and towards Southeast Asia, etc. And you have been a good ambassador to promote the OTEC. Yeah, let me open the floor for any good questions and comments to your presentation. Youngsters, any queries, comments?
So thank you for your presentation, Professor Higigami. In one of the plant, you showed some some plant, I forgot that name. How you are powering and how you are generating the power and how you are distributing to the shore, sir? That 1 kilometer long cold water pipeline also you have shown, no? Takumi project.
Kume project.
Yes, sir.
Kumejima project.
How the power is distributed to the from the site to the shore, and how the power is generated for self-starting of the plant components.
So, pardon, sorry, one more again. So, I cannot clear.
Yeah, for your Takumi project, how are you bringing the power to the shore?
Power?
Yeah, so what is the mode of transferring the power from the water plant to the shore? Are you connecting to a microgrid?
Yeah. Connected grid, yeah. Microgrid, yeah.
Okay.
Public grid, yeah, we are connected.
So, Ikigami, like you were sharing about biofouling effects, what is
Yeah.
its effect on the heat exchanger?
Yeah.
How is it getting affected, and how are you seeing technologies to prevent it,
Yeah.
both in
So,
the heat pipe as well as in the heat exchanger?
yeah. So, Kumejima, as you know well, so deep sea aura is very clean. So not occur the biofouling, condensation side. But evaporation side is ordinarily occurs the biofouling. But Kumejima is not occurs the biofouling because bacteria is very rare, very smaller than normal conventional sea. So Kumejima is a no exhaust is a life waste water. So very clean the area. So coral area. So no occurs a biofouling. So for 5 year continuous operating, no occurs a accident is inside the heat exchanger. Say warm seawater.
My next question is like, are there chances for OTEC to get co-located to offshore wind or any
Yeah.
other energy sources?
Yeah. Yeah, we can join it if we want to. Yeah.
Okay.
Thank you, sir. Thank you for the presentation, overall presentation, the developments in Japan and various collaborations that you have been offering to many of us. Thank you once again for your valuable time.
Yeah.
With this,
Thank you. Thank you very
thank you,
much.
thank you very much. With this, we come to the end of the session on OTEC. We'll have a break now, short break, about 15 minutes. And then
Yeah.
we'll start with this next session on standardization and commercialization. So request all to join first for the high tea. We'll be joining again in 15 minutes. Thank you. Before that, I'll just request Dr. Sahu from NRDC to please honor our chair for this session. Dr. Shrikant with a memento. Thank you. Yeah. Please join for the high tea now.
Welcome back to all. Today, now we are in the session 4 of the International Symposium. This session focuses on standardization and commercialization. May I now request Dr. I request Dr. Jayakumar Sheelam, Chief Scientist, NIO Goa, to chair this session, please. Thank you, sir. So in this session, we have 3 talks. So discussing the aspects of standardization and commercialization. The first talk will be by Shri Rajiv Sharma, Deputy Director General, Standards, Bureau of Indian Standards. I request Shri Rajiv Sharma ji to deliver his talk. His talk will be, the topic is the essence of civilization and role of Bureau of Indian Standards.
Yeah, good morning, everybody. This session, we want to try and reduce the time. So instead of half an hour, the speakers have been requested to make it to 20 minutes. Thank you.
Thank you so much. A very good afternoon to all of you. My name is Rajiv and I'm from the Bureau of Indian Standards, which is the national standards body of India. So after the insightful presentations on the very deep, intense technical subjects, now we move towards standardization. I'll try to convince you why standardization is so important for the country. See, to set the things in perspective, this world has a population of about 8 billion. We are 8 billion people on this planet. And this population is rising by about 70 million every year. And most of the rise in population is taking place in the global south. I hope everybody is clear about what is global north and what is global south. Can somebody answer me what is global north and what is global south, if you can understand that? I know there are students, there are children. So I'll try to explain very briefly what global north is. See, it is not the northern hemisphere or the southern hemisphere we have been learning in the colleges and schools. There are certain countries which call themselves global north because of their level of development. They are the highly developed countries. There are 54 of them which are developed countries, and the other countries are, I want answers, are developing countries. So developing countries are not so advanced countries. So India is in the bracket of, we are a developing country. So the journey is from the developing to the development. I know many of you may have seen some of those developed countries we are talking about. And our ambition is to be there. Our Prime Minister has given us a very important ambition. What is that ambition? Viksit Bharat. Have you heard of that? And it is our, as a challenge, it's a vision of our Prime Minister to become a developed country by the year 2047. Right. So if we can visualize the difference, the developed countries and the developing countries like India, we have to be there by the year 2047. How many years more? Come on. 22 years more to go. Do you think it is possible to be there by the year, within 22 years? Who believes it is possible? How many of you are confident that it is possible? Yes, we all believe that it is possible. How many of you don't believe that it is possible? I, for myself, I'm 100% sure that it is possible. But how? A lot of things need to be done. 22 years is not a very long time. The Prime Minister has given three stages of a formula. And can anybody remember that? He has talked about scale. See, India is a very big country. Small improvements here and there will not make any difference. We have to do things. We have to do things at large scale. which should pan-India presence. A lot of improvements need to be done. The second S which he has told is we have to do things at speed. Speed means 22 years is not a very long period of time. So in order to reach that stage of development, we have to do things at speed. And in order to do the things at speed and scale at which it is required, we need what? We need skills. So scale, speed, and skills. This is what can make it possible for India from now to 22 years from now, 2047, we can become a developed country. So these three things need to be done. And 3S approach is there, which has been given by the Prime Minister. If I can add one more S to it, that will be standards. Can standards help us in achieving that scale? Can standards help us in achieving that speed? Can standards provide the skills which are required for doing that things? How many of you believe that can be done? Yes. So the standards have that power. We can give a standard, provide that scale to the country and do the things at speed. The standards can also help in upskilling the people. So now we come to the question, what is a standard? What is a standard? Are we talking of some new technology which is coming up? What is a standard? I'll tell you very briefly what a standard is. I know many of you are directly or indirectly involved with standardization. Many of you may have referred to the standards, but standard is a document, right? We should all understand that. Standard is a document which is prepared by collaborative effort or combined effort, wisdom of domain area experts, right? So it is a document which is prepared by collaborative effort of domain area experts representing various stakeholders, right? They belong to various stakeholder categories and they come together and develop a document through a process known as consensus, right? We'll understand what consensus means. And then that document provides solutions to the problems of complex and repetitive nature, right? So it's a document which is prepared by combined wisdom of domain area experts representing various stakeholders coming together and developing a standard through a process of consensus. And then that standard provides solutions to problems of complex and repetitive nature. So what are the problems of complex and repetitive nature? Which we require solutions to. Can we do without standards? We can do. There are people who are developing technologies and working without standards. They have no knowledge. But if that thing has to be done at repeated intervals, at scale, at speed, then you require standards. And that is what will help us in developing the country forward. Right. So what are the challenges? How many of you, I'm asking to the younger section of the audience, are you aware about sustainability? It was talked about a lot of time about sustainability, but are we clear what sustainability means? What is sustainability? See, there are three aspects to sustainability: it's economic, social, and environmental. When we talk of sustainability, we means that the planet which we have right now, it is not our own property. It is not for us to consume. It has natural resources. It has finite natural resources. And we must preserve those natural resources so that we take care of the needs of the future generations. So it is without compromising the ability of the future generations to meet their own needs. We have to fulfill our needs without compromising the ability of the future generations to meet their own needs. And these are in the three categories: the social, the economic, and the environment. Are we taking our environment too much for granted? Are we drawing too much natural resources from the environment? Are we polluting the environment to an extent that it is not possible to recover from that? So these are some of the challenges which the world faces now. And the standards must provide solutions or answers to meet these challenges. Technology has to provide answers. When we look at the world which is sustainable for future, it is the technology which must come forward and provide answers to meet those technological or environmental challenges, the social and the economic challenges. And this is the technology which then the domain area experts representing all the various stakeholders get together in the form of a committee structure and develop a document then which implements across the country by all the stakeholders. And then the things are done in a manner which leads to a speedier and economic development of the nation. Speedier economic development of the nation. This is what we require. And when we say this the development of the standard, who should collaborate? Who should collaborate in development of the standard? The experts representing various interests in the country. But then there is a standardization at the international level. Should we take part in that standardization when the standardization happens at the international level? Some answers, please. Yes. We should take part in the standardization at the international level when the standards are being developed at international level. So the standards being developed at the international level, sooner or later, they become mandatory for the entire world to follow those standards. And we must be there in order to make ourselves present, to make our voices heard in that international standards development process. See, there is a saying that if we are not on the table, then we are on the menu. If we can't put our voice forward, we'll be taken for granted. And then there are people who are going to take advantage of the situation we are in. And then they are going to develop something for which we have to just follow them. We can't be part of the making process. So either we can be part of the makers or we can be takers. So I prefer that we be on the table where the standards are being made and be part of the making process rather than taking standards which are developed by somebody else in the world. Because the best technical expertise in the world anywhere. And we have to take part in that standards development process. And this marine technology, the marine energy part of the standardization process has entered very late into our standardization fold. We were developing standards from the year 1947. BIS is the national standards body founded in the year 1947, just before the independence. And this technical committee in the BIS for the development of standards on marine technology came up about 2 years back. It came about 1.5 years back. It's a late start to the process. But nevertheless, we want that this technical committee, which we have formulated, ETD 54, is it? To be a very colorful and very vibrant committee and come out with standards which will then transform the entire technology landscape, not only in the country, but also have the potential to offer something to the international dominant and used the world over. So that is my message to you, especially the youngsters, because then see the standardization provides the right solutions to the problems. And if you feel that you have the expertise and if you feel that you can contribute towards development of the standards, why not go to the BIS website and register yourself as the potential user of the standards and also give comments on the documents which are generated worldwide. How can you participate in the development of standard? You can do it by 3 methods. You can download the documents which are there for public commenting and give your comments for improvement of those standards. You can register yourself to become a member of the technical committee, and also you can propose your own new subjects. I know many of you are researchers, many of you are developing new technologies. Why don't you come forward and say that this is a technology on which the standard is required? And I come forward to develop that standard in a committee structure. So these are some of the ways in which you can participate in the standards development process. It's all about collaboration. It is all about coordination. And the more people coordinate, the more wisdom which goes into development of the standard is getting enriched. That is the message which I want to give you. Thank you so much. And I will request my colleague, Mr. Ritvik Anand, to share his insight on this subject of marine technology.
So very good afternoon to everyone. I am Ritvik Anand. I am scientist in Bureau of Indian Standards, and I am also the member secretary of ETD 54 sectional committee that Rajiv sir explained to you about the standardization and the committee structure through which we are formulating Indian standard. Rajiv sir has already explained to you the importance of standards and how we are developing Indian standards, how as an individual or as an expert you can contribute in the development of Indian standards. I have only few slides where I can explain you what are the standards we are developing in the field of electrotechnology. And the specific, we have a dedicated technical committee on marine energy conversion system, ETD 54. I will give you a brief overview of the work being done by this committee till now. So the first slide is about the scope of Electrotechnical Division Council. We have a 16 Division Council in BIS, which is preparing standards on different aspects related to technology, like we have a specific division council for the civil engineering, for the mechanical, for environmental aspects. So for the subjects related to electrotechnology, we have an electrotechnical division council. The scope of this electrotechnical division council is we are preparing Indian standards right from generation, transmission, distribution to the utilization of electricity. In Electrotechnical Division Council, we have a 45 technical committee which covers entire generation to usage of electricity, and more than 1,500 experts are involved in formulation of these standards. Then if we can see like what are the various standards we have on various categories, like if you can see from the generation point of view, we have standards on renewable energy systems like solar PV systems, wind energy systems. Recently, we have our standards on marine energy systems also. Similarly, on the non-renewable resources also, we have standards for various turbines used in non-renewable sources. Then for the transmission systems, we have various components used in transmission systems, overhead lines, overhead conductors, all those products we have standards. Then in the distribution system also, various components used in distribution system, distribution transformers, insulators, all these technology, we have a dedicated technical committee and we are formulating standards. As far as the application or the uses of electrotechnical area is concerned, we have standards on the various appliances to be used in electrotechnology and also on the storage system. So these are the broad aspects where we are developing Indian standards in the electrotechnology area. So when we are developing standards in any sector, like in electrotechnology, we are developing standards through various levels. Like initially, some basic standards are required to be developed, which will cover the vocabulary related to that systems, some concepts, general concepts related to that system. Then we have further we have a standard for the guidelines for the implementation of those systems. The next level is the standardization related to smart products, the IoT interface. Then we are developing standards on the communication technologies related to the system. So slowly we are developing right from the basic standards to the advanced level of standards across various products used in electrotechnology. These are some of the focus area that we have in the electrotechnical sectors. One of the key area, if you can see, is the renewable sector. So BIS has a dedicated technical committee on various aspects of renewable energy. If you can see, like in BIS, we have 3 technical committees. The one is ETD 28, which basically caters to the solar PV generation systems. Then we have a committee on wind energy systems, ETD 42. And then we have a committee, recently last year, we have created a committee on marine energy conversion systems, ETD 54. So in this renewable energy standardization, if you can see, there we have developed several standards related to components used in various renewable energy systems like solar PV systems, the cables used in solar PV systems, with various kind of onshore and offshore wind turbines, the blades used in wind turbines. So these are the components level standards we have. Then we are also recently we have developed standards related to the grid integration of these renewable energy systems. Now, slowly we are moving more into the renewable energy systems. So these systems are required to be integrated in the grid. So we have also developed, recently we have developed a standard on grid integration of renewables. We are also running various kind of a certification program. As you may all are aware that Government of India has mandated that any solar PV systems, like any solar PV array or panel or inverter or batteries to be used, they are mandatory required to be certified as per BIS standards. So BIS is also running various kind of certification schemes related to the renewable energy systems. Next is very important aspects, international collaboration. BIS is representing India in international standard forum in the sector related to electrotechnology. There is a IEC, International Electrotechnical Council, and Bureau of Indian Standards is representing India in International Electrotechnical Council technical committees. When I am saying that BIS is representing India, that means that the experts of our national committee, whether they are from National Institute of Solar Energy, National Institute of Ocean Technology, some labs, some industries, they all are representing India in IEC technical committees. So that the views, the requirements related to Indian conditions shall also be incorporated in international standards. So these are some broad programs that we are doing specifically related to the renewable energy systems. These committee I have already explained to you, like we have a dedicated sectional committees for 3 primary sources of renewable energy. For the sectors related to marine energy conversion systems, we have last year only we have created a new sectional committee, ETD 54. This committee till date has published 5 Indian standards, and we are also representing India in ICTC 114, which is the mirror committee of on the same subject related to the marine energy conversion systems. So this is the basic composition of the sectional committee. If you can see, in our technical committee, it is not BIS is writing the standards. We are collaborating with all the major stakeholders of our country. They are from the academia, they are from the regulatory bodies, from the research institutions. So all major stakeholders are present. Of course, Dr. Purnima Janrihal, Madam, the chair from NIOT, she is leading, she is the chairperson of this committee. So through this presentation, one of my motive is, if you feel that you have some expertise or you are developing some technology, you are also able to contribute. I request all of you to please feel free. You can reach out to BIS. We have a very transparent process. You need not have to write any letter or any email to us. You just go to BIS website. There is a tab, join as a technical committee member. So you can put your CV and you can apply for the membership. So these are the initial 5 standards that we have developed on marine energy conversion systems. These are some of the important projects related to Indian point of view, where we have nominated our Indian experts in the IC technical committee. If you can see, the first project is on the power performance requirement of the OTEC plant converters, and other is on the tidal energy resources center. So here the experts from India are nominated. These are high level interest projects in IEC, and experts from India are nominated in these projects. They are continuously collaborating with international experts and developing standards on these subjects. In the next financial year, since after 15 days we are going to enter in a new financial year, so we have already decided on some of the new subjects that we will take up in the next financial year. So these are some of the subjects that we have identified that we will take up in the next financial year for development of standard. Even if you feel that some of the subjects you are working on or some technology you are developing, you can also suggest us to develop standards. We will be very happy to add your subject in our annual program of standards, and we will develop standard on those areas also. So this is a brief introduction about the work we are doing in standard formulation, what is the importance of standard formulation, how as an expert you can all contribute in the development of standards. That's all from my side. Thank you very much.
Thank you. I will not ask the audience to ask any questions because we are there in the lunchtime. You can go and meet them personally and then discuss much more about BIS. Thank you, Rajiv Sharma and then Ritik. Thanks. I request memento to be given to the speakers. Yes.
I request the chair to give the mementos to the Sri Rajiv Sharma ji and Ritik Anand ji. Thank you, sir. The next talk will be by Dr. 𝐷𝐾 𝐑𝐄. 𝐷𝐾 𝐑𝐄 is a technology, intellectual property, and innovation management professional with more than 15 years of work experience. Presently, he is heading the Intellectual Property Facilitation Center and Technology Innovation Support Center at NRDC, National Research Development Corporation, Government of India at Visakhapatnam. Sir.
Dr. Sahu, floor is yours.
Thank you, sir. Thank you, NIOT. And this is your 32 years of old. And God bless you. And thank you, madam, for giving this opportunity. Today, my topic is the need of the hour, what the Viksit Bharat we are talking about, how to bring Saraswati and Lakshmi together. And Sabse Bada Rupaya. I think you can give the light. Before that, I'll request, I missed my spec. If anyone can find, please give me. That will be great help. So when we talked about technology innovation, connecting mind to the market, technology from lab to the land, technology from bench side to the bedside. Yesterday, you might have seen some of the technology was displayed, presented, and which are indigenous for the nation and nation building, those who are creating, those who are developing, those who are giving product to the mass. And that is the innovation we talked about to bridge the gap between academia and industry, to keep both Saraswati and Lakshmi together. Because we are in the knowledge economy, knowledge must be acknowledged, knowledge must be managed, knowledge must be monetized. Then only we can mitigate the challenge of the global world and also sustainability. Thank you, Dr. Purnima Jalihal, and also thank you, NIOT, for giving many more scope of collaborating with many industries and many of the product and some of the product which we are seeing outside of this conference are also given to many of the industry who are in the process of manufacturing and process given the product to the nation. Next slide, please. 20 minutes I have. So when we talked about innovation as a citizen of India, as a responsible worker, we must leverage. And that is the beauty of NIOT and how NIOT is leveraging innovation in part of the national innovation ecosystem. And that is the developing path today. We are part of it. Next slide, please. This is something we must celebrate. The innovation has been put in place in the United Nations ecosystem. And that's the technology coming from this place. And the inventor is also sitting here. The innovator is part of it. And we NIOT celebrate the innovation for the nation and sustainability. Next slide. When we talked about invention and innovation, we must respect intellectual property. My earlier speaker spoke about standard. And this is my standard. I'm standing before you. But I must come out with the original standard, novel standard, so that I can make the difference to the nation. And we must have to leverage because on quote, patent are important. You never know when one grab your innovation. Honorable Prime Minister of India. Next slide. We are talking about blue economy. There is a great vision and mission in all sector, including sector of marine and renewable energy. Next slide. And also we must look into the component of the blue economy, who are the real stakeholder and create impact and visibility and also connect the dot. Next slide. The area, we must look into all firm, and that you all aware on that part, particularly as far as the institutional framework is concerned. Next slide. And we must look for the ecosystem. That ecosystem drives economy, technology, and society, because reaching to society, reaching to the people of the last mile is our goal. And that is nothing but the dream of our founding father, Mahatma Gandhi. Next slide. So innovation is a buzzword. Everyone talks about innovation. But we learned the innovation during Corona. We lost many of our known faces. And at that time, we got many startups, many MSME came out with the testing and treating of COVID-19. So innovation is always market-driven, technology-driven, and invention-driven. When we are talking about the institution, that to a national institution, we must look into the R&D-based innovation. There should be a validation, certification, and also originality. Next slide. Our role is connecting the dot, bridging academia industry together in leveraging invention to the innovation with all kind of value addition in processing, protecting, certifying, demonstrating, and also supporting for technology development and field testing and market survey, including prototype. Next slide. So when I talked about Saraswati and Lakshmi, you can see Dr. Purnima Jaluhal is none other than a Saraswati, and Lakshmi, the lady who is sitting there, Bhagya Lakshmi, who is manufacturing. So how to connect the dot, the Saraswati and Lakshmi, that is our objective. I'm grateful that Dr. Ramdas is here. Truly honored to meet you, sir. Next slide. So these are the bringing Saraswati and Lakshmi. You can see left and right how the people are connecting the dot for a big Bharat. And this is the technology from an IoT only. Next slide. Some of the technology who are making us proud, giving an opportunity to stand before you. And it has been already displayed, demonstrated. Next slide. Some of the technology we must look how we can be part of this big Bharat and blue economy. Next slide. Navigating a new business, as far as anything is concerned, the future is foggy. Because there are a lot of implications when you are taking any product to the market, and whether you have a freedom to operate or not, whether you have an IP or not, whether you are infringing, because infringement, piracy, plagiarism, copyright violation, the biggest challenge for India at bilateral and multilateral level, including many of the institutions also. So IP violation is not only create challenge to the individual, it create challenge to the nation. And we have a biggest challenge of Special 301 provision before India by the US Department of Commerce. Next slide. So when we talked about intellectual property, and in fact, everyone talks about Global Innovation Index, and today we are 39 from 84 ranks. Every citizen must understand the role of intellectual property. The intangible ecosystem today driving in the world economy is playing an important role rather than tangible process and product. Next slide. NIoT, connecting the dot. This is something I will present you how you are leveraging invention, innovation, research, development, commercialization, connecting to MSME, startup and industry, and also making the difference to the nation and nation building. Next slide. So we must have to connect that, and that is the objective. Every institution has a policy, and Government of India already established institution to come out the IPR policy so that there should be a benefit sharing. NIoT came fast, I think one of the national institutions to benefit the share came out from the research and innovation that connect to the industry. Next slide. So that will talk about the Bible of an institution to respect, leverage, protect, manage, monetize, and also stand before the global economy as a supreme leader in the invention and innovation. Next slide. So intellectual property gives a opportunity today in the global world. It is a legal right. It is your right. And this is other than fundamental right, intellectual property right. Everyone have those who are creating such intellectual property in the form of process patent, product patent, copyright, design, trademark, semiconductor integrated circuit layout design, also others like geographical indication of goods and trademark. Next slide. So this creates the value, this creates the opportunity, this creates the loyalty, trust from an investor to invest in your process and product. Next slide. And certainly every institution today, those institutions we talked about are certainly making the difference. and harmonizing intellectual property, their institutional practice, so that we should respect the IP, leverage the IP, and also share the benefit of the IP as far as the inventor, innovator industry is concerned. Next slide. It gives a value proposition. Can you please आगे ले जाओ? This gives a value proposition and also freedom to operate in the market. And you need a freedom to operate, to showcase, and this is the recognition of an institution in the global world that this invention is from this institution. That's the role of intellectual property. Next slide. We must look the ethical issues. It is the biggest challenge. As I told, at multilateral level, we have a challenge. Bilateral level, we have a challenge. At institutional level, we have a challenge. We have to create framework for that. Next slide. So coming to NRDC, we are playing a key role. We are grateful to NIoT leadership. We are grateful to all NIoT fraternity. Today, those who are giving us a strength to stand before you is because of their support, how we are leveraging invention to innovation. Next slide. Next. So next. This is our role. This is our objective, how we leverage from lab scale technology to viable level technology that should be commercial viable in the form of publication, in the form of expo, in the form of networking, in the form of demonstration, in protecting all IP, connecting academia, industry, and government together. Next slide. Next. Because of the time constraint, I'm skipping. Next. Next. We have a technology readiness level assessment ecosystem. The way standard has been taken out by the Bureau of Indian Standard, the same way we do the technology readiness assessment of any technology that has been developed in the any lab in the country, so that we can give a certificate, and also we can share the challenges and of the stage of the development of the technology, and also viable for technology transfer. Next slide. Next slide. We do technology valuation, and IoT is one of the best example of technology valuation. We have a rigorous process mechanism, so that because we all are from the public funded institution, and when we are transferring any technology, the money is coming from a taxpayer money. We have to give justice to it and also give confidence to the account, so that it should not be a problem in our financial ecosystem that we manage in the public ecosystem. Next slide. Next. We have a design clinic for design innovation. Next slide. Next slide. So when we talked about intellectual property right, that will give a strong trust, that will give a strong impact of your invention and supremacy in the field of invention, and also give a legal right. We must look into the other aspect also. We may develop a technology, but whether the technology is market readiness level or not. And technology may be market readiness level, whether the technology is consumer readiness level or society readiness level or not. So in that all aspect, we do all kind of validation, valuation, and bring technology to the innovation readiness level. And that's the ecosystem today. We are playing an important role in the knowledge ecosystem, in leveraging knowledge from mind to market. Next slide, please. Not only to that, as a national organization, we are taking Indian technology to the global ecosystem to demonstrate it to the least developed country. Next slide. And we established a technology demonstration center in many of the African countries, took Indian technology, Indian varieties, Indian startup, so that India can support to the least developed country or developing country in the technology absorption and spillover. Next slide. This is something I proudly show in many of the occasions. Many of the NIoT technologies also there who are making us proud. None other than Dr. Ramdas is here, an unmanned remotely operated vehicle. This is one of the technology we have given to L&T Defense and Bell. And this is how a institution plays an important role in mitigating the challenge of the global world and sustainability. Next slide, please. Not only to that, we are part of the WIPO Green to showcase Indian technology. And one of the technology, saline water lantern, is from this platform. We showcase the WIPO Green, and it has been put in place in COP29 of the global ecosystem of sustainability. Next slide. Not only to that, we are transferring many technology, collaboration with our Asian counterpart. Next slide. So that's the role of an institution and role of an organization to showcasing Indian technology for global sustainability, when we talked about green technology and some of the green technology also we have transferred from NIoT to many of the industries. Next slide. When we talked about technology transfer, bringing global world information to global ecosystem, we must leverage it, and technology transfer program we do time to time so that we can create an opportunity and leverage sustainable use of intellectual property and benefit sharing. Next slide. I think last time we had a program, and Ms. 𝐊𝐂𝐑𝐈𝐍𝐄, the US director of the USPTO, witnessed that program. Next slide. We support for technology development validation for commercialization to the women entrepreneur and also entrepreneur in any gender, and handhold them, and many of the technology will be in the market to mitigate the challenge of the global world. Next slide. Next slide. This is one of the very, very interesting technology, and all these are from NIoT, who are making us proud, and the institution itself has a great credential in the national ecosystem of scientific governance. Next slide. Connecting dot is nothing but bringing industry is most important. What industries looks for? Jaisa desh, aisa base. And we must have to connect with industry so that we can mitigate the challenge of the industry, and that academia industry conclave we do. And NIoT is also part of our many program in due course of time. Next slide. Next. And this is something I always, and we always respect to the institution like NIoT, who has given such platform in connecting the dot, leveraging technology from lab to the land, mind to the market, technology from bench side to the bedside. Next slide. And our role is to connect to the MSME startup and industry, because they need technology, and they need the technology at the commercial viable stage so that we can connect to the appropriate institution who can fulfill the demand of such industries. Next slide. Thank you, all of you. God bless you. Jai Hind. Vande Mataram.
Thank you. Thank you, Dr. Sahu. We can have one question, please. Youngsters. Dr. Ramdas. Yes, please. It is related to royalties. Okay.
Part of the benefit sharing academia industry expands class. I think. The kind of process of their development and also commercialization, so that we can also give awareness to the respective institution to know the actual process mechanism of the technology transfer. So benefit sharing part, certainly, sir, it is completely.
I think that is a weak link, because see, as a developer, actually, we cannot follow the industry and we cannot get the royalty from them. So we rely on NRDC. So I think there should be a mechanism to periodically check how many they have sold, whether they have paid the royalty, such things.
Sir, we do communicate, and also in due course of time, we get the information, and sometimes if we are not getting through there, we try to get from their chartered accountant, their annual report, as well as we also visit to the respective industries whom we have given the technology, so that we can actually get a ground position. But at the same time, now the industries has also changed their mindset. They are very, very transparent. Sometimes they have some difficulty in manufacturing, but we are connecting them. And certainly, and many of the institution gives direct one. I think there is no royalty for that, and in one go they can transfer the technology by taking a lump sum premium. That is also one of the mechanism. But for a national institution from a public funded ecosystem, sometimes we have to mitigate the challenge so that it should not be purview of the account perspectives. That is also one of the most important arrangements, sir. So, thank you, sir.
Thank you. Thank you, Rahul.
Thank you, sir.
Let's have one more round of applause for Dr. Sahu, please.
May I request the chair to present a memento to the speaker, Dr. 𝐷𝐄 Sahu, sir. Thank you, sir. The last speaker for this session is joining online. Is Mr. Jonathan Colby. Mr. Jonathan Colby is the president and founder of Streamwise Development, a client-driven consultancy focused on enabling innovation and commercialization in the renewable energy industry through the effective and strategic management of risk to ensure quality for all stakeholders. He is actively involved in standards and conformity assessment in IEC. He was awarded the IEC 1906 award for his work with the ICERE. I request Jonathan Colby to deliver his talk.
Yes, thank you very much. Okay, can you hear me okay?
Yeah, you are loud and clear.
Very good. Very good. And can you see my screen okay? I hope you can see my slides.
You can go ahead.
Okay, very good. Well, greetings, everyone. My sincere thanks to the National Institute of Ocean Technology. I'm very sorry that I cannot join you in person today or yesterday. I hope you have had a very productive symposium, and thank you for the opportunity to speak today. I was very pleased to hear from our colleagues at the Bureau of Indian Standards, and I will speak a bit more about the details of international standards, IEC TC 114, as well as certification through the IECRE for the marine energy industry. And again, my sincere thank you for the opportunity to present today. So the IEC is the International Electrotechnical Commission, and they structure their work under technical committees. The TC 114 is titled Marine Energy, Wave, Tidal, and Other Water Current Converters. This group was approved and formed in 2007, so we are nearly 20 years old. I have the honor of serving as the chair of TC 114, of which I've been the chair for nearly 9 years. The group holds an annual plenary meeting. We have had 16 such meetings in 10 different countries. In 2023, we held our meeting in Edinburgh, Scotland. We had tours of FlowWave, a wave tank, and FastBlade, a blade test facility, as well as a trip to EMEC, the European Marine Energy Center, located in the north of Scotland. In 2024, we held our meeting in Jeju Island, South Korea, and our hosts gave us a tour of the Wave Energy Test Site, or WETS, located on the southwest corner of Jeju Island. In 2025, in just 1 month's time, we will be meeting in Dublin, Ireland, at the Dublin City University campus. Now, as we look at the committee, our committee itself is more than 200 subject matter experts representing 30 countries. You can see we have grown quite significantly in the last 10 or 15 years with a doubling of our experts and a growth of nearly 50% or just over 50% in our countries. Today, we have 20 working groups with a new group pending. We have published 23 first edition standards, 17 of which are our first edition, 6 of which are already advanced to a second edition. And we have made available vocabulary publicly so that the industry can agree on terminology and vocabulary. Now, this terminology and vocabulary can be found in the IEV Part 417, if you're interested in some of the common terms that we've agreed on. Now, I always think a picture tells 1,000 words. So here are the participating member countries, and there are 18 of them. I am particularly proud, especially speaking to you today, to show the flag of India as one of the P members. India is our newest P member to TC 114. And even in the 2 years since they joined, India has had an immediate impact on the development of international standards. We were with our colleagues from India in Jeju Island, and a large delegation of Indian experts are participating in April in Dublin. And so I'd like to thank the entire Indian marine energy community. I'd like to thank the Bureau of Indian Standards, thank the NIOT, and everyone in the room for participating actively and helping make TC 114 a stronger committee because of your participation. So my sincere thank you. You will see we have most of the world's largest economies when it comes to marine energy active in marine energy. So that is very excellent. You will also see one large gap in South America, where today we do not have any participating members from South America. And so I am actively working to increase participation from our marine energy colleagues in South America. Now, in addition to those 18 participating members, we have 12 observing members. You can see we have most of the rest of Europe covered in our observing members. However, we get our first South American country in Brazil as an observing member, and we're working with Brazil to become a P member. Now, I would also note we have another large gap in our colleagues in Africa. We have been unable to really make progress with finding African colleagues, but we certainly would be interested. And if you in India have contacts or experience in working in the African environment in marine energy, we would be very interested to meet and know our colleagues in Africa. Now, a bit more about our committee. One of the important things we do is create liaisons with other standards organizations, both inside of the IEC, but also outside of the IEC at ISO, as well as other international agencies. And so one of our key and strong liaisons is with the International Energy Agency and their ocean energy system. I assume you will have heard about the IEA OES through the work of Dr. Jalihal and other colleagues there in India. Together with the IEA OES, we published a document called Supporting Ocean Energy Technology Development and Commercialization, Coherent Application of Guidance, Standards, and Certification. That is free and publicly available, and I would encourage all of you to have a look at that as you think about how to support development and commercialization. And I think this is a very timely topic, in particular based on the previous topic we just heard regarding the technology transfer from the labs to land, as I believe the catchphrase was. And I thought that was also a very interesting presentation. As we're looking ahead, we have some new work items that we're considering. I know OTEC, or Ocean Thermal Energy Conversion, is a real interesting topic in the Indian environment. And so we are preparing a standard on resource assessment for OTEC. We're also preparing a standard for small wave energy converter design. We're considering a guidance document for installation, operation, and maintenance. And our colleagues in Korea are proposing a standard on risk assessment specific for marine energy. And as our colleague from the Bureau of Indian Standards mentioned, there are many opportunities to get involved. And we at the IEC and in TC 114 would welcome additional Indian experts to engage and contribute to the important work of developing standards. And now to share a bit of where and how you could get involved, I want to provide just a quick review of the standards under TC 114's work package. These are what I call the resource agnostic standards. So these do not depend on if it's river or wave or tidal or OTEC. These standards cover all of the marine energy resources. You can see this includes marine energy design, the measurement of loads, technology qualification, which is very similar to the technology readiness level assessment that was mentioned by our previous speaker, We have standards on moorings, on power quality, and then we have a number of standards that relate to characterizing attributes of the device that it could impact the environment. And so this is acoustic characterization and biofouling characterization. And then because of the important role that turbulence plays on loads and on performance, we've started a new standard on characterization of turbulence in the marine energy environment. Now, if we look at specific standards for the resource involved, we have two standards on ocean thermal energy conversion, the design of OTEC power plants, as well as the power performance assessment of OTEC power plants. And as I mentioned, we're considering a third standard on resource assessment for OTEC. We have a suite of standards for wave energy converters. Now, we've just last year published the second edition of our entire set of wave energy converter standards. So that's power performance, resource assessment, and scale device testing. And I would like to note that with these second editions, we've integrated new information. And as a result, we've withdrawn an older standard that was published in 2016. And so I just wanted to share that for our wave energy experts. We have withdrawn the 102 standard, and that information is now contained within the suite of standards published for wave energy devices. Similar to wave energy, we have tidal energy devices, power performance, resource assessment, and device scale testing. And we have a similar set of standards for river energy converters. So I do hope this gives a summary of all the different activities on TC 114 and the areas where your expertise and your participation would be most welcome and certainly invited. Now, with that, as time allows, I'd like to briefly switch to the work of certification. And this work is done under the IEC-RE, where RE stands for renewable energy. Now, our colleague from the BIS mentioned this briefly, and I'll just touch on it in a little more depth. Certification is defined as the third-party verification of compliance to consensus-based international standards and technical specifications. And such certification and compliance to standards can reduce risk, improve market access, and ultimately support commercialization of the marine energy industry. So again, very relevant to the prior speaker and his comments regarding technology transfer and technology into the marketplace. Now, the IEC-RE system is three sectors. It is marine energy, it is solar photovoltaic, and it is wind energy. Within the marine sector, we have 9 countries or member bodies. And we develop a suite of deliverables that start with test reports, conformity statements, and feasibility statements. And taken together, these become certificates. And these can either be a prototype certificate, a component certificate, a type certificate, and ultimately, ideally, a project certificate. And now these deliverables are issued by bodies. For the conformity statements and feasibility statements, these are issued by renewable energy certification bodies, or RECBs, and the test reports are issued by renewable energy test laboratories, or RETLs. And to share, the marine energy sector is also considering a new category called a renewable energy inspection body. Now, here are the countries that are participating. You can see we have strong participation in Europe, as well as the United States and Japan. At the moment in the marine sector, we do not have India, and I will touch on that in a few slides. But I also wanted to show all of the incredible test laboratories and all of the world-leading certification bodies that are involved. And so in the United States, we have the National Renewable Energy Lab and PacWave, a large wave test facility for testing. In the UK, we have FlowWave, FastBlade, and EMAC that I mentioned earlier. In Spain, we have BMEP, which is the Biscay Marine Energy Platform, and we have IH Cantabria. In France, we have 2 test sites, Cineo and Ifremer. As we look at the certification bodies, we have some of the world's leading certification bodies with Class NK in Japan, Bureau Veritas in France, Lloyd's Register in the UK, and the American Bureau of Shipping in the United States. And so you can see, I hope, that our system in this sector have brought together the world's leading testing and certification bodies to provide independent third-party verification of compliance to standards. And now I really would like to consider and pitch for India to consider participating within the marine energy sector. I can share that India is currently participating in both the wind and solar sectors. This participation is managed by the Bureau of Indian Standards, and so I'm very pleased to have their participation in the symposium today. I would like to note that there is no additional cost for India to join and participate in the marine energy sector. So I welcome you and would encourage your participation. I would encourage and ask the industry to think about relevant test laboratories in India, to consider becoming renewable energy test labs. If there are any relevant certification bodies, to consider becoming RECBs. And I would also ask your industry to consider if there is an interest in the Indian marketplace for an inspection body category. And would there be organizations in India that could offer inspection services in the marine energy sector? And so these are opportunities for market development and market growth in your country, as well as to further engage and collaborate internationally. And I'll just reiterate my open call. We would welcome your participation in the marine energy sector of the ICRE. Your participation in TC114 has been incredible, and I believe you could make a similarly meaningful contribution to the work of certification within the ICRE system. Now, my last slide or two before lunch, I just wanted to give one quick example of what this looks like in certification. So I mentioned we have a test laboratory called EMEC in the United Kingdom, the European Marine Energy Center. They were accepted within the system, and they were recognized with a scope in the IEC standard 62600-200, which I think many of you may be familiar with, as it covers tidal energy converter power performance assessment. A customer, a tidal energy converter developer, Verdant Power, in the United States, hired EMEC from the United Kingdom to do an independent assessment of compliance to this standard at their Roosevelt Island Tidal Energy Project in New York City, New York. The technology was a tri-frame of 3 turbines, and EMEC was hired to independently provide third-party verification of compliance to this standard. Now, EMEC was able to verify compliance with the standard, and this led to the issuance of the first ever test report for marine energy within the ICRE system. The cover letter is publicly available and can be found through the ICRE website. However, the full report is protected as there is significant intellectual property. And now, what does this technology look like? And so I just wanted to quickly show you what an example of a tidal energy converter is. This is the Verdant Power tri-frame. You can see there are 3 turbines located on the edges or corners of a large black frame. This frame was lowered to the bottom of the East River in the middle of New York City and operated for nearly a year, generating over 350 megawatt hours of tidal energy for the New York City grid. Now, this example for me is particularly relevant because if you look in the lower left corner, there's a gentleman with a white hard hat and a yellow, orange life vest. That is actually me. I worked for this company for 15 years before starting my own firm, and I was the responsible engineer for the execution of this project and for the third-party assessment that EMEC conducted successfully. So I was very proud to develop this technology, but similarly, I was very proud to help write the standard that was used and to ensure and help ensure that a third party independently verified compliance to that standard for these turbines that you see here being raised off a barge deck in New York City. So I hope that's an interesting and relevant example of how standards and certification work together to help implement and validate a technology in the marketplace. Now with that, I'll close. TC114, their standards ensure a common language among stakeholders. They codify global best practices for our industry, and they provide the detailed how-to for design, testing, and other activities in our sector. Now, the conformity assessment system, the IECRE, helps to harmonize rules for testing and certification activities. It reduces barriers to trade and enables market access. And ultimately, it increases confidence in the technology and supports the commercialization and successful development of marine energy technologies globally. I'd like to thank you all. I hope I have not taken too much of your time. It's an honor and a pleasure to speak with you. And again, my sincere thank you to the National Institute of Ocean Technology for inviting me to your symposium. And I'm very sorry I wasn't able to join you today. Thank you very much.
Thank you. Thank you, Mr. Colby. I think it's late night for you there.
It's early in the morning. I am in Spain.
Early in the morning. Okay.
It is 8:30 in the morning my time. So not too bad. Not too bad.
Right. Before I ask, you have some time to ask questions? Right. In fact, thank you very much for enlightening us with the IEC, as well as especially on the TC 114. We are all part of this standardization in India. Part of it. Then I saw that we have something on river engineering as well, which is part of this. But then when you say river engineering, whether we talk about the estuarine part or only upstream of it?
We would cover all parts of the river where the flow was natural. If it was anything with the dam and hydropower, that would be under TC4. But for us, TC 114 covers all of the natural flowing parts of a river, from the fresh water through the estuary and into the ocean.
Okay, thank you. Then there's one more question from me before I leave to audience, is that when we want to be a third-party investigator in investigation, do we need to be certified first by some body so that we will be a certified agency to be a third party? So is there any plan?
That's a very good question. So for people that maybe aren't as familiar with this topic, there are national accreditation bodies that can accredit third parties to certain competencies, such as test laboratories and certification bodies. So to your question, accreditation is not mandatory, but it is accepted. The IECRE system uses a process called peer assessment, where the other bodies do assessments on new bodies that are applying to become these third parties. So if you do carry an accreditation, the assessment is streamlined. If you don't carry an accreditation, the assessment is more rigorous. So it's not a mandatory to be third party recognized, but it does make the process more simple if you carry an accreditation at the national level. I hope that's a helpful answer.
Yeah, thank you. Leave any questions from the audience? All right. If there are no questions, once again, we thank you for your time and then for your enlightening talk. Thank you very much.
Thank you very much. And I hope you all have a lovely lunch. And again, my honor to be with you. Thank you very much.
We would like to have you in person maybe next time.
Yes, please. That would be wonderful. I would love to come. I've been to Chennai once and I would love to come back. So thank you very much for the invitation.
Thank you. Have a good day.
Thank you very much, sir, joining online and delivering your lecture. Now that we come to the end of the session, may I now request...
Wait. So before he ends up, I thought I'll just brief on what we have heard so far. So we had talks from BIS. Rajiv Sharmaji and Ritvik has given a wonderful overview of what is standardization, why is standardization. Okay. And then in that, I wanted to add, if any one of you feel that something is missing, or it's a new process, a new technology, don't wait for somebody to tell you to go. You can straight away write to BIS and then say, yes, this is what I feel is missing. They have an agency or they have a procedure wherein they will check and then say, revert back to you and say, no, it's already there or it's a new thing. So that's one part of it. Similarly, if you have any process in your mind that you want to work on, go to NRDC, right? So they are the agency which will tell you it's already patented or not, whether it is possible for patent. So that's the second talk. Anything in international, yes, Purnima Madam is leading the BIS ETD 54 in marine. There are a lot of things which you have gone through. All of it is available on the net. So you can go through that, and then if anything is missing or you feel that you want to be part of it, you are welcome. Right? Thank you very much. Thank you very much, NIOT, for giving me the opportunity to chair this session. And we are slightly late, but then we are well in time for lunch. Thank you.
Thank you, Chair, for your valuable inputs. May I now request Dr. Sudhir Joseph, Scientist G in COIS, to present memento to Chair 𝐂𝐀𝐑𝐈𝐍𝐄 𝐑𝐄𝐍𝐄𝐖𝐀𝐁.
Thank you, everyone. Before we break for the lunch, I'd like to call upon the NRDC representative, Mr. Sahu, and Yalas Technology, the TOT partner for Roshni, to felicitate the pioneer in our field for marine energy, Dr. Purnima Jalihal, with a bouquet.
When we are celebrating Amrit Kal, actually we must have to celebrate those leaders who are making us proud. And today, this women leaders are playing a key role. And recently we celebrated International Women Day. Jatrana Arjasturamante Pujjante Tatra Devata. So it's my honor and privilege on behalf of all of us as a token of respect to Madam Purnima Jalihal. And also, please come, Madam. How we took the technology and technology become a product, and also mitigate the challenge of global world, and that to fulfill the demand during the blue economy when we are talking about. It's our honor to have Dr. Purnima Jalihal here, and also I would request Dr. Bhagyalakshmi ji, who is an entrepreneur from Yalas Technology, Visakhapatnam, and also she empowered many women in her company. I visited, madam, and also our team are also many of the women workforce yesterday. They were here. So it is truly, honor for us to honor you. And we are also getting such kind of privilege, and that's the role. Thank you.
Thank you once again, all. Thank you. Thank you, Mr. Jonathan. Nice to have you on this forum and speaking. Thank you for a valuable time. So now we break for the lunch. We'll be meeting here again before 2 o'clock to start the end of the session or end of the symposium. So request all of you join for the lunch. Thank you.
and solar energy production. Have you done any long-term prediction for the climate change on wind energy?
Yeah, we have done it. We have taken the retrospective data from all the LCMRF data, from ISROSCAT, and even from the European, website NASA. We have studied that there won't be much change in the climatological long-term intra-annual variability will be almost similar for the next 10-15 years. And with the P75 probability 75%, we expect in Tamil Nadu there will be a plant load factor of 49.5% to 50%, which is taking into consider all the losses, electrical losses, mechanical losses, and even EIA study we have done it, and they say that these areas are clear for all the project development.
Many countries, Europe has already done for 100 years prediction.
100 years we have not done at the moment. We have gone only for 20 years retrospective data. Okay, 20 years we have done it.
Yeah, I read that 150% variation some regions predict.
Maybe since this is a new industry, and when we grow and we learn with the experiences, we'll try to take the 50 or 100 years data as well.
Will there be any restriction for fishing activity in these two locations?
Yeah, there is a lot of resentment and resistance from the fishermen for this project. And the decision in closed doors in the government is that first we do the pre-project activities so that we don't tell them about the projects, and thereafter we will be having a stakeholder meeting with the local fishermen with the help of Collector Ramnathpuram and Tuticorin, so that we need to guide them in the regional language that these projects are going to benefit them in longer work, giving them a lot of employment opportunities. And anyway, this fishing activities will not be disturbed because of these offshore turbines moving into the sea. So that way it's only a matter of education, and I hope that will be done, and when we will do at an appropriate time, because for every activity there is a right time and appropriate time to do that. And probably once the tenders are being, the responsive bidder is being decided, at that point in time we will hold this stakeholders meetings, educate them and get going.
Thanks for sharing the quite good plans to deploy at this best wind sites. So here, what kind of water depths are there, and what are the water depth?
Water depth in this area is about 37 meters at this particular buoy location. It will vary between 37 to 42, whatever. But now we are doing a geotechnical study in the month of April to June. That will give us the precise information. But with the 𝐊𝐃 start and the studies which we have done earlier, that has been showing between 30 to 41 meters.
Okay. So essentially, monopile structure.
Yeah, we will go for a monopile with 60 meters depth up till the hard starter. And I think it will be 8 meters rotor dia, dia of the pile. And then that is the normal international practice for 12 or 15 megawatt. Maybe if the soil is very loose, then we may have to go up to 62, 65 as well.
In the Denmark and few other places, they are doing co-location of different energies. Like floating solar is being put along with offshore wind, like so maybe that also.
That is a long-term plan that their government is also thinking to, as I said, this offshore power will be utilized for powering the electrolyzers. That is one of our branch that we will be using it for production of hydrogen and ammonia. Then we also will have solar floating platforms, so that both complementing each other, we can have round the clock, 24/7, 365 days, the power output available.
Okay. Okay. One more question you can take. No more question there, then I can ask.
Okay, thank you so much.
I can ask, sir, one question. So what about coral reef? Is there any coral issue?
Tamil Nadu, I have not seen. I mean, nothing has been reported in the EIA reports. Even in Gujarat also, it is clear.
No.
Not there. Okay. Only thing they, at a little bit towards Sri Lanka, they are saying there is a lot of bird migration and that may hit the birds. But that is quite far away from our project sites.
Okay. Thank you very
much.
Sir. Thank you. Thank you, sir. Very nice presentation. And it's very much interactive. What about next?
Sir, I request Chair to present memento to Dr. Rajesh Kathiyal. It was very nice and informative talk. We were looking forward to your talk, sir. Thank you so much. Well, otherwise, sir, your face is photogenic. Thank you so much. We move on to the next talk of the afternoon. Dr. Mohit Verma from SERC, he's principal scientist, and he works in the area of structural dynamics. He will be talking on engineering of floating offshore renewable energy structures.
Thank you, sir. A very good afternoon to one and all present here. My name is Mohit and I'm from CSIS Structural Engineering Research Center. I would like to take the opportunity to first thank Purnima ma'am and other organizers for giving us this platform to showcase some of the work that we have been doing at CSIS Structural Engineering Research Center. So just to give a brief outline of where we are. So we are one of the 39 labs of Council of Scientific and Industrial Research, and we are located in Chennai. And we basically deal with the structural engineering aspects, and we cater to different kind of aspects such as basic research, consultancy work, and also strategic sector we are dealing with. So these are some of the thrust area that we are working in. And recently we have added one thrust area, which is the energy infrastructure. And I'll be showcasing the work that we have done in this particular thrust area. And to support our R&D activities, we also have 10 different laboratories, which supports the different kind of experiments that are required for structural engineering. So this is going to be the outline of my presentation. So I'll start with basically presenting the floating offshore wind turbine structure that we have taken. And there are various methods to analyze the floating offshore structures. And this include uncoupled analysis, coupled analysis, partially coupled analysis. So I'll be showcasing what experiments we have done for each of these analysis methods, followed by the future direction. So as told by Rajesh sir and also the efforts taken by the Ramanamurthy sir, in the MNRE and Ministry of Earth Sciences, we know that there is a great potential for offshore wind energy in India, and we want to utilize that. So that's why we came up with a project in SERC where we want to work on designing a platform for a floating offshore wind turbine. So with the great opportunity comes the great challenges. And these are some of the structural engineering challenges that I have listed here that comes once we go to design an offshore platform. So this includes structural health monitoring, the substructure design, the aerodynamic modeling and the hydrodynamic modeling, the stability and control of a floating offshore wind turbine, and also the fatigue resistance of the different components that will be used for floating offshore wind turbine. So to summarize these analysis method, they can be coupled into different forms that are shown here. So the first is the uncoupled analysis. So this analysis is generally done at a component level where we just want to understand the dynamics of a particular substructure. It can be either a platform or it can be your tower and turbine dynamics. And this also serves as a means to find out some coefficients which are required for doing the fully coupled analysis in some software such as ANSYS Aqua. And then we have the partially coupled experiment. So these experiments, we do not take both the substructures, but we just take first one of the substructure and we do forced oscillation. We apply a force instead of having the complete structure. So this gives us an idea how these loads are going to vary once we have some force applied to the substructure. And then we have the fully coupled analysis. This can be done in OpenFast or ANSYS Aqua. And in order to do the fully coupled experimentally, we have to go for the real-time hybrid testing. So to start off, we took a benchmark problem, which is a 5 megawatt NREL wind turbine, which is supported on the OC4 semi-submersible platform. And the dimensions of this particular structure and the details are given here. So what we did is first we made the two different models because we wanted to have the testing in the wave basin and also in the wind tunnels. We have a wind tunnel facility where we can test to evaluate the different loads that comes onto the turbine. So here we have the 1:50 scale model of NREL 5 megawatt wind turbine supported on OC4 platform. And then also we created a model, a 1:200 scale model for wind tunnel testing. So to start off with, we went for the coupled and uncoupled analysis. So here I've shown the workflow where when you want to go for the fully coupled analysis, we need certain hydrodynamic coefficients, and they are usually evaluated by conducting a free decay test in a wave basin. So what we did is that free decay test can either be done in a wave basin or computationally using CFD analysis. So first what we did is we did this free decay analysis. We didn't have a wave basin facility, so we wanted to test in the still water condition. So we calculated the natural period for this platform for 2 different degrees of freedom in a tank of size 3 meter into 4 meter. We do understand that there were some limitations because of the reflections that will come from the boundaries, but nevertheless, this test was important for us to know whether the frequencies are coming close to what we expect or not. We also carried out the CFD analysis for the same semi-submersible platform, and we've evaluated the heave period for the platform. So here are the results that we are obtained, and here we can see we did the experiments only for 2 degrees of freedom because of the limitation of the testing setup that we had, and we got the values which are very close to what is reported in the literature. Although there is some variations, as I explained, it can be due to the boundary effect or because of the weight that we added in the center of the platform to give the pitch degree of motion. So we also did some partially coupled studies. We have initiated those experiments where we want to simulate the motion of the platform, and in order to do that, we are using a shaker system. So here you can see this is a wind turbine 1:200 scale model, which is put inside a wind tunnel. And in order to simulate the motion of the floating platform, we are using a shaker assembly. So here we are doing the forced oscillation where we give the different motions to the base of the platform, and then we try to understand how the loads that are coming on the turbine are affected. So after that, we have to go for the fully coupled analysis in order to get the true response of a floating system. So for this we have carried out by coupling 2 different softwares. So one is the OpenFast, where we do the aerodynamic and the tower simulation, and the other part is the ANSYS Aqua, where we do the hydrodynamic part. So whatever hydrodynamic coefficients we obtain from the free decay test are given as input to the ANSYS Aqua. And in order to make them interact, these two software interact with each other, a dynamic link function is created such that two different softwares can interact with each other, and we can get the fully coupled response of a floating offshore wind turbine. So here is the simulation that is shown for one of the load cases, and similar studies have been done for different other load cases that are given in the IEC standard. So after that, we don't want to stop here just with the obtaining the response of the platform, but since we are the structural engineer, we have to do the structural analysis as well. So this can be done by mapping the pressures that we obtain from ANSYS Aqua onto an FE model, and then we try to see what are the stresses that are going to come on the platform. So suppose if we come up with some other configuration, and if we have to design the platform for different load condition, we can actually check whether the material or the sizing is correct or not, or we want to provide any other internal stiffness in order to resist the loads that come onto the platform. So finally, when we go for the experimental testing, it is very difficult to do a coupled analysis for two main reasons. Because we are scaling down, your aerodynamic part is scaled based on the Reynolds number. However, your hydrodynamic part, the scaling follows the Fruit's law, Fruit scaling. So these two becomes difficult to satisfy for a particular scaled down model. So this is usually done using real-time hybrid testing. To briefly explain what is real-time hybrid testing is, let us assume we have a structure here, a base isolated building. And what I do is, instead of testing the whole structure, I partition into two different parts. The top part is the building, which I call it as a computer model or a virtual substructure. So I model it using a computer simulation. And then I have the second part of the structure, which is the base isolation. So this is the part of the system which I do not have good knowledge, or which is difficult to model. So that we physically test. And then we make them interact with each other with the help of an actuator or a shaker. So this can be viewed as very similar to your finite element analysis. But in this, what we have done is we have taken one of the finite element and brought it to the real world. And the interface and the continuity equation we are trying to apply with the help of an actuator. So once we go for, let's see how we can do the hybrid testing when we go for floating offshore wind turbine. So there are three different ways in which this can be done. Let's say we are doing the test in the wave basin. So there my platform hydrodynamic part is going to be the real physical substructure. And on top of that, we place a shaker assembly which simulates the tower load. Or it can be done in a wind tunnel where my actual part is the wind turbine. And at the base, I have a shaker assembly as I showed, which will be simulating a computer model of my floating offshore wind turbine and the hydrodynamic condition. Some people have also tried to use the third configuration where they use some fans to apply the thrust forces that will come onto a wind turbine. So this is how we go for the wind turbine experiment in the wind tunnel. This is the flow of the information. And here, I can play it, but here is an example of how people are doing the hybrid simulation for floating offshore wind turbine, where the base assembly is actually simulating the motion of your floating platform. So we also try to use artificial intelligence when we go for this real-time hybrid simulation. So here is the flow of information. Actually, in real-time hybrid simulation, you have to solve the computer model in real time. So these models are very computationally expensive, and they becomes difficult to solve. So in order to replace that, we have proposed a Gaussian meta models, which are based on Gaussian process regression. So these models are much faster computationally, and they can be used for conducting the hybrid experiment. So that's how we have done. We generated the dataset based on the OpenFast simulation. And then we formulated the Gaussian process meta models for the platform dynamics. So here is the correlation shown between the platform motion that was predicted using the meta models and what was actually obtained from the OpenFast. So we also did the hybrid testing for tune mass dampers for wind turbines. So wind turbines are subjected to extreme harsh conditions, and people have proposed to use some kind of a damping device such as tune mass damper, which can reduce the tower vibration. So in order to validate the TMD design, what we proposed for this wind turbine tower, we can use hybrid simulation. So here you can see the shaker that is placed inside the nacelle, which is the prototype of this tower nacelle assembly, will simulate the aerodynamic loads as well as the reaction forces that will come because of tune mass damper. So here is the control loop for that. So our virtual system is a tune mass damper system and the aerodynamic loads, and our tower nacelle assembly is the physical substructure. So we designed the controls for the shaker such that it applies the same forces that a tuned mass damper is going to apply on my tower nacelle assembly. So this is a control design problem for evaluating the optimal TMD. Why we went for optimization was we can add additional constraints for the TMDs, which usually exist, such as the limits on the displacement or the uncertainty that we can have in the properties of the primary structure. So if we formulate a problem as an optimization problem, these additional constraints can be accounted. So here is the experimental setup so here we have a prototype nacelle and tower assembly. And inside that, we have a shaker which is simulating a tuned mass damper. And the experimental response and frequency and time domain is shown here. We can clearly see that the tuned mass design damper is able to reduce the tower frequency. Beside this, we are also working in other areas. We have a fatigue and fracture lab which works on the fatigue load evaluation for the joints in the offshore structure. And we were also working on designing of a support structure for a solar farm. Design of a space truss has been carried out for supporting a solar farm. So for future roadmap, we have few projects in mind. So we have a facility which is 14 meter deep. So in that, we can actually put a wind turbine tower and do soil structure interaction studies. And we also have a different location. We can do the multi-support excitation experiments so that we'll be able to apply the wave loads and the aerodynamic loads with the help of an actuator. And the other project that we have in mind is one of the questions that was asked by the audience last time, which was a combined system which will support both wind turbine and solar panels. So if you look at the current system, they're usually very large in size. So it becomes very difficult to transport them. And if you go for a very compliant structure that we usually use for the dams, they cannot survive the harsh wave environment. So we want to come up with some kind of a partially compliant configuration, which will be able to serve both the purpose, have rigidity and also balance the compliance part. So these are some of the projects that we'll be working in future. Thank you very much.
Okay. Few questions, 2-3 questions we can take. Some questions. Shanti. Wonderful. Nice presentation. One thing which I missed or is not there is we have all the experiments.
Yes.
It's only in the horizontal shaking, right?
Yes, sir.
Not in the vertical.
So actually our initial plan was to have a Stuart platform kind of a configuration which can give all 6 degrees of freedom. But because of the purchase procedure that could not go through, so we had only the horizontal shaker available at that time. So we are actually designing a test rig where we can do the pitch and other degrees of freedom also.
Okay. One more thing in the last slide, your future roadmap. What's the time frame you are thinking of?
So we have submitted proposals for this particular project, sir. This one. So we currently have a floating offshore, this Flowtech FTT going on. So we are working on this. We are halfway through, but we have not done the experiments yet. So that's why I have not shared that. So this project is going on and is expected to get completed in March 26.
Thank you, sir. Thank you for the nice presentation.
Thank you.
Yeah. So in a hydrodynamic analysis, you have analyzed heave and pitch individually, right?
Yes.
But sir, in a real scenario, parametric resonance might happen between heave and pitch. A parametric resonance. In technical language, we call it Matthew instabilities also. When device is not oscillating, heave and pitch happen at the same time. Because of that, earlier resonance will happen. So how you are going to tackle that thing, sir?
So when we do the coupled simulation, those things will be happening together only. So the initial experiments that we have shown was just to evaluate the hydrodynamic coefficients that you give as input to your ANSYS Aqua. So for that degrees of freedom alone, we have tested. But once we do the simulation, all these things will be happening together for a particular environmental condition. So it's not in isolation.
Okay, so you are saying you will couple heave and pitch. After that, the turbine, whatever pitch is happening, you're also coupling that also.
Yes. So it's like a matrix.
Okay.
It will be a coupled.
Okay. Thank you. Thank you so much.
Thanks for this very wonderful presentation. Very nice.
Thank you.
You have done your best, both from simulation and also from the experimental model. So that updating is quite good. Question is like in your fully coupled model, have you taken the force frequencies? Like for example, the 1P, 3P kind of like a tower shadow effects and other? Not yet. No. Maybe from your model, now that you have calibrated them to some extent, you may need to study and the rotation conditions for the chosen wind turbine. What kind of frequencies, because when the blade pass frequency comes, then how that effect would come.
So, sir, when we actually did simulation in OpenFast also, where that takes into account the different wind speeds also, and the turbine controller also it takes into account.
Okay.
So cut in speed, cut out speed. So there.
That is okay. But when the blade passes the tower, you have a shadow effect. And then that part, in practice, that is a big challenge. Second, also my observation from my own experience, these small oscillations, people will say that I have parked my wind turbines, like they will lock and keep. But in reality, what would happen is these slow motions of the ocean one will affect the drivetrain of the wind turbine. You have a lot of fretting wear in the bearings and other. You have start getting iron powder like in the bearings, literally. So those parts we may need to also simulate, like the way you did the shaker test. One has to also study on these drivetrain.
Thank you for the suggestion. We'll look into that, but majorly we concentrate only on the design of the platform part, because turbine internal mechanisms right now we are not modeling or even in the testing. We just put a motor to.
Yeah, exactly. But in the wind industry, especially offshore, still the wind turbine manufacturers, they only focus on the wind turbine. In fact, like the old generation, like I was with Vestas. So old generation wind turbines, you can see there was no sensor input from the floaters also to the controls. Only now they are taking a little bit into that. So that's why they will assume as if it is onshore. Okay, we did a Portugal deployment with a tripod design wherein a V82 turbine was put on top of the floater. And for 6 months it was put, but it turned up quite good. Like for 2 years it ran quite well. But later in the Hornsey project and few others you can see in the websites, lots of gearbox failure happened. 2 or 3 times a gearbox is brought back to shore, then all the profit is gone. So that's why these fretting and all these aspects also we have to take into account.
Sure, so we'll have a look into that.
One more suggestion is you should also study with the same configuration. Is horizontal axis better or vertical axis is better, so that we can bring down the payload to the barge itself, like.
Yes.
So
actually, sir, I did not explain the last one that we are doing. I think sir also explained you can't put 2 vertical axis wind turbine close to each other because of the wake effects.
No, that is going to be wake is going to be in horizontal also. No?
We are also working on one platform configuration which supports both solar and vertical axis wind turbine, so that we can place them in between and utilize that space so that we'll have more energy production per unit area.
Yes.
So there are 2 configurations that we are studying, but I'm not.
Correct. Because the reason is in the offshore side, since turbulence is much minimal compared to the onshore, you don't need to have taller wind turbines, correct? And having such a big payload above the tower brings a lot of instability. So vertical axis is better, but the industry is not anymore working on that vertical. Last time they used to do the egg beater design. Like yesterday, one speaker showed the egg beater design, like vertical axis. So such similar configuration we may need to again study. Instead of going for horizontal axis, we should also look at whether vertical axis is better because of the omnidirectional capability and other. Okay.
So that configuration also we will be studying, sir, in the wind tunnel test to see what kind of load comes on the platform for the same wind conditions, so that we can have a comparison for the two. Thank you, sir.
Okay, thank you. Cannot take more questions. We have to go to next presenter. Thank you very much, Mahit.
Thank you, sir.
Requesting chair to present memento. This is the last talk of the symposium. Obviously, this will be followed by a panel discussion and validatory function. This last talk is on flexible responsive systems in wave energy, an alternative to conventional wave energy converters design by Dr. Krishnendu of the University of Plymouth. Dr. Krishnendu, request to you to briefly discuss, present the things. We are running out of time.
Thank you. Good afternoon, everybody. First of all, I'd like to thank Professor Balaji Ramakrishnan, Dr. Purnima Jalhal, and team for giving me an opportunity to be here in this symposium and present the work recently I've been involved with, which is a flexible, responsive systems in wave energy, an alternative to conventional web design. So this is the outline of the work. So briefly, I'll be going through the conventional WEC designs and the challenges, then the flexible WEC, different flexible WEC based on the operative concepts. Then the project, what was the aim of the project and the research program there, and the hydroelastic experiments which was conducted to study the flexible material responses for different wave conditions. Then the system feasibility study, hydrodynamics of the clamp model, the variable capacitance metamaterial power takeoff system, and the concluding remarks. So yesterday and today we have actually got a good idea about how much potential we have in our the wave energy potential we have, and also different different wave energy converter devices which we already have tested, and it's all in the R&D stage, and there are few tested structures available. So I'm not going through the conventional rigid WEC designs again, but I would like to point out the challenges in this WEC design. One is the seasonal variations in the wave direction, and also the survivability of the structure in extreme C scenarios, or the critical stresses on the structure, and it improves the survivability of the structure. And also this can actually include a lot of various power takeoff systems, which can be like a air turbine or a new electroactive polymer materials or novel dielectric elastomer generator. And also this can bring the light weight of the structure. That is when the component is rigid, so the structure can be huge. And these kind of flexible structures can bring down the weight of the structure, and this can minimize the collision risks and making them a safer option for co-location with the offshore wind farms. So just briefing through different flexible wave energy converter based on different membrane the operating concepts. So we have membrane cell. So this is a floating air bag. So here we can see that the membrane, we have like a membrane, a deformable membrane, which is attached to a boundary, and there is an air filled in the structure. So with the deformation of the membrane, the air is inside the structure is forced out and inside, and this can be, the variation is this air changes can be captured using a power takeoff system. And the power takeoff system can be a pneumatic one or a dielectric elastomer generator. Then there another kind of flexible WEC is a bulge wave, which is it can be oriented perpendicular to the wave crest, and it is a tube filled with pressurized seawater. And this is also like Anaconda, which is a model which was tested in University of Southampton. So this can also use the dielectric elastomer generator as the power takeoff system. There comes another type of flexible WEC, which is wave carpet. So it has a free end boundary condition, and these are held via tethers or hydraulic pistons and can be installed at the sea surface, at the seabed or slightly above the seabed. And these are the few flexible WEC options we have currently. So FlexWave project is an EPSRC funded project, which was led by Professor Deborah Greaves from University of Plymouth in collaboration with University of Southampton, University of Oxford, and other industry partners. And the main aim of the project was to bring a step change reduction in the cost of energy and a pathway to utility scale and niche application of the web designs through the use of flexible responsive systems. So the whole project was divided into three different key areas. So we wanted to bring an origami part into the structure. So origami is a new thing coming to the wave energy converter. So it's basically there'll be like a folding and opening of the structure, which can reduce the stress on the elements. So we have one of the postdoc working in University of Oxford who was focusing on developing the design and analysis of the origami-inspired flexible energy structure. Then another part comes, we have different polymer materials available. So there are a number of polymer materials which can be suited for developing such a device. And we need to have like a testing on these materials, and also we need to see if that can be manufactured. Then the seawater agent and all that goes into this part of the research. And there comes the hydrodynamic assessment of these flexible web concepts. That's where I'll be dealing more with. So initially we did a preliminary investigation to understand how these flexible membranes respond with wave conditions. So in the waveflume facility at Coast Laboratory in University of Plymouth, which is a 35-meter long and 0.6 meter wide flume, we have tested 4 different materials. So there we have taken neoprene rubber, which is of 3 millimeter thickness. Then there is neoprene rubber, which is reinforced with nylon fibers, which is again of 3 millimeters, and also polyurethane and silicon, which is of 1 millimeter. So we selected 4 of these membranes, and we are testing the hydroelastic responses of these membrane in the water. So one of the challenge in these experiments was that, so basically when we had these rigid structure experiments done earlier, we could have some of the the instrumentation side, how we get these deformations, how these nonlinear responses can be measured was not a big challenge. So here we tried with strain gauges, flexible strain gauges. So one part was to have it like proof, underwater proof. So we had adhesives added to the flexible structures. And the moment the adhesive was added, it became more rigid. And the moment we took that flexible strain gauges and attached to the membrane responses, that part became rigid. So there comes a need for like having a non-contact measurement in this case. And ultimately we went to adopt an underwater laser distance sensor to measure the material response. So this was the layout. We at 6 different locations, the response of the hydroelastic membranes were measured, and there were wave gauges attached installed in front of the structure and behind the structure to measure the reflection and the transmission characteristics, and also the incident profile. I'll just go to the so these are the few videos of flexible material interacting with the wave. First one is the neoprene rubber for a regular wave of 1.75 hertz. So what we did was that we have selected 3 different wave frequencies based on the ratio. So we took the ratio of the membrane length to the wavelength ratio as 0.5, 1, and 1.5. And we wanted to understand the interaction of these for different wave amplitude. So we increase the amplitude from 0.001 meter to up to 0.025 meters. So here I've actually provided, so in the silicon case, we can see that there's like a good amount of non-linear, the moment we got the data, we could understand that the whole responses were non-linear. And yeah, I'm not sure. Okay, for the neoprene rubber, the responses were like really low. And for the silicon material, which is more of lesser thickness, which is 1 millimeter, and also more flexible material, so it had like a larger non-linear responses. Here I've actually just discussed on the membrane response for the neoprene rubber. So the hydroelastic response signals, which we got from the experiments, were analyzed using Fourier transform analysis. And for each of these wave amplitude, 0.1, 0.001 meter, 0.002 meter, 0.005 meter, and 0.001 meter, we could see that as the wave amplitude increases, we could see there is there is an extra element which we can observe in this data. So that is like the material is found to excite at a lower frequency. In this case, it was 0.2 hertz, and we suspect it may be a fundamental frequency of the membrane. And also the peak vertical response was observed at the fundamental wave frequency. And the whole thing, like the whole setup, but we had a lot of tuning initially to like have this membrane testing done with the highly nonlinear responses. We had to like include a lot of extra tensors to keep it in position and things. So currently we are on publishing the paper. So we'll soon have the paper published and we'll have the results more in the paper. So from there, we move to understanding the system feasibility. So we have already told that we had some of the flexible VEC concepts available, which was SQ1, which is a floating air bag, then Anaconda and a clamp VEC. So these potential wave energy converters were analyzed, and since we had this origami part into the structure, the clamp VEC is the most suitable structure where we could actually bring in the origami also into the structure. And the suitable potential part ecosystem can be an air turbine generator or a dielectric elastomer generator. So we have two configurations being tested. And here we can see these. So again, in this case, we have two rigid walls, which is the clamp wall one and the other side. And these part will be the flexible structure. So one of the configuration had this part as flexible alone. And on this configuration 2, we are also trying to bring in more of the flexible elements into the structure. So currently, again, on this, we have applied for an UK patent. So I can't have the most of the design discussed in here, but we have like a good origami panel here, which will keep the structure to move in a, so the equilibrium angle at which the structure will be floating will be like 20 degree to one side. And we have a clamp to like move from plus or minus 20 degree. Another challenge in this case is the power takeoff system. So whenever we take a wave energy converter, the experiment, so we need to know how we can actually provide the power takeoff force into the structure. So again, we wanted to bring in a bit of a flexibility to the experiment. So we have actually took a pulley box drive arrangement where we can see that these, it's more like a hinge wave paddle. So we have the this panel with slots attached to the clamp wall, and there is a pulley bearing arrangement here and the motor. So the clamp wall, we wanted also to control both of the clamp wall individually. And so we had like, and we also have a plan to have different panels, flexible panels included into the configuration too. So in total, we had 8 motors fixed inside the structure, and this 4 on each side. And I've already told that we wanted to like have a clamp action amplitude going up to plus or minus 20 degree. So the system is developed to accommodate different power takeoff systems. So as I've already mentioned, we were planning to have like an air turbine structure, then also a dielectric elastomer generator. So this will have a flexibility to include different power takeoff system by controlling each of these motors. So again, that was another challenge part in this experiment. So we had a lot of time spent on sorting how to control these motors in synchronous mode. And yeah, there was a lot of electronics part, which wasn't like a main area for me. But yeah, it was a good learning curve there. And a few of the bench test cases were done to see how this control part we were able to like implement it. And then implementing these electronics inside the structure for the hydrodynamic testing also was a challenge. So ultimately, the this structure is in water and the testing is ongoing. Yeah, I also wanted to bring in a bit on this variable capacitance metamaterial. So that's the dielectric elastomer generator also to this topic. So these are like, it's not a new area, but there is a lot of research going on in this area. But these are like polymer material, which can actually be electrically activated, and the stretching and, compressing of these structures can actually give in. So it will be more of a new area in the wave energy converter if it can be brought, and more research is needed in this area. So I thought it will be a good platform to bring in this subject here. So it's based on electromechanical coupling of dielectric film. So basically we have a film and sandwich between two flexible electrodes. And this, when it is stretched, and we also need to like preload the dielectric material with low voltage, and then as the film stretches or compresses with the external mechanical force, the thickness decreases and increase in the surface area. And once that is increased, there will be the reducing distance between the electrodes and increasing the capacitance. So what are the advantage of these dielectric elastomer generators? So basically they are soft and can be incorporated into a deformable structure. And also one another major challenge is that we need them to survive in the harsh marine environment. And the challenges in here is it is having it needs like high operating voltage. Then there is material fatigue over time. And also the stability of these electrodes is also a concern. So we need a more laboratory setup, like a high voltage testing setup to develop such dielectric elastomer generator. Yeah, I think that's my last slide. So to conclude, concluding remarks, I think I'll just skip the other points. It's just where we stand now. So let's together harness the vast ocean energy potential out there with innovative and efficient designs. So thank you once again for giving me this opportunity. Yes, thank you. I hope I didn't run through the presentation.
Thank you, Kishan.
Thank you.
Some question you can take, one or two?
I think there is one.
Okay. Yeah.
Yeah, thank you for the good presentation. I have one doubt. Which material you have chosen at the end? I mean, among the four.
So we have a combination of this neoprene rubber, silicon, and also the neoprene rubber reinforced structure. Because since we have the origami coming into it, so we need like a combination of all three.
Okay.
So apart from polyurethane, we'll be like having these structures included in the structure.
Okay, you have included all three.
Yes, we will be. And currently, the design, we have like a bit of a polycarbide material to give that flapping.
Okay.
But our plan is to like have this polymer, apart from polyurethane, there'll be a bit of silicon because that will be more of a dielectric generator. Then there'll be a bit of this neoprene reinforced structure and a bit of neoprene rubber also.
And one more question is, have you checked the depth? What is the best depth to get the energy from the surface of the water?
This structure we have designed for 60-meter water depth.
60 meter.
Yeah, 60.
And which one was performing better? Which material was performing better?
On the material side, so it's basically we wanted to just have a feel of these material, how these respond. So that, and when it comes into the origami structure, it doesn't have much of, influence on it. So that's like standing independently. On the preliminary investigation, we could just understand the, the challenge in which we are actually going to. So that experiments didn't have like a lot of influence on designing finally on the origami part. But we could understand it's going to be a challenge, like how we actually include these flexible material, like over the hinges also. That is also a big concern. So yeah.
Thank you. Thank you very much.
Thank you.
Good luck with your PhD.
Postdoc, yeah. Thank you.
I think no one has, I have a question.
Yes, sir.
So you said 60-meter water depth. 60 meter means like it is wave energy converter and wave is surface phenomena and you're putting at 60 meter. So how this wave effect will be there?
No. So it's a floating device. It's a floating device. It will be installed in the 60-meter water depth. Like we designed the structure for the 60 meter, but it's a floating device and it will be flapping with the wave.
Okay, so like how the wave effect will be going to 60 meter. So wave will
it will be hitting at the structure itself.
Okay, so it's so long.
Yes. So no, we have like a submersible, and it will be like a 20-meter. So there will be like a 12.84 meter depth of submergence of the structure.
So then another is triboelectric nanogenerator and your one. So did you compare which is better?
No, we couldn't actually with, that was also a plan where, that is also like a feasible structure, but it requires a more research area on that power takeoff system itself. Yes.
Okay. Okay, thank you.
Thank you.
Okay, thank you very much.
Thank you.
This ends. Some more question. What you? Quickly one only. Scaling.
Material scaling is another big challenge. I think with the dielectric element, that's another again a research area going on. It's hard to like scale down this material. So that's also like so basically major part was focused on studying the hydrodynamics of it. Material scaling again. It's open to the new research area. We can have like area where we can have more projects to look into the material scaling. It's on the like it's a PhD topic now. Yeah.
Okay, thank you. Thank you. Oh, you want to? So, over to you. Thank you.
Dr. Krishnandu will receive memento from chair. And I request Dr. Srikanth to give memento to Chair Dr. Samad. Thank you, Dr. Samad. We will have panel discussion next as the next probably the last event of the symposium, and after panel discussion we'll have a valedictory function. We will need some 2 or 3 minutes break. We'll just make the arrangements on this. We are almost ready. The members who have accepted to the experts who have accepted our invitation to be part of this panel discussion, we are thankful to them. So I request Dr. M.A. Atmanand, former director, to come on the stage. Dr. J. Ramdas, former director again. Dr. M.V. Ramanamurthy, Mission Director, Deep Ocean Mission and Director, NCCR. Please come on the stage. Dr. Srikanth, Program Director from NTU. Dr. Purnima Jarihal, Group Head of Energy and Freshwater and convener of this symposium. And the odd man out will be myself to facilitate the discussion. Because I won't call it as a moderation. So this is the last feature of this event. We have been deliberating, sharing our thoughts about marine renewable energy status in encompassing a very wide variety of technologies, right from the resource assessment to the technology demonstration in India as well as abroad. So with this background, essentially now this discussion and the opinions of the experts who have really spent decades in the areas related to marine renewable energy, it is very obvious that we request them to share their thoughts. So essentially, I will not really give any more introduction because a lot of discussion already has happened. So I'll straightway start with requesting our expert members to share their thoughts on the 2-3 layers essentially. The first one of that, essentially, we can just talk about what you think about the renewable energy scenario in India and obviously its importance in the today's context. So, and obviously marine renewable energy, where exactly it fits into this mix. So I'll request I will request Dr. Atman to share your thoughts.
Thank you very much. First of all, before starting, I would like to orally felicitate Dr. Purnima Jarihal, who will be, after serving NIOT for many decades, we also worked together in various areas, starting from the wave energy project at Vizhinjam in Kerala, then the UTEC, then the desalination, all of them. And I would like to first compliment her before starting the actual presentation. Thank you, Purnima. And so now coming to this aspect which Prasad has given, I have just got some information. So what I find is that the renewable energy, as I understand from various references, that there's a lot of progress in India. If you talk about non-marine itself, the solar power has experienced about 30-fold surge from about 2.5 gigawatts in 2014 to 94 gigawatts by November 2024. That's really great. And wind from 47 gigawatts in 2014 to about 99 by 2029-2030. So in 1 year, it is said, this reference from PIB, so is from 2023 October to 2024 October itself, installed capacity, there's a surge of about 13%, which is quite impressive. But coming to marine renewable energy, Unfortunately, the growth has not been so great. As we all know, an IoT was born from IIT Madras, and the first project was the Vinyam project. I think everybody knows about that, which I happen to be also working in that project in the initial stages. We had enough information, and after that, the plant was closed. A lot of experimental data was obtained. Then we moved to OPEC, which is the most important requirement for the country, and it slightly changed to desalination also. And again, now OPEC based desalination plant. Of course, Purnima will be talking more about that. Is just about to be commissioned. So, apart from these two, if you see, the other one is only the one which Dr. Katyal explained today about the offshore wind. A lot of work is going on in offshore wind. But still, if you ask how much of power generated and put in the grid, as on date, it is nothing is there. And OTEC and offshore wind and offshore floating PV, that's another one which is there, which is also in a small way, it is there, but nothing which can be really called as some high generation capacity or so. So I will not talk more now because others are also there. With this, I will just say that India is moving, but not enough, so to say. Thank you. Next round, we can speak something.
Thanks for that. What is that called? That's opening pitch. So I request Dr. Ramdas to share his thoughts.
Thanks, Dr. Prasad. Dr. Atmanandan congratulating and felicitating Dr. Purnima. But anyway, I don't want to dwell into that one. I can't imagine that I would come to NIOT and I would not be meeting Dr. Purnima. So I don't want to think about it. Yeah, actually coming to this thing, renewable energies, I remember Gartner's hype cycle. Always one novel idea comes up and a lot of expectations are there and a lot of money is poured into that one, and it is hyped up like anything. Suddenly, after some years, actually there is some reality, actually check is done, and people say that it is not as good as what we thought it would be, and all. And there will be some kind of disappointment. There is a valley of death. Then funds dry up and all. And slowly the technology develops, matures and all. And again, we reach some plateau and all. I don't know where we are actually. And I don't want to go into the figures, but all over the world, there was an intention to move towards renewable energies. But if you see now US, they are actually now climate change skeptics. I don't know how much they'll be contributing to this one. Russia, of course, they have their own oil, and with Arctic actually becoming more land becoming available and more oil and natural gas available, I don't know how much they'll go into that one. Of course, Europe is, they are achieving almost countries like Sweden and all 50%. Okay, but I don't know whether you can call hydropower as the renewable energy. If you can call it, yes, that plus offshore wind is actually driving them actually. Coming to India, of course, we are in the tropics and we receive the most solar energy, but unfortunately, we don't have that kind of wave energy. We don't have that kind of tidal energy, and we don't have that much. Means like to say, wind also. I don't know how much we have. Still, the studies are going on for that offshore wind also. How effective it is and all. I don't know how much we really can contribute the marine side. I don't know, but this reminds me of my earlier experience. Actually, it doesn't stop trying these things. When I was working on gas hydrate, somebody asked me in one press conference whether gas hydrate is the future source of energy. I said, I don't know. Then they said, is it not the future source of energy? I said, I don't know. They asked me that then. Told them that because I don't know, I should know, so I'm working on that. So it's really worth experimenting actually. And as Dr. Purnima used to say, every watt counts. And I also add every drop counts.
So we have to do horses for the courses. So we should not say that, okay, 𝐶 will solve all the problems or 𝐶 will not solve. It's not like that. At some islands like this, LTKD effective. So at some places, and even in islands and all, they're asking for the wave-based that buoy like things for charging their devices and all. So we have to adopt. We have to adapt and adapt actually. So we should not throw the with the bad water. Okay, so these are my few initial observations. Maybe we'll come to the next round. I'll be able to say more. Thank you.
Thank you so much, sir. Dr. Srikanth, please. Dr. Srikanth also brings a perspective from abroad, and quite likely the way you presented your work, well, it was quite impressive, and the kind of the wide variety of initiatives that Singapore has been able to take. Maybe that perspective also is not only in the opening pitch, but somewhere down the line. Please talk about that.
Exactly. Yeah. Thank you. Thanks for this opportunity. And I want to thank specifically Dr. Purnima for giving this opportunity to come and take part in this excellent event where I could meet all the experts of India at one place. So this is a very memorable event that I participated. Talking about global level and versus India's scenario of ocean energy adoption is similar. This is the same situation happens like elsewhere also. But one thing about beauty with India is India in its path towards a developed nation. Okay, you could see that every energy, because there is energy craving, okay, the supply is catching up with the demand. And in fact, you can see that significantly any energy not being delivered, as I said, from economist point of view, 15 times there is financial loss to the industry. Second also is the challenge with renewable as such is always energy availability and place of demand is sometimes different. Like if you see in China, for example, the Inner Mongolia has very good wind, whereas Shenzhen, Shanghai has high energy demand. They also put in large HVDC cables and bring the power. You have lots of transmission loss, etc. So every country has its problem. So I see with India, like there is a very good effort in these decades, especially. Okay, and you could see that when we see our own counterparts of other institutions like ISRO or other, which even underwent embargo in the 80s, 90s. Okay, still it has become a world's best cost-effective satellite launchers and rockets. With so minimal. In the 80s and 90s, you know, like a lot of challenge was there. But now today, it has become a world's best example, like similar to a Tata Nano. Like, okay, it has got that kind of a global perspective. The same holds good for this ocean energy also. Like, you believe or not, you take a look at it, all the technologies that has been devised out, even the OTEC, like NIOT has spearheaded very well, you can see that the technology is so simplified, so modularly designed, etc., that now today it is for the industry to take it, goes for economies of scale, and even economies of geometric scale. So that's what the morning presentation showed. So once the sizes at megawatt level reaches, you will see that the cost, like both the capex, opex, as well as the levelized cost of energy will come down quite good. And NIOT also has neatly identified islands as the early adopters. So usually for new technology, when technology push is happening, you need good adopters. Whereas in the case of this ocean energy, you have both sides. There is a market pull also. Okay, because we want to, at a national level, there is a goal to displace of carbon. And so therefore, there is a very keen interest, okay, for clean renewable. Ocean energy, the beauty is because of the water's density, okay, compared to even wind and other, this is the best. No doubt, as Professor Ramdas pointed out, the renewable energy here in this tropical belt is lower than that of we don't have those Coriolis forces and other that happens in this temperate waters and temperate climate. But however, we have to, this challenge becomes opportunity for the research community to tailor make towards these regions. Once done beyond Singapore, beyond India, like you can see, the neighboring countries and other will all be supported. The whole tropical, let it be even Caribbean islands, to all these places we can use the same. Like, so that's what is the incentive for the industries to take it forward. So that's what I see. Lots of things. Like today, every kilometer of subsea cable costs $1 million. So if green hydrogen comes on board, then we can store energy as green hydrogen or hydrates, and we can take it easily towards shipping. So every time we have to convert this challenge to the opportunity. Being in Singapore, for example, for every headcount, I have to go for a visa. The institution will give a job placement, but a visa may not come. But here you are blessed with young brains, like the average age is only hardly 23 or something, we can say. So that's the beauty of India. So I'm very 100% positive that very uniquely designs will come out that are very commercially and scalable. So that's where is the future I foresee. Thank you.
I think one part probably we would have hit upon was the human resource, but you, I think, just mentioned that part also. And sometimes it is a realization that, yeah, that also can be a huge asset that we probably need to tap furthermore by proving that. Dr. Purnima Jalihal, your thoughts?
Thank you. So, since I have been like sort of pushing uphill for the last 2 decades in this field, I have a lot of things that I can say, but to keep the long story short, first of all, my mantra is watt to megawatt. You know, there is this tendency in policymakers to say that, oh, you have to be 2 rupees per unit, otherwise it has no value. But, you know, solar has become 2.2 rupees per unit after 45 years. It used to be 45 rupees a unit when it first started, and nobody wanted to put a solar PV plant anywhere in those days, 3 decades ago. So things have to mature, and it happens with time. Then there are perceived risks because it is offshore. India still doesn't have the proper wherewithal to do offshore related tasks, and we need to work on that. But having said that, we need to have actually an open-mindedness for small off-grid units, because we have lots of places in India where there is a utility for small off-grid units. It doesn't have to be megawatt range all the time. Then the second level is the, you know, kilowatts kind of ranges, where right now what we're doing for the 𝐷𝐾 power desalination is only 65 kilowatts. So it looks very small, but it serves a purpose of going green. For that particular island of Kavaratti with 1 lakh liters, we are going to power it completely with 𝐷𝐾. So that has a value of its own. And just like LTTD, when we did the Kavaratti plant, nobody even thought, and there was so much fear of whether it will work at all first. And then when it did work, we never thought it will go on for 20 years. That has been replicated in the rest of the islands, and that has become a success. So let's not give up. And the 𝐷𝐾 power desalination itself is a big value for pristine islands like Lakshadweep. And then we go to the larger scale ones where there's very capital intensive plants like 𝐷𝐾. But the thing is, unless the government chips in, we can't even, it becomes a catch-22 situation. So first we need the government support. Parallelly, the infrastructure and the actual wherewithal to be able to put up such plants, build them, fabricate them, have appropriate shipyards and ports and things like that. And then only it can grow. So all these are parallel activities. And I think we need to have policies which will really enable us to do these kind of things. Because the cost is a later thing. First, we have to show that we can do it. Can always bring the cost down. And the last thing to add is actually, in fact, there was only 1 or 2 individuals kept for ocean energy as such under the MNRE, because actually as per the business allocation, we are supposed to do the R&D for ocean energy, but they have to make the rules and policies. And long ago, the counterpart there, I used to always say, you're not doing kuch kar hi nahi rahe ho, you know, you're not doing anything for ocean energy. Without you doing, it will not. So sometime in 2017, he sent me a mail saying, I have done it. here it is. That's when MNRE at least recognized ocean energy as a renewable, and it can enjoy the same purchase obligations as solar and wind. Unfortunately, though that is now there on paper, we haven't yet utilized that because we need all the young startups and industries also to kind of take part in this endeavor. Thank you.
Thank you, Dr. Purnima. Dr. Ramanamurthy is heading Deep Ocean Mission and offshore. 𝐿Tech is a part of the Deep Ocean Mission. So essentially, in addition to general scenario, which I requested everyone to talk about, so you also please talk about the thing that from the Deep Ocean Mission's perspective also. So please share your thoughts.
Thank you, Dr. Prasad, and colleague, panel members, delegates, and most importantly, students. I think first I would like to say, when you talk about the renewable energy, the significant achievement today happens to be Dr. Purnima, because she is the first person to represent from India in international global forum, especially on the renewable energy. That itself is a big achievement for the country as well as to the NIOT. As I think she mentioned about that very valuable point is about not too much worry about the cost. I totally agree with that. When we started solar from 17 to 2.2, it took long time. And also in terms of maturity of technology, how do we get into that? But in fact, the challenges which Dr. Srikanth has told on that marine side, we have a huge challenges to take up for that. Actually, even if you look at offshore policy in India itself, especially on the wind, there are two concessions which were available from policy side on the past. One is called accelerated depreciation, and then southern one is renewable energy certificate. But unfortunately, one has been dropped and now other one is there on that. Today, when we started looking at renewable energy to take it forward, we need to have a good map of potential along the Indian coast, though it may be low or high or medium. That will come to know only unless we have a potential maps for India. In fact, that is one of the objectives what we are doing as a part of Deep Ocean Mission that Dr. Purnima is also parallelly working on. Second one is most important one is no such kind of technologies are, if you look at from commercial angle, it's not worth taking up. But we need to invest and then see how we take it up in the future. Like solar, maybe now initially for the offshore wind, but later on, so many things will come in the future. I think one of the important one is off-grid systems for that. Especially for islands, when there is no power, we have to depend only on the diesel. These off-grid systems will become almost like a maintenance-free system for the long term. When we start looking at, I think what is being done at many countries is also a levelized cost of energy. This will definitely come down. Even for wind, it started with somewhere around in US dollar, huge number, and then it has come down over a period of time in terms of maturity of technology, but also on the infrastructure. I think Dr. Kadial's presentation clearly highlights that when we first started about offshore wind, per unit cost was somewhere around 7 to 8. No one is ready to come for that. That's how government has come up with policy of viability gap funding. Since it is not commercially viable, we need to support from the government initially till the technology is matured, and after that, renewable energy will take up further. That has been done for the wind, but also we need to do for other renewable energy in the country as well as. The third point, which is very important, is I think some of the students were presenting on the research on that. Unless we encourage this research at this stage, we will not be in a position to catch up for the future what we wanted to have on the renewable energy. I think with these things, I'll close at this stage and I'll hand over to the sir.
Yes, to augment that, actually, in the renewable energy, there are non-conventional energy resources. I mean, it started with some time long, I mean, some 3, 4, 5 decades ago on biomass. It started with, then obviously natural gas, etc. also were coming. But still, when it came to renewable energy sources, especially after 70s and 80s, when we had extremely huge scarcity of global scarcity of petroleum supply was there. So biomass was there, the wind came into picture, solar came into picture, but the solar and wind, probably solar photovoltaic also, probably in the 80s, the one would never could think about sort of photovoltaic as a very viable economical option. But now from that time, 80 and 90 rupees as per that tariff as a cost, it has come down to say a few hundred paise now. So that's the kind of learning curve has been seen by the solar. Same with offshore wind also. So I'm sure that every renewable energy technology will have its own learning curve, obviously with efforts and the scale. But when I was studying non-conventional energy sources during my post-graduation, we were told by Dr. Suhatme, as one of the first lectures, was there's nothing like a technology better than the other one, or say more economic than the other one. It is all about appropriate technology, choice of the right technology, considering the location, considering the resource that is available. So there is no point in comparing two different technologies. So I think, so I just thought I'll just share that perspective. So appropriate technology is something which we need to consider. And in that context, I think amaranth renewable energy resources are extremely relevant to India. So now moving on to that, they say that any mistake of a shipman can cause the ship. So it's very tough in being in offshore. So obviously not every resource that we are talking about has to be offshore when it comes to MRE, but still there are challenges. There are development, there are risks involved. So I would like to request you to share your thoughts, as well as we also have gone through certain kind of experiences. India has gone through certain experiences, right, from the demonstration, very ambitious demonstration of bioenergy as well as OTEC. But there have been kind of setbacks, there have been failures. But then each time, each of these projects has actually learned from the team, or the people who were involved, learned something, and actually they came up with something else. So in this round, I would like to request all of you to share your experiences when you were working on the projects or activities which were related to this our Rise Renewable Energy Development. So again, I'll start with Dr. Atpal, sir.
Thank you, Prasad. Let me just, before touching upon the point which he wanted me to speak, one thing about the cost which Dr. Purnima and Prasad all mentioned. This is true for all any technology. For example, you just take the telephone. I mean, we had normal land phones those days. I don't know, most of you may not know, when we were young, even the land phones, we did not get a land connection. We have to apply and wait for more than a year or so. Then only you will get a connection. Otherwise, there will be, and OIT, own your telephone. You have to pay a lot of money, and perhaps within a few months you will get it. Then when the mobile phone came, you know, they were mobile, but it was quite large. And the cost of the mobile and the call was so expensive. It was, I think, about 10 rupees for a minute or so. And if you receive a call also, you have to pay. So people used to only give a missed call and things like that. And right now, you know, what is the situation? I mean, mobile is so inexpensive, and the whatever Jio, Airtel, all these people, I mean, it's like a throwaway price. It is available. So this technology is similar in this case also. And unless it comes to that stage where the economics is there, nobody will invest. Investors are, they want to make money after all. They are not bothered about what is the R&D and how much money has been spent. They want to get back the money at the earliest. So the state, like the government, will have to invest. That is how we talk about now the infrastructure, which we have to come for all these aspects. So to just tell some of my experiences, of course, it will be common with Purnima and others also in NIOT. I can tell, not to talk about renewable energy, in any other areas also, when we were working with the deep sea mining, etc., we did not have a proper ship for that infrastructure, and we had to really slot to do some launching, retrieval, etc. And coming to the work which was done at Vizhinjam in Kerala, even there to setting up the plant was a challenge due to the non-availability of infrastructure like cranes and other systems. And coming to 𝐻𝐃, the first plant unfortunately could not be successful was because of lack of infrastructure. If you ask now, I think an IoT will be very easily able to set up that because the infrastructure and the know-how is readily available. And the most important challenge was in the islands, because the islands, the crane which was available is only about 5 tons capacity. So whole design and whole assembly, everything has to be done with keeping in mind that each component cannot be more than 5 tons. So these were the challenges. And even now, if you see the offshore wind, if you want to set up, unfortunately, we don't have large cranes. If I remember correct, I think the largest crane called 𝐌𝐀𝐑𝐈𝐍𝐄 is in Chennai port. I think about 50 tons or so. I'm not sure whether it is current. I mean, this I'm telling from my memory. That is the only one which is available as a large crane, and large barges we don't have. So everything in the East Coast, we have to depend on Singapore, or in the other side means we have to depend on Dubai. And you see that, I mean, I don't want to compare, but Singapore, you know, is only as big as Chennai. But the amount of infrastructure which they have is so enormous that India's is a sort of maybe the second largest democracy in the world, but we don't have that much infrastructure, unfortunately. So we have to heavily depend on them. We can depend, but the only thing is that all these things will add to the cost. So infrastructure development in the country has to be commensurate with the other developments. Otherwise, what happens is we'll be always depending even for a crane barge or any other structures which for installation, we have to depend on other countries. And what happens is that the cost, the timer will start from the time the people start from the port and return back. So the cost is so high compared to having something in India. And we have the capability we have, but somehow the infrastructure development is slightly taking a backstage. So this is what I just wanted to gently tell. You can continue. Thank you.
Thank you, sir. Ramda sir, your thoughts, sir. Experiences also.
Yeah, thank you. Drawing from my experience, so we always say NIoT research is three-dimensional, in the sense 3Ds are there: design, develop, and demonstrate. Sometimes we go a step forward and we do even deployment also. Okay, so first we have been trying to prove the technical viability before we talk about the commercial viability. The first experience is Vizhinjam wave energy plant, and I think Dr. Atmanand and Dr. Purnima are more qualified to talk about it, but I tell my experience actually. When we go to the beach, we see giant waves actually crashing and all. We think that if you put the plant there, actually it can power whole Chennai and all. So it started like that actually when we 125 kilowatt plant was actually designed for Vizhinjam, and it was put there and all. And only around 25 kilowatts of power has been generated once in a while and all actually. And later a desalination plant was connected. People say later it was closed after the demonstration. Some people call it a failure, but I see that it's a major success, because there we tested different kinds of turbines, Wells turbine, impulse turbine, and we have demonstrated that this is the maximum we can get from this wave. If the input wave power is limited, however efficient is your conversion system, you get only this much power. So it was proved. Now, if anybody wants to put up a plant, they can really have the data from us. If they want to array of these plants, they can have. Actually, we have proved beyond doubt. And Dr. Purnima and her team actually designed wave-based floating buoys and all. And we have been getting orders from ports and harbors for actually more of them. So I say that it's a success. Actually, anybody can take this data and use it. Similarly, ocean thermal energy conversion experiment. Actually, I was one of the few people who could see the deployed pipe for the last time in the ocean before we abandoned the project, actually. It went like a textbook launch. Unfortunate incident. One incident really killed it, and that we thought that was a failure, but it was not. Today, almost 1 lakh people, 0.1 million people of Lakshadweep are having water every day, fresh water, only because of that experience that has been converted into LTTD. So we have done a really human service in this field. And also Dr. Purnima really hung on to that VOTEC, and actually she kept the flag high. She became the champion actually in the international committees also. And now actually we are revisiting, and we are going to have a plant at the Kavaratti, as she was selling actually 65 kilowatt power. And also we have done the consultancy for Shell and USTDA. We got a project, and now with offshore hydrogen, this thing and all, it may have got a second life. So what our experience is that we don't condemn an idea, we keep working at it, okay, and then we understand it. Now we give this experience to the industry. This is a different field. Industry cannot come and just pour the money into this one. So they need, similarly, like I can give one more example, like deep sea mining. People keep on asking, why are you working on that one? Yes, when tomorrow commercial exploitation code comes in, we have to share our experience with them. Till then, who will work on that? Okay, so this is our duty. And from my experience, I feel that NIOT has been doing this very well. Thanks to the leaders like Dr. Purnima, Dr. Atmanan, and many others. But we have been learning, and we have enough information and knowledge about this thing. If industry comes up really, we can guide them for future endeavors. Thank you.
Srikanth, your perspective.
Thank you.
Being in Singapore, do you think that you really face any challenge? Because you keep telling so many tests and so many designs being tested.
Yeah, challenge exists always. Because when opinions don't match, that becomes a barrier to get permissions and all that. I do have my own challenges. For example, putting renewables in the Singapore oceans, you see that because the GDP comes quite high from shipping, you want to touch the ocean for energy generation. They say like, because they are so energy rich, say suppose they need a 3 gigawatt of energy, they have 9 gigawatt of spinning reserve. In fact, all the power plants are supposed to be operationally ready. So if you see, like, for example, for the gas turbines, when the nearby Indonesia's forest fire comes, the air gets polluted. The particles come and affect the gas turbine. So they expected each power plant to have $1 million worth of filter as standby. Otherwise, they will get penalty. They will, Energy Market Authority will come and check, and then they will fine them. So you could see that they are very energy rich, but very fossil based. But there is a very high interest at the high level in the government level that they want to become like decarbonization and other, and then they push the bureaucrats to come up with when such a technology comes. But yet you could see that in the operational side, people are not ready to take a risk. Like when you talk with the Marine Port Authority, they would say that why renewables? Because shipping is my priority in that way. So this is the challenge. So when I saw that challenge in 2012, I started seeing when Europe and others were putting on the seabed, that's where I went in. Why not I make everything floating so that with a tugboat, I pull it there, moor it, and do the testing to the islands, etc. See which, looking at the marine spatial planning, you see like which portions are not well utilized, give them counter white papers, and then you push them in different directions. Like, so this is where like, so I always see that success is when the prepared gets the opportunity. When the opportunity comes and you are not prepared, then that's where the problem comes up. So that is where I will tell to the research community that they are the better people. If engineers were or the industry people directly jump into these, you will see that much more failures will happen. you name like BP oil issue in near Brazil, another a lot of challenges. So like the design, development, and demonstration, what Dr. Atmanand was pointing out, in each of these stages, the failure mode analysis we have to do. We have to look at it and come up with technology preparedness or some backup plans, like even this cost also. If we want to go for made in India, like what exactly the localization we could do, how we can achieve at least 70-80% localization and other. So these are some things at the research community, at the applied level, maturing to high TRL, we have to look at it. And instead of the approving agency putting the kind of the rule, when these applications and these design developments, etc., are being looked at, I'm very sure from these experiences, these are very notable demonstrations at Lakshadweep and others, that itself will give us how these supply chains, as he rightly pointed out about the deployment challenge, the lack of some of the cranes and other, these I am seeing more as opportunity, that how to customize them towards our own specific needs and other. But no doubt they become sometimes delaying parameters in that way. So that's how I'm seeing the specific challenges towards, like the way from a tiger to a leopard to a jaguar. You have a new animal coming out from the specific challenge. So that's how I'm seeing. It's an opportunity to tailor make towards our own region. So that's where I see that.
Dr. Purnima, in addition to your comment and thoughts about challenges and opportunities in marine renewable energy development, I also like to just touch upon one aspect, because you have been one woman in engineering, and that too a difficult field of offshore, and because everything that we talk about is essentially when it comes to deployment, it is a tough thing, even for everyone. So still you have been there, you have been, you have sailed, you have gone for deployments, handled people, mostly males around. So that aspects how you manage to handle, because there are many women and girls actually around here, and it will be a kind of a great motivation if you share some of your experiences from that perspective and how you somehow managed to overcome. Definitely your colleagues also must have been very nice, and they would have definitely helped you. But still.
Yeah, that's I had some other things that I wanted to say as far as infrastructure and stuff was there, but now we have been sidetracked. Okay, never mind. Anyway, there are women in the audience. So I'd like to say this, that I always do this when I go to engineering colleges, that don't shirk from work because you've got to go to field. There are a lot of adjustments that you have to make, and there's no doubt on that. Simple things like in Ennur Port, when we were doing whether it is 1 MLD or whether it's a pipe or whatever. I mean, there was no ladies' bathroom there. And I had finally, because I was in very good books with the Ennur Port people at that time, Captain Rebala Prasad, I think, supported me so much in every way. And he had actually given me the key to the ladies, to the bathroom. There was no ladies. I mean, there was one bathroom in the signal station of Ennur Port, and I was the only one who used to go there even after office hours and use, because there wasn't anywhere else. And so that is the kind of support I've got from a lot of people. Of course, the team has been entirely supportive right from day one. I had difficulties in the beginning because of the language, but then they have tolerated my poor Tamil and managed and always supported me. So support-wise from the institute, from the top to bottom, all the directors here and everybody has always been supporting. So that was not a problem. But yes, site and field have their own challenges. And but the other thing which probably today, this may be an apt occasion to tell this as an experience. And none of the people here were present at that time. So it may be new to them also. So there was this one operation when we were trying to do in 1 MLD connecting the pipeline. Our contractor was few kilometers away. I was chief scientist on Manjusha and just a couple of other scientists. And then there was this tug master who was acting very nasty. and he was refusing to cooperate. And you know who the contractor is. When he called me on a separate thing and said, in Marathi, he said that he is not cooperating. If he is not going to cooperate, I'm going to leave. And he was holding one end of the pipe. So I said, you can't threaten me like this, and let me talk to the tug master. So because I was chief scientist, I was anyway sitting in the main this thing, and I kind of took the VHF and I said, both of you come on the same channel, I want to talk. So this tug master was one of the rudest. I mean, I've never had anyone talk to me so badly. He spoke very badly and said, you don't know what you're doing. Do you know anything about offshore? These were the kind of words he used. But I just kept quiet and I said, this has to be done before nightfall. You will take the tug away tomorrow. We cannot pay you more money. You have to do the connection now. In any case, after a long time, maybe took 2 hours, it was getting dark. So with the contractor and with him, with a lot of instructions, finally the connection was made. And the contractor, of course, was relieved because he was helping us, and he was always, he had been with us for many years. So he was always, so we were like several distances away, right? I mean, several kilometers away. Nobody was seeing each other. We were on different vessels. So finally, it was very tiring. And then everyone came and said, Madam, let's go and have dinner. So I was just about to leave this thing and go. And that time they said, no, the tug master wants to talk to you. So I'm just telling you this because of women here. I hope you get motivated with this, because he called and said finally that I have never worked with a woman offshore before. So I'm actually sorry if I was very rude. And I just want to say hats off to you, madam. So that felt good. So that was really good, because I didn't have any like support even on the vessel that day. I mean, I was a chief scientist and there were 2 others. So that way it was a big relief for me that people finally recognize the actual work, and, you know, it doesn't matter then whether you're a lady or whatever. So you have to keep your determination and go ahead and see how, I mean, actually sometimes it is, you know, use your brain to see how you can circumvent a small problem like a toilet or something. So, you know, you can just find out ways and try to take. But of course, this is something that I've always been saying, that there have to be more amenities in terms of infrastructure. This is also to have the 50% of the population also involved. We need to have amenities which are conducive to everybody to work. So anyway, thank you.
You also, I mean, you have studied the infrastructure in India and as well as abroad. Maybe you can also talk about.
So I just quickly tell you about that. So this is like how we have to evolve. So long ago when we did Tuticorin in 1 megawatt, Dr. Atmanand was a big part of the whole thing. So he has seen the pipe. Now that time the 1 meter high density polyethylene pipe was actually imported from Thailand and Malaysia. And we were not making any pipe at all in India those days. Slowly, as we started doing Kavrathi, in fact, the Nozzle, who was later taken over by Reliance, they supplied the pipe for Kavrathi, which was 630 millimeters in diameter. Today, India makes 2 meter pipes, and I'm told one company has started making 2.5 meters also. So what has happened is, apart from the knowledge that this is a pipe that can be used, the demand has grown. So ultimately, it's a market demand and supply game. And so unless we create a demand, there is no need, right? So especially in a country where resources are limited, unless there's a demand created, infrastructure will not come. So recently, actually, OES came up with a new document. It is towards vision, but it also highlights the infrastructure, what is required there. See, they plan well in advance. They know that tomorrow we're not going to have a market for ocean energy, but they plan well in advance. So a study was conducted as to what infrastructure is required for how much of gigawatt of power. So they were targeting something like 360 gigawatt by wave and tidal. And they had put me also on that subcommittee to review that work. There were a lot of, I would think, shortcomings, because nobody has done this work before. So there are shortcomings in that work as far as I'm concerned, especially the Asian context is not there at all. But what they did was they made a graph where the infrastructure requirement, the capital for that, and the capacity that we are headed towards, what is the inflection point at which how much of investment can give you how much of total gigawatts. That is Henry's work. You know that graph, right? So that is something that we need to do in India. What sort of investment will be required to achieve, let us say, 2 gigawatts of wave or, 5 gigawatts? So this is something I think we need to take up. I mean, towards infrastructure parallelly growing to make marine energy a possibility. Otherwise, if you don't have the suitable infrastructure, but I'm happy that, the team is now going to Jaigarh and they are having, they have made a deep draft vessel there. I'm surprised we are having shipyards now in India who are making it. Only they are not aware of marine energy. So they need to be educated. And when all of you go there, I think you have to sort of educate them. Thank you.
Because this is a revelation actually in the recent times that Indian offshore industry has developed. And obviously there is no objective assessment or say understanding. Probably, I mean, they go with shipbuilding business and ship repair business. Now more towards shipbuilding there. Earlier it was only around the ship repairs, but now building also has commenced very well. And probably we had to probably see how we can really exploit. I would say again harness that resource. Sir, against the opportunities and the challenges, obviously comment on infrastructure also from you, sir.
So there are, I think, 3 major challenges, maybe what we have faced and then what solution we got at also. And first time when we are installing this monopile for the Gulf of Combat, the barge available, especially Jacob, was only 30-meter depth. And we could not able to do. Then we have to find out a way how we take this Jacob barge and then install them. I think earlier it was mentioned that in India, we don't have such kind of infrastructure really to do such kind of major installations in the offshore especially. If you see that monopile cost what we had for that, initially people were telling in Indian rupees, 15 crores for the installation, but it was done at 4 crores. But in the total component of 4 crores, I think Dr. Pandikumar was also there. 30% is only the cost of the material, but 70% goes for the marine spread, what we call as the infrastructure. Especially marine operations requires major amount of money only for installation and then minimum amount for the what material actually it goes on. Even it same is the case with the desalination plant. The offshore installation cost is so high and we need to develop infrastructure and also the methodology, what way we are going to deploy and demonstrate. That need to be evolved over a period of time. I think NIOD has done that work and then after that now installation monopile in India, I don't think is a major challenge because we could able to do it. Like as rightly said by Dr. Srikanth, we had for offshore wind, I think when I was working with Nive, we did a marine special planning for the offshore wind and Kanyakumari and then Rameswaram, where all these blocks were put into that and then where is the port, what port we are going to utilize. Now the question is whether this port can handle this kind of large blades and then infrastructure is the question. That time what was suggested is container terminals which operates on the port can be immediately augmented and then make it for the wind turbine to receive and then operate it for the second one is about the vessel. Now either we have to get it from Korea or Singapore or some other place for the vessel for that. But now people started thinking about what kind of vessels to be built in India to handle such kind of offshore. That is why initial cost of any renewable energy is very high because we don't have infrastructure. This 8 rupees will become 4 rupees only when we have a number of projects which is taken up in the future. The second challenge is on the investigations. I think Dr. Purnima also knows for that. When we first taken both Dr. Pandikumar and Dinesh were there on that, while we have put it started going into the seabed because we didn't do investigation. The main reason for that is nobody want to invest on the investigations in the beginning. Unless we do geotechnical and geophysical investigation in that area, it is going to be a very expensive task and also we will have a lot of difficulties. That was a very bad experience for that. After that, we did investigation and then installed the monopile for that. That's why I think Katyal's map clearly shows that now there is a structured investigations in the both Gujarat as well as in Kanyakumari in terms of all parameters. Then only industry can come. Industry cannot come with uncertainties and then some kind of vagaries in the system for that. And third one is, most important one is the climate change. Maybe when I was working with there, when we started for desalination, we are comfortable installing all the plants especially from November to February or March. Now there is no question of fair weather available in any place in the country. You have to operate all installations at least 1 to 1.5 meters wave height and then go installation further. The climate change, there are two aspects. One is about installation. Second one is also about how climate change affects the renewable energy. I am not touching about the second part. Even the first part itself is a very complicated, because when we do installations, either it is can be a deep sea mining or whatever it may be, we don't have such kind of fair weather what need to be operated in the past further. We have to prepare ourselves for this kind of eventuality in terms of infrastructure, and then any weather, whatever it is there, we should be in a position. I think with this I'll stop.
From the investigation, I just remember that in cricketing parlance, we say that you should study the pitch before playing. So whether it is a bowler or a batsman, pitch, we should study the pitch first. Thank you so much for sharing your experiences. Sir, any other experiences if you would like to share? Any one of you, we can, because some anecdotes, actually, these are the things which actually teach us the next generation about, it's probably, I think it can be a fond memory also, and it can be. So if there is any experience, you can please share. Sir. So then, still, I mean, I still have one small round about the general remarks about where the things are lacking, or are we lacking anything, or say, are we going in the right direction? Obviously, it cannot be that we are totally wrong anywhere. There is earnestness in almost all the marine energy community in development, but then to augment the efforts. As Dr. Purnima mentioned, was certainly somewhere the government has to pitch in and create an atmosphere where the industry as well as the researchers also do more. So that is something which I would like to give your opinions from Atmanand sir, please.
No, right now the country is going in the right direction, no doubt about it. But as we just indicated, the infrastructure development and many other aspects, like for example, we can consider, like Dr. Purnima said, micro level generation need not be of the order of gigawatts and connecting to the grid, not grid connected, independent units. And if you see the total cost, it is said is about 30 to 60 crores per megawatt for any of these projects. So it definitely requires a support from the state that is very much essential. And if you consider taking up on a small area, I mean, like for example, the islands in the Lakshadweep, if you take, you know that the cost of diesel, the diesel is going from the mainland to the Lakshadweep Islands, and the cost for that is quite high, and that really makes it important that if you make it carbon neutral, or at least reduce that by having renewable power plants in the islands, that would really be a mark. It would be as part of the blue economy. The tourism can be improved. You can say that we have a green island where tourists can come and enjoy. I mean, there are so many other linked activities which could be benefited by having this. So definitely I agree that I feel that we are going the right direction, but still much more is to be done, because we have got a lot of youngsters here. I hope all of you will take it up seriously. Thank you. Yeah, actually, I'm not talking about technicalities now, but generally we are quick to deify or demonize things actually, because just because we work with one system, we say that actually this is the best and that are actually worthless and all. Actually, we are quick to take thing or disliking to this one, but it's not the case. Tell you one example, my experience actually. Now, when we participate in this discussions in the United Nations about means evolving commercial exploitation code for the deep sea mining. Some people say immediate for mining, deep sea mining, and some not much these things. So we cannot mine, so we should actually wait for some time. They asked for our opinion. Yeah, unless we work on that and we gather enough knowledge, okay, we can't take a decision on that one. So we get confused between information and knowledge. Knowledge comes with working on one system, actually. We don't have enough knowledge about these things. We have to work on that. As R&D organizations, we should really concentrate on whether it is wave energy, �WTech, tidal energy, or whatever it is actually, or offshore wind or anything. We should not be quick to come to a decision. We should work on, and we should really collect enough information, and we should generate enough knowledge so that we can take an informed decision on that one. I dare say that actually that is the difference between India and China. Actually, though we are alarmed about actually some things, but we should take a leaf out of their book. Actually, their strength is that they go deep into the subject and they really create knowledge base actually, and we should do that one. Whatever we do, we should really dwell deep into that one, and we should generate that knowledge base so that industry can come and take about that one. There is no shortcut, and you cannot just say that, okay, I'll put up I have tried some things like as an young scientist, I started making one tide gauge, and I started putting up everywhere instead of actually making it and giving to industry. I started putting up in all along the Indian coast, networking it and all. One time I just go there and make it all right, and second thing goes wrong actually. So, and it gives a bad name to the technology. So R&D organizations like us actually should concentrate on really proving a system, proving the technical viability, and generating enough knowledge, and then passing on to the industry. But actually industry cannot do research, and we cannot do actually installations and all. So I think at the right time, we should actually involve the industry to come in and take over and establishing these technologies in the ocean. Thank you.
Yeah. From my view of technology innovation, especially industrial the supply chain innovation, etc., we could see that specifically when a technology push or a market pull, which is much significant, is market pull. So application demand, like for example, in the semiconductor industry in year 2000, when the existing procedures of dielectric and other, like silicon oxide and other, that was in the CMOS one, it was almost about to fail, cannot meet up with Moore's law. You could see that all the industry competitors came together and there was a competition, okay, cooperate to compete. And then came up new materials like low-K dielectrics, etc. That's where today you see NVIDIA chips and other all are still embarking. Now today we are in year 2025 and it's still going on. But in year 2000, Moore's law was about to fail. In this kind of a thing, we find that application pull has the key thing. Today, if you see, blue economy is of that sort. India's very rich coastal locations of 7,500 kilometers is a big resource. Okay, so now today fishermen are going hunting for the fishes with a lot of uncertainty. But now if alternate is given ocean-based deep water aquacultures, like for example, like a floating fish farms, now instead of depending on diesel power, if we are giving them like a hybrid renewable-based energy systems to start with, as a early adopter of renewables, both can co-evolve. So now new supply chain can happen. All are within the limits of, it doesn't need very heavy installation systems, etc. So that's where the modest adoption of renewables can happen, for example. That's one example, I would say. Even in the case of REC credits, like the renewable energy, the carbon credits, for example, if you take a look, in reality, to carbon capture, 1 ton is around $150. But what governments put a penalty to industry for CO2 emission is only $5. In some countries, it's $17. That's all. But in reality, to get back the CO2 emitted is pretty costly. So that is where if countries are having goals to go for zero carbon and other, you can see if these penalties and other come in, automatically renewable adoption would be much faster. So that's where these unsymmetric subsidies and other to certain industry is actually demotivating renewable adoption. So those are the practical things. So that's where these are certain aspects that I see. Otherwise, renewables is definitely very, very, no doubt, like it is like wind or wave is very stochastic and all that we can say. But we can, these uncertainties we can plan well, like today with AI and other, and we can design systems and we can take it forward, is my opinion. With right technology, planning and other, from lab to field, and again bringing back from field to lab, planning very meaningful doctoral studies, masters and other these kind, people will get evolved for this industry, as well as solutions will be coming in tune to the national goal, like, and also industries also, as Dr. Purnima pointed out, the demand will arise and automatically resources and planning and efforts would fall in place. So that's what I think. Yeah, thank you.
Yeah, just a small quick thing only. A lot has been already said, but I think the way to go would be, I mean, of course, capital investment has to come from government right now to make an R&D technology grow, like 𝐻𝐃 now under Deep Ocean Mission. Mission Director, please help us. So that anyway, that's a very good positive step taken by the Secretary to, you know, even think of having this program for this offshore 𝐻𝐃 and desalination. But that is a real capital intensive thing. What one could do is, I'm also a big fan of hybrid systems nowadays, and Europe is going very much into solar wave, wind, these kind of combinations. So what could be done at a much smaller level without too much of capital investment is maybe the industry people over here, the youngsters, you can think of, like, you know, installing microgrids in remote coastal localities. So the cost is low. You are catering to a small community and make it a fully renewable thing where 2-3 forms can be used and put it on a microgrid. This way you can use probably a small wind, small solar, because solar takes footprint. So you can go little bit into the water, do a wave and solar together or something. In the end, a small microgrid with low capital investment serving a community. I think this could be a good step to even start scaling. Thanks.
Very precious thought. I think it has to start at a smaller scale. Probably the costs may not become very kind of intimidating. Thoughts about how we can move ahead. Obviously, definitely, government is doing some partly, actually it is funding some development through 𝐻𝐃 and desalination. So maybe you can throw some light on that and your experiences.
I will answer straight away your question only. I think when this 𝐻𝐃 plant was there, I think I remember with 200 crores was what has been kept for the pilot demonstration. I think when we have gone for this expression of interest, the cost turns out to be around 500 crores. But just now I got a message that midterm review has been approved by Department of Expenditure. I think this 500 crores will put up the proposal shortly for that. So that's why this investment in especially on the mining and then this offshore plants are all is need of the day, and then we need to invest more on that, because
as a country, we have to develop a lot of things on the offshore. Unless as a R&D institutions we do on that, industry cannot come on that. Industry can take some risk, but not the complete risk for that. So it is the responsibility of the government to invest and then show that this is viable and then it can be done. Then industry will come into the picture. Either it can be offshore, VOTEC or mining. If we expect industry should invest completely on that, means it is a very difficult task for that. That is why even the policy, if we see the experiences from the offshore wind itself, government has come with 4,500 crores viability gap funding. Same is the case with VOTEC. Suppose if we want a VOTEC to be a reality, government should invest initially and then call the industry and then ask them to join with you. It is possible for that. So that is what I think is the future, and then we need to have a more investment on that. But other part which is very much relevant to NIOT, especially for the others who are not aware of that. This is the only one institute which got specialization in the, especially on the marine technology, ocean technology. Most of the manpower which is already there in NIOT, they are on par with international standards or even above that in terms of capabilities and experience for that. This manpower should be utilized not only for that country, but also at other places in terms of their experience. In fact, number of demonstrations what NIOT has done is numerous, and then it cannot be measured. And then that Ramdas, when we started, I think I was seeing that first time this Mansub has gone into the harbor trial for that. It was a fantastic achievement in terms of demonstrating A to Z for that. Maybe we'll be going to the 500 meters and then 600 meters in the future with all capabilities of entire team. Last time when this entire ROSUP team was working, it really a wonderful job done by the entire team for that.
Thank you so much for insightful thoughts. Now, with your permission, shall we open, at least take a few questions from the audience then? Any questions from audience to any of the expert member, or a generic question if someone wants to, please. You tell your name, from where you are, and you ask the question.
Sir, I'm Madars. I'm from IIT Madras. I'm a master scholar. So, in general, I want to ask one or two questions, sir. And one of the things is like many people like, sir, you're all told that NIOT, like just now itself, is the only institute. Why are there no institute? We should be constructing more institute, right? So that research will flourish.
I can do that.
Actually, you're right. China, if you see the internet, you will see that they have Ocean Institute 1, Ocean Institute 2, Ocean Institute 3, like that. They are there actually. We need for 145 crore people, one institute is not sufficient, I believe. But again, see, for naval use, actually, there is NSTL, Vishakhapatnam, NPOL, Kochi. They really cater to the needs of the Navy. Similarly, NIO Goa, before NIOT was started, actually, NIO Goa did human service in even deep sea mining and other things, and all. They have been contributing to, and they have done some technology also. Maya AUV is made by them, and also it's not, and they also made one tide gauge with pressure sense bed tide gauge and all. So they were also developing some technology. So NIOT is one institute actually dedicated for the ocean technology in the civilian sector. And now we may not be starting the institutes, but we are following the technology everywhere actually. Many projects were given in the Deep Ocean Mission also to different agencies. Dr. Ramanmurthy will be able to tell you like that. And Dr. Atmanand, when he was here as the director, he started one SAVE competition, and he made AUVs very popular in India. So it need not be now the government is not really willing to set up different institutions. But one thing is we can actually start this program in different institutions and all, and they can work like satellites. Spoken hub models can be there, and they can contribute. Okay. Thank you.
Sir, I have one more question session. Uh, like in the whole panel, we are all discussing about the support from the government. So my suggestion shouldn't we invite them to they may not have time for the entire symposium or this, but shouldn't we invite them for this panel discussion? Not once, they will not understand. 4 or 5 times they comes, they will understand the situation. So by that we will get some fund, some raisings, and it will go to the higher authorities, and they will put some yojanas, and it will be going, sir. Shouldn't we do that?
See, the people who are sitting here essentially have been doing something, and they also talk to government. And this is also an autonomous institution, but it is a government of India institution only. So probably the feedback about what obviously your point is well taken. We can always see what can be done. But probably I think what I felt was you were actually pointing towards generating employment. Correct, huh? But I think, see, this will come up. This will come up. Have a positive thoughts in your mind. Okay.
Thank you, sir.
Any other question?
Hi, sir. I'm Subikesh from IIT Chennai. Ma'am is addressing that a hybrid system that combines solar with water or wind with water. It is possible to combine OTEC with salinity gradient energy, or within the ocean resources, it is possible to combine the technologies.
No, so your question is quite valid, but what can be done with OTEC are different things, not necessarily wave and tide and things that. But in fact, right now, what NIOT is working on, we're making a design for a platform which has OTEC and making water. Okay, so it's like basically energy-free water, because the OTEC power is making the water. Along with that, we are also going to make hydrogen. So that is the studies that are being undertaken right now. And then there are many other spin-offs of OTEC that can be done, which is what we are studying to see how to make it more, not only commercially, but, it should be technically viable first. So first we're studying and trying to do the R&D for that. So right now we are focusing on OTEC, water and hydrogen, all simultaneously being done on the same platform. So I hope that answers your question.
Yeah, thank you.
Request all the expert members to just give concluding remarks in such a few sentences. With Atmanand sir, please.
Thank you, Prasad. The concluding remarks which I would like to tell is that while we need a lot of infrastructure, we also need a lot of manpower, youngsters, to work in this area. Because right now I am wearing another hat as a faculty in IIT Madras. I find that students are more keen. Of course, that is a trend for last maybe more than a decade, that they are keen to go to an IT field, even if they do their work in ocean engineering. Perhaps that is more paying than an ocean engineer. So the thing is that youngsters should work in this area and continue to work in spite of all the odds and difficulties. And that is how we have a strong technology base. And we talk about ISRO as they have been so successful. The main success with them is two things. One is, of course, the infrastructural developments which the state has supported. Second thing is the excellent manpower. If you see that the people there are all
really technically competitive, and they are really, the number is quite large. So perhaps all of you youngsters should consider working in this area and bringing up the country carbon neutral sooner than later. That's all I want to tell. Thank you.
Yeah, actually, my thoughts are similar. Whenever I go to a college for giving a talk or something like that, at the end of my talk, I ask how many converts are there here, and actually how many people want to really work on core technologies rather than going for IT jobs and other things, actually. And nowadays, students are very smart. Immediately they come, they ask me, sir, I want to become a ocean technologist. What should I study? Actually, what is the course and all? I tell them that nothing, actually. You can be anything. You can be civil engineer, electrical engineer, or electronics engineer, or even a physicist like me. Okay, but one thing is, if you study your subject well, and if you do your thing well, actually, you can contribute to the ocean technology. It's a truly multidimensional this thing field, this one. So everybody can contribute. Even if you take mining, or if you take wave ocean energy, or anything you take, it's actually, it's not that it needs, we need all kinds of people to really achieve what we want to achieve. So what I say is that take yourself seriously and stick to your core field, then you'll be able to contribute. This is my message to, I see a lot of youngsters here. So this is my suggestion to them. Thank you.
I think most of the things I've already told, but I think since somebody has asked the question about any renewable energy or to any project which we have to take it forward, government stands on the first apex level, then we have a national institutes, then third comes the academia, and fourth is the industry. We have to understand the roles and responsibilities of each and every pillar very clearly. Government is only a facilitator. It will not get into the micro details of what has been done. The responsibility of the National Institute is basically to formulate the program and then demonstrate and then show that how this technology has taken place to the final shape. Then comes the academia. Academia's role is only to investigate the new problem and then gets work in association with the national institution so that there will be one-to-one interaction with them. The last part is the industry. Industry will come into the picture right from the beginning in the slow phase. Once the technology is matured at that layer, finally it has been taken over by industry. But it has to happen. So the responsibility of each and every particular, these four pillars has to be kept in clearly in mind. So like you are asking about the creation of how many number of national institutes and all. In fact, NIOT had a apex centers at many other places. Like if you see in Angkor, now there is another center in Nellore. Many places such kind of facilities have been established already on that. Not only that, in fact, the Deep Ocean Mission has a provision and collaboration with national institutes as well as other ministries and also on the academia. It is not that only one single institute is doing the entire Deep Ocean Mission for that. So there are multiple institutes that are involved on that, and then they are working together one-to-one depending on the objectives and deliverables of the project. That's how it functions. And then it is not only to renewable energy, to any project to that matter. If the country has to go, all these pole brothers have to act according to their responsibility.
Thank you so much. I think you brought that academic research part also. So I think it is very vital to have that. And they can approach national institutes, national centers with concepts, with proper studies. And that can be probably taken forward. Dr. Srikanth, you are concluding.
Just to add to the earlier thoughts and suggestions, I find that as Dr. Atmanand shared, the telephone example, how India leapfrogged, that today people have more than one mobile, so that scenario came, that leapfrogging was able to come because of the wireless, from the wired kind of phones. So the same way, today, even in this ocean energy systems, you could see from a passive system, you could see that with the adoption of AI and the smart energy systems, becoming for example, the earlier question about hybridization. So if I have both a AC and a DC source, like combining a solar and either a tidal or a wind or other, you have to combine AC and DC. Now today you can see the power electronics is getting cheaper and cheaper, because things like from silicon we are moving to silicon carbide, and from silicon carbide we are moving to gallium nitride devices and all. So people are able to, in the electronics itself, convert any type of energy source into scalar energy, and then we can supply to the grid frequencies. Virtual power plants and a few other energy systems are coming up. So these all are coming from these young minds, and research community is offering to the industry. And as earlier spoken on standards, etc., new standards are evolving. So as the industry is pushing these ocean energy system to the industry, new innovations also are coming. Just in the wave energy device, if you take a look in the patents, around 250 designs, concepts are coming up, and many more. Like we don't know, like which would be a game changer that will bring down, and all have a progress report, like a levelized cost of energy, whichever. Because we may talk renewable at home. Once you go and switch on the light, you want to pay a power bill that is low. So that is the keen interest. Like as a consumer, you will look for low cost. Like so, that is where I would say here. Usually, the trend is the youngsters show a much creativity, while the elderly staff and the minds are always like towards the strictly meeting the standards, avoiding failures, and in a very conservative way they focus. So that's why the NIoT type of institution, you can see both young and old brains are working together to form new solutions. Like so that way it is matching well. And so that's what we look forward with the new game changer technology. So each of us have an opportunity to contribute to this industry. So that's what I foresee. And we take these opportunities not as passing cloud, like before things mature, we should have our contribution. So each can strive and take it as a passionate hobby, I would say, not as a job, as a work. Okay. There is nothing called weekend and other in this area. Like so, every day and night, like we can live and breathe with this opportunity to contribute for this birth that we have taken. We can give back to the society. Thank you.
Thank you, Dr. Srikanth. Ma'am, your remarks.
So just say very briefly, students and young researchers, I consider them as ambassadors. Okay. An analogy is, when a software is being sold to academic, all the academicians here will understand that, they say you buy one license, I'll give you 100 free. Okay. And what's the reason for that? Have you thought about it? Because if you're used to one software, 100 people graduating, all of them will go for jobs. Everywhere they will say, I'm used to that software, so I cannot do anything else. And then the industry has to invest in that, right? So who benefits? It's a software seller who has benefited, because, you all are his ambassadors, literally. In the same way, I would suggest all of you become ambassadors of ocean energy or marine energy. If all of you, in a large number every year take up, because it's multidisciplinary, it doesn't depend on which discipline you are. There is a scope for everybody. There is so much to do in this field. So every year, if we have several people, specializing in doing work in ocean and marine energy, then it will, start fostering startups and industries. And then when there is an inflection point with a lot of industry and government funding, then we can start scaling up. So I want all of you to be ambassadors. Thank you.
Thank you very much. It was very enlightening discussion. The thoughts that you have shared, very, very valuable. They are motivating, as well as they're really showing a light. And there is because it's all of us have to come together, different resources. Again, I'm talking about developers. So different resources, academic institutions plus national centers, with the industry. So everything has to work in coherence. So thank you so much for sharing a lot of takeaway personally for me as well as definitely for all the audience. Thank you so much. It will be my privilege to present mementos to you. Thank you so much. Plenary function in another 5 minutes. So over to Annalika, please.
Good evening, everyone. As we come to the conclusion of the International Symposium on Advancements in Marine Renewable Energy, it is a moment to celebrate the success of this gathering of experts, researchers, and enthusiasts in marine renewable energy. Over the past 2 days, this symposium has provided a platform for insightful discussions, knowledge sharing, and collaborations, paving the way for advancements in this field. As we conclude, let us take a moment to acknowledge the efforts of everyone who contributed to making ISA-MRE a grand success. It is my honor to invite our esteemed chief guest, Dr. M.V. Ramanamurthy, Mission Director, Deep Ocean Mission and Director, NCCR, Ministry of Earth Sciences, to join us on stage. I request Dr. Purnima Jalihal, Scientist G and Head, Energy and Freshwater, to also join us on stage. I request Dr. Purnima Jalihal to welcome our chief guest with a bouquet. Thank you. The past days have been filled with enriching discussions on wave energy, offshore wind energy, ocean thermal energy, floating solar energy, and their potential in shaping a sustainable future. Experts from across the globe have shared their research, insights, and experiences, making this symposium an invaluable experience. To present the key takeaways from this symposium, I now request Dr. Purnima to summarize the symposium highlights.
So good evening, and first of all, thanks for your patience. You are still here in the hall. That is like, I think the biggest accolades that one can get at the end of a conference. So first of all, thank you all for very much for that. Before I get into the detailed, the actual summary of the workshop, Chief Guest Dr. Ramanamurthy and the two former directors, Dr. Atmanand and Dr. Ramdas, who graced this occasion, and yesterday Dr. Atmanand was present for some of the talks also, and also all the students, NIOT staff, and especially all the scientists who have come from other organizations. Thank you so much for being here, because that actually motivated us to kind of do it with some kind of zeal and enthusiasm, and because of which we have such a mixed gathering as well. So before that, I also wanted to say that I'm personally, on a personal level, I'm really very much touched by all the accolades that all of you have showered on me, right? Starting from the chief guest up to, like the industries and startups and anyone. I'm really very, very touched, and it has been very emotional. So first of all, a very big thank you to all of you for acknowledging the efforts, and also being so vocal and nice about it, and making it a very, very wonderful experience for me as my last conference here. This was Professor Balaji's idea to do this conference, and he's away abroad today, but I just like to place on record my gratitude for his enthusiasm in making this workshop happen. And especially this particular field is very, very like it's not being done with as much zest as it should be. So I'm very grateful for that. So it gives me immense pleasure actually to tell you about what happened in this International Symposium on Advancements in Marine Renewable Energy, ISA-MRE 2025 for short. So through these 2 days, if you can just go back through the sessions, I mean, they have been, I think, really inspiring sessions with different topics. we have not only brought in, normally, some of the conferences are so academic oriented, they'll just be graphs, plots, and things like that. But here we tried to bring a mix of the actual technologies which are being developed, the startup scenarios, different kinds of energies, and we tried to touch all the forms that are possible. We missed the floating solar. I tried to get somebody, but they were not free. And other than that, most of the technologies which are being done at a certain level were all represented here. So I think it was a very good mix of topics. The other part was it was truly international. We have one international gentleman sitting here also in presence. So that is, thank you very much for that. But we had representation from the US, Japan, Singapore is also sitting here, and the European Commission, and also Europe. So all these people actually brought their own different perspectives with their expertise. So that added value to the conference. And of course, all the Indian speakers from the various labs. So we have touched upon all the elements which should be in the renewable energy, kind of a scenario. We have done standards, we have done resource assessment, done specific forms of energy. So in that respect, the conference has touched all the areas. So I hope it was fruitful and, a learning experience for everybody. In addition, I think the main thing, like I said also, that students are ambassadors. So from that perspective, we had these drawing competitions for small children, 8th to 12th grade. And the kind of drawings that have come, it is just simply astonishing. In fact, the chief guest, when he saw that book that was prepared with the drawings, he said, what is left for me to talk? Even little children know about marine energy in India today. That is just simply so amazing. Beautiful drawings. It's not only the talent, but the ideas. So we were really touched to see the amount of response and the wonderful drawings that came. So that is the prize winners will be declared today. And then we had the poster competition for the college students. And there also, I'm told a very good collection has come in, and I'm also eager to see who won the poster prizes. So this has been well attended. I can see the attendance has been fairly uniform since yesterday and today. And that is a tribute to all my team who has organized this, because making people sit through 2 whole days is, I think, an achievement, and I hope it has reached out to everybody, the importance of marine energy and what we can do. So I will say thank you all for your active participation. Thank you for the people who have come and delivered the talks, and for the students for your patience and for your participation in the poster sessions. Once again, I think the conference has been, at least we've got feedback that it has been really well appreciated. Thank you all for your presence today.
Thank you, ma'am. It is an honor to have with us today Dr. M.V. Ramanamurthy, Mission Director of Deep Ocean Mission, whose contribution to the field of island desalination and coastal protection have been remarkable. I now invite Dr. M.V. Ramanamurthy to deliver the valedictory address.
Dr. Purnima, I think today is her day, and then Dr. Atmanan, Dr. Ramdas, and many other colleagues from NIOT, and then Dr. Srikanth, I think thanks for coming all the way from here for this important day. I think I should say some 2 important words about Dr. Purnima. When I saw the book, I think how she interacts with the children whenever it comes for any activities which is required. One thing I should admit that I have been telling her also, and then many of others in several meetings. My second daughter is a big fan of her. In fact, she has not gone to any function which others have invited. When I said I could not go, means I think she has gone all the way to I still see her, hope Purnima remembers that. And then that's how she interacts with kids. Same is case with Dr. Ramdas' daughter for that. So she got a lot of, she knows how to motivate young children and students to come up in the better line for that. The second one is also, she is of my own discipline. I think in civil engineering, we have been interacting with, sometimes we used to quarrel and fight also on some of the issues. I think maybe last 25 years, we are working on that. In fact, she is during Atman's time, she has created one group for me, and then I had opportunity to work for some part of in NIoT, especially on the idle data sets. They have been working on the desalination plant. I think many of you already told about her. She was working for the VOTEC with Dr. Ratmanand when he was there as a director, and also previous directors with Dr. Katroli and then the Professor Ravindran. Our contribution to NIoTs are very significant in terms of many projects which have taken to the demonstration side. And she is a very good in analytical thinking and also on very good communication skills. I think if somebody has to be convinced for that, I think better we should take Purnima on learning, then we use for her and then convincing for her. And I know that I think after this, she will go to the IIT Gauti along with her husband, and then she will continue to interact with all the colleagues of NIoT and then many other research work. I don't want to talk much about the symposium. I think she has already talked a lot about the symposium, and then she has been a head for the energy and freshwater for quite long time. Though she is a civil engineer, but she has been working on the mechanical systems and then many technologies, especially related to the water and then renewable energy. In fact, we used to exchange a lot of information related to that. Either it can be VOTEC or some of the current turbines which have been installed in Andaman or wave rudder by BBDP. Still, we used to remember that name, like Ramdas, and we used to ask about abbreviate for that name and all. So the many things has been done by her, and then now it has come. Maybe it is only a matter of 2 months. She retires in this month, and then I will retire in the month of May. It is only a 2 months delay with both of us, and then we all are the same mode, and then same time we all live together and then grown together, and we retire together for that. I wish her all the best for the future life, and then also wish that she contribute to the NIoT, also to the other community, especially on the many areas which is required. Thank you, Dr. Purnima, for giving me this opportunity, especially Dr. Prasad, to sit with her in this last day of last tenure of the Dr. Purnima. And thank you all.
Thank you, sir. As a token of our gratitude, I request Dr. Purnima to honor Dr. Ramnamurthy with a shawl and memento. One of the special highlights of ISA MRE 2025 has been the national level drawing and poster presentation competition on the theme of marine renewable energy, aimed at encouraging young minds to explore and express their creativity in this crucial field. It is now time to recognize and reward the young talents who participated in this competition. I request Mr. Biren Patnaik, Scientist E, Energy and Freshwater Group of NIoT, to bring about the brief about the competition and announce the prize winners.
Thank you. Good evening. It's a outstanding presentations by young students, and also the poster presentations as really creative, innovatives. And the school students are really made excellent presentations, and these are all actually heart touching too, and it is a wonderful responses we have got within very short notice. So we want to it is not easy to sorry for your innovative creative presentation, enthusiasm and patience makes this event special. Every competitions have winners. Selecting them, it is not an easy task. So I especially thanks to Dr. SDS Fani Kumar and Dr. Satyanarayan sir for George for the posters presentations. And I request Dr. M.B. Ramanamurthy sir to distribute the prizes to students. So I will start the first for drawing competitions students. Dr. Sorry, the Bhavanya Chalapadi, 8th standards from Sri Prakash Vidya Niketam, Visakhapatnam, Andhra Pradesh. Next is 𝐈𝐍𝐿 from 9th standard, Vidya Niketan, Visakhapatnam, Andhra Pradesh. Tamil Selvi, 8th standard, Mahasri Vidya Mandir, Senior Secondary School, Polacheri, Chennai. Krishnaka Single Consultation Prize from DPS, Haridwar, Uttarakhand. It is to be taken by Nidhi Varsini. Another consolation piece, Shivani from Bharati Vidya Senior Secondary School. Jagat Narayan Jai Kumar from Maharshi Vidya Mandir, Secondary School, Polacheri, Chennai. Now, poster presentations winners, Divya Darshani BS from Madras Institute of Technology with their teams. Madras Institute of Technology, Madras Institute, Madras. Second prize goes to Prashant Kumar, IIT Madras. Third prize go to the Aswath and teams. Aswath, Madras Institute of Technology, Chennai. And Nasima Noor from IIT Mumbai for consolation prize. Nasima Noor. Ritika S. from Jerusalem College of Engineering. Ritika S. and one more from Jerusalem College. Amlan Sellin from Indian Maritime University, Visakhapatnam. I request Dr. Purnima Jalihal, Madam, to honor the poster judges, Dr. Fani Kumar and Dr. Satyanarayan sir. Dr. Fani judges. I congratulate all the prize winners and all the participants for their enthusiastic participations. Thank you very much.
A big congratulations to all the participants and winners. May this be the beginning of their journey in contributing to sustainable and renewable energy solutions. As we come to the close of ISA MRE 2025, it is essential to extend our heartfelt gratitude to everyone who made this symposium possible. I now invite Mr. Ashwini Vishwanath, Scientist E, Energy and Freshwater, to propose a vote of thanks.
Good evening, everyone. It is my distinct pleasure to propose a vote of thanks on behalf of the organizing team of ISA MRE 2025. As we come to the end of this wonderful event, I would like to express our sincere gratitude to everyone who has contributed to its success. I would like to start by thanking our esteemed chief guests, panel speakers, invited speakers for their insightful and engaging presentations. Your expertise and willingness to share your knowledge with us are greatly appreciated. I would like to thank the students, delegates, the attendees from the industry, scientists for their presence and participation, making this event a success. Next, I would like to thank the press, the computer team, the estate and maintenance, the finance and accounts for contributing to make this event a grand success. A special thank you goes to the organizing team led by the director and Dr. Purnima Jalihal and the EFW team for their tireless efforts in planning and executing this event. The EFW team dedication and hard work have made this event a reality. And then thank you all once again for all your contribution. We hope you enjoyed this event and that you will be joining us for the future gatherings. Thank you.
Thank you, sir. With that, we officially conclude the valedictory function of this symposium. Let us all rise for the national anthem. Thank you all once again for being a part of this symposium. Wishing you all a safe journey back home and continued success in your endeavors. We will join now for high tea in Manthan Hall. Thank you very much.